네, 잠시 후 10분 뒤엔 오전 10시부터 제2회 CWR 국제 심포지움이 시작할 예정입니다. 네, 이제 복도에 계신 분들, 또 장내에 계신 분들께서는 자리를 정돈하시고 착석해 주시면 감사하겠습니다. 잠시 후 오전 10시부터 저희는 제2회 CWR 국제 심포지움을 시작할 예정입니다. 바깥 복도 쪽에 계신 분들과 장내에 계신 분들께서는요, 이제 자리를 정돈하시고 착석해 주시면 감사하겠습니다. 아울러 여러분의 휴대폰이 무음 또는 진동인지도 다시 한번 확인해 주시면 감사하겠습니다. 정말 귀하게 마련된 오늘 이 시간, 제2회 CWR 국제 심포지움인 만큼 적어도 이 시간만큼은 여러분의 휴대폰보다는 무대 위의 시간에 집중해 주시면 더욱더 감사할 것 같습니다. 네, 조금 뒤 오전 10시에 뵙겠습니다. 네, 잠시 후 5분 뒤인 오전 10시부터 제2회 CWR 국제 심포지움이 시작할 예정입니다. 네, 이제 복도에 계신 분들 또 장내에 계신 분들께서는 각자 자리를 정돈하시고 착석해 주시면 감사하겠습니다. 아울러 여러분의 휴대폰이 무음 또는 진동인지도 다시 한번 확인해 주시면 감사하겠습니다. 오늘 행사 더욱더 귀하게 또 여러분의 집중 가운데서 진행될 수 있도록 여러분의 휴대폰이 무음 또는 진동인지 다시 한번 확인해 주시고요. 이제 곧 5분 뒤에 시작할 제2회 CWR 국제 심포지움을 위해서 자리를 정돈하시고 착석해 주시면 감사하겠습니다. 네, 잠시 안내 말씀드리겠습니다. 이제 잠시 후 3분 뒤 오전 10시부터 제2회 CWR 국제 심포지움 행사가 시작할 예정입니다. 장내에 계신 분들과 복도 쪽에 계신 분들께서는 이제 각자 자리를 정돈하시고 착석해 주시면 감사하겠습니다. 아울러 여러분의 휴대폰이 무음 또는 진동인지도 다시 한번 확인해 주시길 바라겠습니다. 오늘 행사는 해외 연사자와 국내 참석자가 함께하는 국제 행사입니다. 앞쪽에 위치한 QR코드를 통해서 AI 통역 서비스를 이용해 주시면 감사하겠습니다. 전면에 있는 전광판에서도 실시간 통역이 송출되겠고요. QR코드를 이용하시면 각자의 핸드폰으로도 확인하실 수 있습니다. 네, 번역 언어 설정은 접속창 하단을 통해서 변경할 수 있겠고요. 보안 관계로 장내 공용 와이파이는 제공되지 않는다는 점 확인해 주시면 감사하겠습니다. 아울러 오늘 심포지움은 한국수목원 정원관리원 공식 유튜브 채널을 통해서 온라인 생중계되고 있습니다. 온라인으로 함께하시는 분들께서는 접속하신 네트워크 환경에 따라 끊김 현상, 음성과 영상 속도의 차이가 발생할 수 있다는 점 양해 부탁드리겠습니다. 네, 이제 잠시 후 오전 10시부터 잠시 후 행사가 시작할 예정입니다. 장내에 계신 분들께서는 이제 자리에 착석해 주시면 감사하겠습니다. 아울러 QR코드를 통해서 통역을 사용할 수 있다는 점, 그리고 한국수목원 정원관리원 공식 유튜브 채널을 통해서 온라인 생중계되고 있다는 점 확인해 주시면 감사하겠습니다. 네, 그럼 정식으로 인사를 드리도록 하겠습니다. 안녕하세요. 저는 오늘 사회를 맡은 아나운서 조윤하입니다. 네, 바쁘신 일정에도 불구하고 오늘 이 제2회 CWR CWR 국제 심포지엄에 함께해 주신 내외 귀빈 여러분, 또 국내외 연사 및 참석자 여러분께 진심으로 감사의 마음을 전해봅니다. 오늘 이 심포지엄은 글로벌 정책과 과학의 만남, 지속 가능한 미래를 위한 동행을 주제로 개최되겠습니다. CWR, 즉 산림내 작물 재래 원종은 기후위기와 식량 안보의 시대에 매우 중요한 유전 자원입니다. 오늘 이 자리는 CWR의 보전과 지속 가능한 활용을 위해 국제정책 동향과 연구 성과를 공유하고 또 한국의 전략과 협력 방향을 논의하기 위해 이렇게 마련되었습니다. 시작에 앞서서 진행 순서를 먼저 간략히 안내드리겠습니다. 먼저 오늘 오전에는 개회식과 국제기구의 역할에 대한 발표가 진행되겠습니다. 이어서 오후에는 CWR 보전과 이용을 위한 글로벌 협력 및 정책 동향 공유에 대해서 국가 CWR 보전 전략, 식물원 기반 보전이 발표가 이어지겠습니다. 다음으로 이어지는 순서는 연구 분야인데요. CWR 연구 발전사 및 형질 연구 방법 소개에 관해 미래의 작물 재래 원종, 또 베트남의 CWR 유래 벼 활용 사례, 그리고 한국 CWR 보전과 협력 성과 발표가 이어지겠습니다. 네, 그리고 마지막 순서로는 글로벌 정책 안에서 지속 가능한 활용을 위한 한국의 CWR 전략을 주제로 패널 토론이 진행되겠습니다. 네, 그럼 지금부터 제2회 CWR 국제 심포지엄을 여러분의 큰 박수와 함께 시작하겠습니다. 큰 박수 부탁드립니다. 네, 국제 행사인 관계로 국민 의례는 생략하도록 하겠습니다. 네, 먼저 귀한 걸음 해주신 내외 귀빈 여러분들을 소개하는 것으로 오늘 행사를 시작하겠습니다. 네, 한 분 한 분 소개해 드릴 때마다 따뜻한 박수 부탁드리겠습니다. 이상익 산림산업정책국장님 참석하셨습니다. 따뜻한 박수 부탁드리겠습니다. 마리오 마리노 국제연합 식량농업기구 FAO ITP GRFA 기술총괄님 참석하셨습니다. 힐데엘린 호란 크라메르 주한 노르웨이 대사관 참석관님 참석하셨습니다. 칼리 코엘 세계 식물원 보전연맹 사무총장님 참석하셨습니다. 나이젤 맥스티드 버밍엄 대학 교수 및 국제 자연보전연맹 의장님 참석하셨습니다. 노암 하유트 존 이네스 센터 수석 연구원님 참석하셨습니다. 응우옌 흐울러의 건터 대학교 메콩 연구소 책임 연구원님 참석하셨습니다. 조호성 대통령 직속 국가과학기술자문회의 바이오제도 농림수산전문위원회 위원장님 참석하셨습니다. 최무열 한국임업진흥원 원장님 참석하셨습니다. 최경 국립수목원 원장님 참석하셨습니다. 정규영 국립경북대학교 교수님 참석하셨습니다. 심상택 한국수목원 정원관리원 이사장님 참석하셨습니다. 네, 마지막으로 이번 국제심포지엄 개최를 위해 힘써주신 산림청 및 한국임업진흥원 또 한국수목원 정원관리원 관계자분들 함께해 주셨습니다. 따뜻한 박수 부탁드리겠습니다. 네, 이 밖에도 국립수목원, 한국연구재단, 대학교, 아프코 코아기, 아시아 발족을 위해 먼 걸음 해주신 12개국 대표단 여러분까지 함께해 주신 모든 참석자 여러분께 다시 한번 서로에게 따뜻한 박수 부탁드리겠습니다. 네, 시간 관계상 여기에 오신 모든 분들을 한 분 한 분 소개해드리지 못하는 점 정말 양해 부탁드리겠습니다. 네, 그러면 이어서 대회사가 있겠습니다. 먼저 임하수 산림청 차장님을 대신해서 이상익 산림청 산림산업정책국장님께서 대회사를 진행해 주시겠습니다. 여러분 큰 박수 부탁드리겠습니다.
예, 여러분 반갑습니다. 먼저 사회자 분께서 간단하게 소개 말씀드렸는데 당초 이 자리에 이제 산림청 차장님께서 참여하셔서 같이 의미 있는 시간을 갖기로 했는데 아시다시피 어제 오늘 좀 전국적으로 비가 많이 내렸습니다. 그러다 보니까 좀 크고 작은 사고가 나서 차장님이 본의 아니게 지금 산림청 본청에서 현장 대응을 위해서 지금 긴급 대응인 상황입니다. 그래서 이 자리에 함께 하지 못한 거 먼저 양해 말씀드리겠습니다. 그럼 이어서 준비한 환영사 같이 하도록 하겠습니다. 존경하는 국내외 귀빈 여러분, 그리고 세계 각국에서 이 자리를 빛내주신 정책, 학계 및 국제기구 관계자 여러분, 반갑습니다. 산림청 산림산업정책국장 이상익입니다. 먼저 작년에 이어 제2회 산림내 작물 재래 원종 국제 심포지움을 성황리에 개최하게 되어 매우 뜻깊게 생각하며 바쁜 일정 중에도 이 행사에 참석해 주신 여러분께 깊이 감사드립니다. 특히 오늘 이 뜻깊은 자리를 빛내주시기 위해서 국가과학기술자문위원회 바이오 제조 농림수산 전문위원회 조호성 위원장님, 그리고 국제연합 식량농업기구 마리오 마리노 기술총괄관님, 주한 노르웨이 대사관 힐데열렌 호르난 크란메르 참사관님, 세계식물보존연맹 칼리코엘 사무총장님, 국제자연보존연맹 날겔 맥스 교수님, 존 이네스 센터 노암 차유 수석연구원님, 켄터대학교 메콩연구소 응우엔후 로이 책임연구원을 비롯한 기빈 여러분께 깊은 감사의 말씀을 드립니다. 지난해 국제 심포지엄에 대한민국의 산림내 작물 재래 원종의 국제 공동 연구의 협력을 첫걸음을 떼는 자리였다면 올해 심포지엄은 글로벌 정책과 과학의 만남이라는 주제 아래 한 차원 높은 연구 협력과 실질적인 정책 실행 체계를 논의하는 소통의 장이 될 것입니다. 오늘날 우리는 기후 변화로 인해 생태계 파괴, 생물 다양성 감소, 그리고 이로 인한 식량 안보 위기라는 복합적인 도전에 직면해 있습니다. 이런 전 지구적 위기 속에서 산림에서 자생하는 작물 재래 원종은 인류의 생존과 식량 주권을 지켜낼 핵심 자산으로 그 중요성이 날로 부각되고 있습니다. 이번 국제 심포지엄의 슬로건인 Seed to Table처럼 산림 내 작물 재래 원종의 체계적인 보존과 지혜로운 활용은 기후재난 시대의 식량 주권을 확보하는 실질적인 대책일 것입니다. 따라서 이번 심포지엄은 단순한 논의를 넘어 기후 위기에 공동으로 대응하고 구체적인 실행력을 확보하는 글로벌 융합의 장이 되길 바랍니다. 여러분의 깊이 있는 고견이 모여 전 세계가 공감할 수 있는 정책적 대안이 마련되길 기대합니다. 대한민국 산림청은 앞으로도 산림 내 작물 재래 원종의 보존과 활용 연구를 지속적으로 지원할 것입니다. 특히 호라이즌 유럽과 같은 국제 공동 연구에 적극적으로 참여하여 미래 식량 안보 확보와 생물 다양성 보존 가치를 실현하는 데 앞장서겠습니다. 다시 한번 귀한 시간을 내어 참석해 주신 모든 분들께 감사 말씀드립니다. 이번 심포지엄이 인류의 지속 가능한 미래를 밝힐 의미 있는 협력의 시작점이 되길 기원합니다. 예, 감사합니다.
네, 귀한 말씀 감사합니다. 네, 말씀해 주신 것처럼 오늘 참 비가 많이 내렸는데요. 그럼에도 불구하고 이 자리에 어렵게 함께해 주신 모든 분들 다시 한번 감사의 마음을 전해봅니다. 또 말씀해 주신 것처럼 기후위기와 식량 안보 위기 속에서 산림 내 작물 재래 원종의 보존과 활용이 얼마나 중요한 과제인지, 또 국제적 협력과 실천적 정책으로 이어져야 한다는 점도 다시 한번 되새길 수 있었습니다. 뜻깊은 말씀 다시 한번 감사드립니다. 이어서 심상택 한국수목원 정원관리원 이사장님의 환영사가 있겠습니다. 네, 이사장님을 따뜻한 박수와 함께 무대 위로 모시겠습니다.
네, 여러분 반갑습니다. 소개받은 한국수목원 정원관리원 이사장 심상택입니다. 바쁘신 일정에도 제2회 산림내 작물 재래원종 국제 심포지엄 참석을 위해 국립세종수목원을 방문해 주신 참석자 여러분을 진심으로 환영하며 감사의 말씀을 드립니다. 특히 오늘 행사를 주최해 주신 산림청 이상익 산림산업정책국장님, 그리고 한국임업진흥원 최무열 원장님께 감사의 말씀을 드립니다. 아울러 오늘 행사를 빛내주시기 위해 참석해 주신 주한 노르웨이 대사관 힐데엘린 할란드 크라머 참사관님, 국가과학기술자문위원회 바이오제조 농림수산전문위원회 조호성 위원장님께도 감사의 말씀을 드립니다. 또한 해외에서 한국을 찾아주신 FAO 마리오 마리노 기술 담당관님, BGCI 칼리코웰 사무총장님, IUCN CWR 스페셜리스트 그룹 공동의장을 맡고 계신 나이젤 맥스테드 버밍엄 대학교 교수님, 존 이네스 센터 노암차유 박사님, 건트 대학교 메콩 연구소 응우엔 후 로이 연구원님, 그리고 CWR 워킹그룹 각국의 관계자 여러분 등을 비롯해서 멀리서 참석해 주신 여러분들께 깊은 감사의 말씀을 드립니다. 이 밖에도 한국연구재단 실장님을 비롯해서 함께해 주신 국내외 관련 기관의 참석자 여러분들께도 감사의 말씀을 드립니다. 이번 행사의 주관기관인 한국수목원 정원관리원은 국가식물자원의 체계적인 보존과 지속 가능한 활용을 위해 노력하고 있습니다. 특히 국립백두대간 수목원의 글로벌 시드볼트와 시드뱅크 운영을 중심으로 야생식물 유전자원 수집, 보존 및 관리, 생물다양성 보존과 증진, 국제협력 확대를 위한 노력을 중점적으로 하고 있습니다. 지난해 제1회 CWR 국제심포지엄을 성공적으로 개최한 데 이어 올해 다시 세계 각국의 전문가 여러분과 함께 뜻깊은 논의를 이어가게 되어 매우 기쁘게 생각합니다. 어제 우리는 산림내 작물 재래 원정의 중요성 인식을 하기 위한 워킹그룹 회의도 함께 했었습니다. 이제 이를 어떻게 보존하고 활용할 것인지에 대한 실질적인 협력 방안을 함께 모색할 시점이라고 생각합니다. 오늘 심포지엄을 통해서 세계 각국의 정책과 과학적 성과를 공유하고 실질적인 국제협력 기반을 넓힘으로써 한국의 산림내 작물 재래원종 보존 전략이 한 단계 발전하는 의미 있는 성과를 기대합니다. 한국수목원 정원관리원은 앞으로도 식물 유전자원의 체계적인 보존과 지속 가능한 활용을 위해 노력해 나갈 것입니다. 작은 종자에서 시작된 가능성이 지속 가능한 미래의 밑거름이 되기를 희망합니다. 다시 한번 참석자 여러분들께 감사드리며 행사 기간 동안 유익하고 뜻깊은 시간이 되시길 바랍니다. 감사합니다.
네, 따뜻한 말씀 감사합니다. 네, 말씀해 주신 것처럼 이 작은 종자에서의 가능성이 자라나갈 미래가 더욱더 기대가 됩니다. 네, 한국수목원 정원관리원 이사장님의 환영사였습니다. 다시 한번 따뜻한 박수 부탁드리겠습니다. 네, 이어서 다음은 최무열 한국임업진흥원장님의 인사 말씀이 있겠습니다. 원장님을 따뜻한 박수와 함께 무대 위로 모시겠습니다.
반갑습니다. 한국임업진흥원장 최무열입니다. 먼저 제2회 KCWR 산림내 작물 재래 원종 심포지엄을 개최를 진심으로 축하드립니다. 이번 심포지엄은 산림내 작물 재래 원종의 미래 가치를 함께 모색하고 국내외 연구자 및 산업과 정책 관계자들이 지식과 경험을 공유하며 국제협력 기반을 넓혀가는 매우 뜻깊은 자리입니다. 산림내 작물 재래 원종은 오랜 시간 다양한 자연 경과 환경에 적응하면서 가뭄과 병해충, 기후변화 등 여러 환경적 위협을 견뎌온 소중한 유전 자원입니다. 이는 단순히 보존해야 할 야생 식물에 그치지 않고 나아가 식량과 의약품, 화장품, 또한 여러 산업에 비롯한 산림 바이오 산업의 새로운 가치 창출을 할 수 있는 중요한 국가적 자원이기도 합니다. 특히 기후재난이 심화되고 생물 다양성의 중요성이 커지고 있는 요즘 기후변화에 강한 품종을 개발하고 지속가능한 산림 생태계를 조성하기 위해 다양한 유전적 특성을 가진 자원을 체계적으로 발굴하고 보존하며 활용해야 합니다. 이제는 연구와 기술, 산업과 정책을 유기적으로 연계해서 산림 자원을 기반으로 한 그린 바이오 산업의 미래를 본격적으로 열어갈 때입니다. 오늘 국내외 전문가 여러분께서 나누어 주실 지식과 경험은 작물 재래 원종의 미래 가치를 재조명하고 산림 부분의 보존과 지속 가능한 활용을 통한 미래 산업으로 도약하는 중요한 밑거름이 될 것입니다. 한국임업진흥원은 산림과 임업의 지속 가능한 발전을 지원하고 산림 자원의 산업적, 사회적 가치를 확산하는 전문 기관으로서 산림 재래 원종과 관련한 산림 과학 기술의 연구 성과가 연구실에만 머무르는 것이 아닌 임업 현장과 기업의 기술 개발 그리고 국민이 체감할 수 있는 산업적 성과로 이어질 수 있도록 적극 지원하겠습니다. 오늘 이 자리가 산림 생물 자원의 보존과 활용을 한 단계 발전시키고 지속 가능한 산림 바이오 산업의 미래를 열어가는 소중한 출발점과 도약의 기회가 되기를 바랍니다. 아울러 행사를 준비하신 모든 관계자 여러분의 노고에 감사드리고 참석하신 모든 분들의 건강과 행복을 기원합니다. 감사합니다.
네, 귀한 말씀 감사합니다. 말씀해 주신 것처럼 연구와 기술, 또 정책, 산업을 연결해서 나아가는 그린 바이오 산업이 앞으로 정말 기대가 되는 그런 말씀이었습니다. 다음 순서는 오늘 심포지엄을 축하해 주시기 위해 참석하신 주요 내빈분들의 축사가 이어지겠습니다. 먼저 국제연합 식량농업기구 FAO ITP GRFA의 마리오 마리노 기술총괄님의 축사가 있겠습니다. 네, 마리오 마리노님을 무대 위로 모시겠습니다. 여러분 큰 박수 부탁드리겠습니다.
Thank you. Thank you very much for inviting the Secretariat of the International Treaty on Plant Genetic Resources for Food and Agriculture to this important international symposium on crop-wide relatives, and in particular for giving me the floor. I would like to express my sincere appreciation to the Deputy Minister Lim Mao-su of the Korea Forest Service, President Choi Moo-il of the Korea Forest Promotion Institute, and obviously the President of the Korea Arboreta Garden Institute, Chairman Shim Sang-taek, for their leadership and support in organizing this event. I want to also thank to the organizers, all the people working here, because this has been a very hard work for each and everyone, in particular for the Institute, and for their contributions to the symposium. Distinguished colleagues, ladies and gentlemen, it's a great pleasure to join you today to reflect on the role of the crop-aware relatives in shaping more resilient and sustainable agri-food system. Crop-aware relatives are not only objects of conservation, they are strategic resources for the future. This morning we had a breakfast, an interesting breakfast all together, and we taste the crop-aware relatives. In particular for us that we are spending a life on genetic resources, it was a great opportunity. They represent, in fact, an invaluable reservoir of genetic traits that can support adaptation to changing environments, strengthen resistance to pests and diseases, and contribute to the diversification of a production system. Their potential is essential if we want to develop crops that can perform under the complex and evolving conditions faced by farmers worldwide. The FAO's International Treaty on Plant Genetic Resources for Food and Agriculture provides a global policy framework to support this effort. Its scope covers all plant genetic resources for food and agriculture, including crop wild relatives and wild plant species, when they have actual or potential value for food and agriculture. By bringing together conservation, sustainable use, and facilitated access, the treaty supports international cooperation and recognizes the interdependence of countries in safeguarding and using plant genetic diversity. At the same time, global assessment continue to show that important challenges remain. In many cases, crop-aware relatives are still insufficiently documented. Our collective task is not only to recognize the importance of CWR, but to ensure that they are systematically documented, effectively conserved, and used in a sustainable way. This is quite relevant and important, and in particular to made available for their use. This conference aims to make awareness on the relevance of the CWR, exchanging point of views and experiences at national and international level. We need to move from awareness to action, and from conservation alone to the active use of diversity in building climate-resilient agri-food system. My sincere thanks for the invitation. Thank you very much.
네, 귀한 말씀 감사합니다. 네, 작물 재래 원종이 미래 식량 안보와 기후 변화 대응을 위한 전략적 유전 자원이고 또 보존에서 활용으로 나아가야 한다는 점을 분명히 짚어주셨습니다. 네, 이어서 다음은 주한 노르웨이 대사관의 힐데엘린 호란 크라메르 참사관님께서 노르웨이 대사님의 축사를 대독해 주시겠습니다. 참사관님을 무대 위로 모시겠습니다. 여러분 따뜻한 박수 부탁드립니다.
안녕하세요. Distinguished representatives of the Korean Forest Service, KOAGI, Korean Forestry Promotion Institute, researchers and experts. It's a great pleasure to join you today at this second Crop Wild Relatives International Symposium. On behalf of the Norwegian Embassy in Seoul, I would like to thank the organizers for the invitation and congratulate you on bringing together such an important group of experts and institutions. This symposium addresses a central question of our time: how we safeguard the biological diversity that future food system will depend on. Crop wild relatives carry traits that can help crops tolerate heat, drought, pests, diseases, and changing growing conditions. In a world marked by climate changes and pressure on food systems, this genetic diversity is part of our shared preparedness. South Korea has shown clear leadership in this field. Korea has placed crop wild relatives and wild plants seed conservation firmly on the international agenda. The work being done here combines science, infrastructure, field knowledge, and international cooperation. From a Norwegian perspective, the conservation and sustainable use of plant genetic resources is closely linked to food security, climate adaptation, and international solidarity. No country can secure the genetic basis of future food production alone. Norway's engagement is based on a simple principle. Crop diversity is a global public good. It must be conserved for the long term and made available in responsible ways for research, breeding, and food production. The Svalbard Global Seed Vault is perhaps the most visible expression of this commitment. Located in the Arctic, it provides safe, free, and long-term storage of duplicate seed samples from gene banks around the world. It is not a replacement for national and regional gene banks, it's a backup, a global safety net for collection that remains the property and responsibility of the institutions that deposit them. It helps ensure that if collections are lost through natural disasters, conflict, technical failures, or other crises, they can be restored. In that sense, the Seed Vault is both a practical facility and a symbol of trust. And as of last month, 1.4 million seeds have actually been deposited so far. Crop wild relatives are not only resources to be preserved in storage, they are also living genetics resources that can contribute to more resilient agriculture. This is why today's symposium is so timely. It brings together those who know plants in the field, those who conserve seeds, those who generate data, and those who breed future crops, and those who shape policy. It is also reminds us that biodiversity conservation is not separated from climate policy, agriculture policy, or development policy. It is part of all of them. Let me end by congratulating the organizers once again. Your work is practical, scientific, and forward-looking. By conserving crop wild relatives today, we are keeping options open for tomorrow. On behalf of the Norwegian Embassy, I wish you a successful symposium and a fruitful discussion, and I really look forward to learning a lot today. 감사합니다.
네, 조한 노르웨이 대사님 메시지를 전해주셨습니다. 다시 한번 정말 감사의 마음을 전해봅니다. 작물 재래 원종 보전이 식량 안보와 기후변화 대응 그리고 국제적 연대와 직결 등 과제임을 확인할 수 있는 그런 말씀을 해주셨고요. 특히 스발바르 글로벌 시드볼트와 볼드 프로젝트 사례를 통해서 보전에서 활용으로 이어지는 협력의 중요성 또한 함께 생각해 볼 수 있는 기회의 시간이었습니다. 다음은 세계식물원 보전연맹의 칼리 코엘 사무총장님의 축사가 있겠습니다. 사무총장님을 무대 위로 모시겠습니다. 여러분 따뜻한 박수 부탁드리겠습니다.
Good morning, colleagues, guests, and friends. Welcome to the second International Crop Wild Relative Symposium. On behalf of Botanic Gardens Conservation International, it's a great pleasure and privilege to congratulate Coagi, the Korean Forest Services, and all the partners involved in organizing this important symposium. Botanic Gardens Conservation International is an NGO headquartered in the United Kingdom. We connect botanic gardens and botanical institutions worldwide with a global network dedicated to plant conservation. BGCI is proud to support initiatives that strengthen collaboration between the biodiversity sector and the agricultural sectors, and that bring together science, policy, and practice. Crop wild relatives are among the most valuable and yet underutilized natural resources. They contain the genetic diversity needed to develop crops that are more resilient to pests, diseases, climate change, and environmental stresses. Conserving these species is therefore fundamental, not only to biodiversity conservation, but also for food security, sustainable agriculture, and the livelihoods of future generations. This second International Crop Wild Relative Symposium provides a timely and important platform for researchers, conservation practitioners, gene banks, botanic gardens, arboreta, governments, and local communities to come together, exchange knowledge, and share experiences and build new partnerships. By strengthening collaboration across sectors and regions, this symposium can help accelerate conservation action. We need to improve access to genetic resources and ensure that crop wild relatives continue to contribute to resilient and productive food systems. This gathering also aligns closely with many global commitments, such as the Kunming Montreal Global Biodiversity Framework and the Global Strategy for Plant Conservation, as well as other international efforts to conserve genetic diversity for food and agriculture. Congratulations once again on this important milestone, and I do wish the second International Crop Wild Relative Symposium every success, and I look forward to seeing the partnerships, the innovations, and the conservation actions that emerge from this meeting and contribute to securing crop diversity and food security for the future. Thank you.
네, 귀한 축사 감사드립니다. CWR 작물 재래 원종이 생물 다양성 보전과 식량 안보를 위한 핵심 자원이고 또 연구기관과 식물원, 유전자원, 은행, 정부가 함께 협력해야 한다는 점을 다시 한번 확인시켜 주신 시간이었습니다. 네, 이어서 국내 생물자원, 농수림수산 분야를 대표해서 참석해 주신 연사분들의 축사가 이어질 텐데요. 조호성 대통령 직속 국가과학기술자문회의 바이오제조 농림수산전문위원회 위원장님의 축사가 있겠습니다. 여러분 큰 박수 부탁드리겠습니다.
네, 안녕하십니까. 존경하는 국내 기빈 및 전문가 여러분, 그리고 이 자리에 함께해 주신 모든 참석자 여러분 반갑습니다. 국가과학기술자문회의 바이오제조 농림수산전문위원회 위원장 조호성입니다. 작년에 이어서 올해도 축사를 하게 돼서 감회가 남다릅니다. 먼저 글로벌 정책과 과학의 만남, 지속가능한 미래를 위한 동행을 주제로 개최되는 제2회 산림내 작물 재래 원종 국제 심포지움의 개최를 진심으로 축하드리며 뜻깊은 국제 심포지움을 마련해 주신 산림청과 국립인문진흥원, 한국수목원정원관리원을 비롯한 모든 관계자 여러분의 노고에 깊이 감사드립니다. 오늘날 기후변화와 생물 다양성 감소, 식량 안보 위협은 어느 한 국가만의 노력으로 해결할 수 없는 전 지구적 과제가 되었습니다. 이러한 시대적 흐름 속에서 CWR은 기후변화와 병해충, 다양한 환경 스트레스에 대한 적응 유전자를 보유한 미래 식량 안보와 지속가능한 농업을 위한 핵심 유전자원으로 국제사회의 관심이 더욱 높아지고 있습니다. 이번 심포지움은 FAO 국제식물유전자원 조약을 비롯하여 세계식물원 보전연맹, 국제자연보전연맹 등 국내외 전문가들이 한자리에 모여 CWR의 보전과 활용을 위한 정책과 연구 성과를 공유하고 지속가능한 국제협력 방안을 함께 모색하는 매우 뜻깊은 자리입니다. 특히 이번 심포지움을 계기로 아시아 CWR 워킹그룹이 공식 출범하게 된 것은 매우 뜻깊은 일이라고 생각합니다. 이는 아시아 각국이 CWR의 보전과 활용을 위해 지식과 경험을 공유하고 공동 연구와 정책 협력을 확대해 나가는 새로운 출발점이 될 것입니다. 우리나라가 이러한 국제협력의 중심에서 미래 식량 안보와 생물 다양성 보전을 위한 아시아 협력 체계를 함께 이끌어가기를 기대합니다. 국가과학기술자문회의 바이오제조 농림수산전문위원회는 화이트바이오와 그린바이오 분야의 국가 연구개발 투자 방향을 제시하고 미래 핵심 기술과 전략 분야를 발굴하는 역할을 수행하고 있습니다. 특히 산림 생명자원을 활용한 그린바이오 기술은 기후위기 대응과 지속가능한 농업, 생물산업의 경쟁력 확보를 위한 핵심 분야인 만큼 CWR의 보전과 활용을 위한 연구개발과 국제협력이 지속적으로 활대될 수 있도록 정책적 관심과 연구개발 기반 마련에 최선을 다하겠습니다. 오늘 이 심포지움에서 공유되는 다양한 정책과 연구 성과가 대한민국의 CWR 국가 보전 전략을 한층 발전시키고 우리나라가 산림 생명 자연과 CWR 분야의 글로벌 협력을 선도하는 중요한 전환점이 되기를 기대합니다. 다시 한번 이 심포지엄 개최를 진심으로 축하드리며 함께해 주신 모든 여러분들의 건강과 건승을 기원합니다. 감사합니다.
네, 귀한 축사 감사드립니다. 정책과 과학기술의 연계를 통해서 CW에 관한 국제협력을 확대해야 한다는 귀한 방향을 또 제안해 주셨습니다. 네, 이어지는 순서는 이번 심포지엄을 축하하며 김호 농업촌특별위원회 위원장님께서 영상으로 격려의 말씀을 보내주셨습니다. 네, 위원장님의 격려사 영상을 함께 보시죠.
안녕하십니까. 대통령 직속 농업촌특별위원회 위원장 김호입니다. 인류의 지속가능한 미래를 도모하는 2026년 제2회 CWR 국제심포지엄 개최를 진심으로 축하드립니다. 뜻깊은 자리를 마련해 주신 산림청과 한국임업진흥원, 한국수목원 정원 관련 관계자 여러분, 그리고 멀리 해외에서 발걸음해 주신 세계적인 석학과 전문가 여러분을 뜨겁게 환영합니다. 오늘날 우리는 급격한 기후위기와 생물 다양성 감소라는 중대한 도전 과제에 직면해 있습니다. 이러한 환경 속에서 현재 우리가 먹는 식량의 기원이자 강인한 생명력을 지닌 산림 내 작물 재래 원종은 전 세계 식량 안보를 지켜낼 전략적 자산으로 주목받고 있습니다. 이번 심포지엄의 슬로건인 글로벌 정책과 과학의 만남처럼 이번 자리가 한국의 CWR 가치를 세계에 알리고 글로벌 협력을 통해 지속가능한 농임업의 미래를 여는 강력한 융합의 장이 되기를 기대합니다. 다시 한번 심포지엄 개최를 축하드립니다. 참석하신 모든 분들의 건강과 행복을 기원합니다. 감사합니다.
네, 과학과 정책의 협력을 통해 지속가능한 농업의 미래를 만들어가야 한다는 메시지를 전해주셨는데요. 격려의 말씀을 보내주신 것에 다시 한번 감사의 마음을 전해봅니다. 네, 이상으로 모든 축사 순서를 마치고요. 이제는 기념 촬영 순서를 가져보려고 합니다. 오늘 행사를 주관하고 주최해 주신 관계자분들부터 앞으로 먼저 모셔보도록 하겠습니다. 먼저 산림청 국장님, 또 한국임업진흥원 원장님, 한국수목원 정원관리원 이사장님 세 분께서는 앞으로 자리해 주시면 감사하겠습니다. 네, 오늘 귀하게 마련된 시간이니까요. 저희 한 분은 세 분 올라오셔서 다 같이 촬영 진행하도록 하겠습니다. 두 분만. 네. 저희 화이팅도 한번 할까요? 하나, 둘, 셋, 화이팅! 네, 이어서 잠시만 자리 계셔주시고요. 네, 이어서 다음으로는 오늘 행사에 축사를 해주신 내빈분들 및 심포지엄 발표자분들과 패널분들까지 단상 위로 모셔보겠습니다. FAO ITP 듀얼 FA의 마리오 마리노 기술 총괄님, 주한 노르웨이 대사관의 힐데일린 호란 크라메르 참사관님, IUCN의 나이델 맥스티드 교수님, BGCI의 칼리 코엘 사무총장님, 존 이네스 센터의 노암 하유트 수석 연구원님, 건터대학교 메콩연구소의 응우옌 흐울러의 책임 연구원님, 국가과학기술자문회의 바이오제조 농림수산전문위원회 조호성 위원장님, 한국수목원 정원관리원 나채선 실장님, 또 국립수목원 최경 원장님과 국립경북대학교 정규영 교수님 단상 위로 자리해 주시길 바라겠습니다. 네, please smile 웃어주시고요. And after, why don't we doing the like fighting pose? Fighting? Yeah. Like that. So I will take 3. 1, 2, 3. Fighting. Yes. Then how about we take like heart, like I love you, I love you, CWR International Symposium. Heart. 감사합니다. Thank you very much. 네, 이제 자리로 모두 돌아가 착석해 주시면 감사하겠습니다. 네, 이제 참석하신 모든 분들과 함께 사진을 찍는 시간을 가져볼 텐데요. 지금 이 자리에 계신 모든 분들께서는요, 소품을 아마 가지고 계실 거예요. 이렇게 타올처럼 생긴, 국립수목원에서 만든 이 타올처럼 생긴 소품을 가지고 계실 텐데요. 여기 이 가슴팍 정도에다가 이렇게 펼쳐주시고서 함께 촬영을 진행하도록 하겠습니다. 네, 적혀있는 문구는 이번 국제심포지엄 주제의 핵심인 Seat Table, 산림종자에서 피어난 우리의 식탁인데요. 이 촬영 시 잘 문구가 보일 수 있도록 정면을 향해 들어주시면 감사하겠습니다. 네, 앞면, 뒷면 모두 상관없습니다. And please having a smile because it's a really good day, right? Smile. 네, 감사합니다. Thank you very much. 그리고 지금부터는요, 저희 지금 40분인데요. 네, 50분까지 잠시 환기하는 시간을 가진 뒤에 발표를 시작하도록 하겠습니다. 또한 모든 발표에 대한 질의응답은 시간 관계상 패널 토론 때 부탁드리도록 하겠습니다. 이어지는 첫 번째 발표는 오전 10시 50분부터 시작되겠습니다. 발표가 시작되기 전까지는 통역 시스템과 자료집을 한 번씩 확인해 주시면 좋겠고요. 또 실시간 AI 통역은 전면에 있는 전광판을 확인해 주시거나 혹은 QR코드 통해서 직접 개인 핸드폰으로 확인할 수 있다는 점 참고해 주시면 좋겠습니다. 또 바깥으로 나가실 분들께서는요, 5분 전인 45분까지는 다시 입장해 주시길 바라겠습니다. 네, 그럼 잠시 후에 뵙겠습니다. 네, 잠시 후 오전 10시 50분, 잠시 후 3분 뒤인 오전 10시 50분부터 첫 번째 발표가 시작되겠습니다. 네, 장내에 계신 분들 또 복도에 계신 분들께서는 이제 자리를 정돈하시고 착석해 주시면 감사하겠습니다. 잠시 후 2분 뒤인 10시 50분부터 오늘의 첫 번째 발표가 시작할 예정입니다. 장내에 계신 분들께서는 이제 자리를 정돈하시고 착석해 주시면 감사하겠습니다. 네, 저희는 이제 바로 잠시 후에 제2회 CWR 국제 심포지엄 첫 번째 발표를 시작할 예정입니다. 네, 장내에 계신 분들께서는 이제 자리를 정돈하시고 착석해 주시길 바라겠습니다. 네, 잠시 후 오전 11시부터 제2회 CWR 국제 심포지엄 첫 번째 발표를 시작하겠습니다. 네, 조금만 다과 즐겨주시는 분들께서는요, 조금 더 즐겨주시다가 가지고 자리로 돌아와 주셔도 좋을 것 같습니다. 네, 이제 잠시 후 5분 뒤인 오전 11시부터 제2회 CWR 국제 심포지엄의 첫 번째 발표가 시작될 예정입니다. 장내에 계신 분들께서는 이제 자리를 정돈하시고 착석해 주시면 감사하겠습니다. 첫 번째 발표는 총 30분 정도 지속될 예정입니다. 네, 이제 저희는 잠시 후 오전 11시부터 제2회 CWR 국제 심포지엄의 첫 번째 발표를 시작하겠습니다. 장내에 계신 분들과 복도 쪽에 위치해 계신 분들께서는요, 이제 각자 자리를 정돈해 주시고 착석해 주시면 감사하겠습니다. 조금 뒤 첫 번째 발표가 시작될 예정입니다. 네, 이제 제2회 CWR 국제 심포지엄의 첫 번째 발표를 시작하겠습니다. CWR 보전과 이용을 위한 글로벌 협력 및 정책 동향 공유라는 대주제로 국제연합식량농업기구 FAO ITP 듀얼 FA의 마리오 마리노 기술 총괄님께서 진행해 주시겠습니다. 발표 주제는 다음과 같습니다. The role of ITPGRFA in facilitating the conservation and sustainable use of crop-wide relatives, bridging global policy and field-based practices. 네, CWR의 보전과 지속 가능한 이용을 촉진하기 위한 ITP, GRFA의 역할, 그리고 글로벌 정책과 현장 실천을 어떻게 연결할 것인지에 대해 얘기해 주실 예정입니다. 네, 마리오 마리노님 큰 박수로 맞이해 주시길 바라겠습니다.
Okay, thank you so much. This is the first presentation, and I hope that you are still awake, enough awake, for half an hour presentation. I mean, it's a long journey, to be honest. Almost 20 years in FAO and working on genetic resources for more or less 40 years now. It has been really relevant and important in my career, but in particular in biodiversity, when no one didn't know anything about biodiversity, about the relevance of sustainable use of plant genetic resources. It has been a very long journey, but thank you so much for this opportunity, because we are not just, showing our passion, but also we are showing you our work every day, and I hope that you can figure out the efforts we are making in everything. So I think it is work like this. Yes, we can start immediately with a few words about the international treaty. I'm not taking too much time about that, but just to let you know that the International Treaty on Plant Genetic Resources entered into force in 2001. In 2004, but was ratified at the conference in FAO in 2001. So we are talking about more or less 25 years in which the treaty is not an instrument that you can put in a drawer, but something still alive and very relevant for each and every one. The international treaty doesn't manage the seed banks directly. This is something that has to be clear, because many times we receive this kind of questions. But it provides the global policy architecture that helps countries, institutions, and communities conserve, access, and exchange and sustainable use crop diversity, including crop wild relatives. Its practical relevance lies in translating international commitments into national strategies through gene bank standards, facilitated access, benefit sharing, and capacity building and partnerships. The treaty provides also the legal and policy framework for conserving and use PGRFA, in particular through the conservation obligations that are under the Article 5 of the treaty, sustainable use measures under Article 6, facilitated access through the multilateral system, farmers' rights, global information system, international cooperation, capacity building, and information exchange. As you know, in the majority of the cases, when we presented the international treaty, we presented the treaty as a sort of, I would say, unique experience in the context of food security. And that is the reality, because the main objectives of the treaty is conservation, sustainable use, but also to provide all the instruments, all the tools to share the benefits derived from the use of the plant genetic resources. My presentation will be more or less organized in three different agenda items. The first one is about what FAO is doing on plant genetic resources. The second part should be focused on the multilateral system of the international treaty. And last but not least, we should mention also the global information system. So, here, the third State of the World on Plant Genetic Resources was published last year in 2025. It has been a very huge work collecting different, I would say, data around the world. The first one was published, and I'm looking to Nigel, on 1996, if I remember well. 1998. So I was a little bit, that's why I was looking at you, because I remember that you were also involved in the first one. And it was really a big effort made by FAO and useful for all different stakeholders at that time. I remember that the majority of the countries, when they ratified the treaty, took into account the first State of the World to take data and to provide additional inputs to the policymakers to decide if the treaty worthwhile or not. So here there are more or less 128 countries that were evaluated for conservation, sustainable use, and plant management and of plant genetic resources for food and agriculture. Here there is the first slide is about crop-aware relatives, some data. You will see in the next two slides the wild food plants and also the landraces varieties. But we can keep focusing on this for the time being. I mean, crop-aware relatives were surveyed and inventoried in 66 countries. These crop-aware relatives were represented by over 1,000 taxa from 142 genera. As you can see, about 1/3 of all these crop-aware relatives were found threatened at least once. And the piece shows for each region the percentage of crop-aware relatives found threatened out of these those inventoried. The larger the P, the greater the number of crop-aware relatives surveyed and inventoried. Sorry. Yes, now we have the wild food plants. I mean, you know better than me that wild food plants are edible wild species used for food. And that were reported in 54 countries. These wild food plants were represented by 400 taxa from 192 genera. About 40% of all these wild food plants were found threatened, and at least at once. A pattern like crop-aware relatives were observed for the percentage of the wild food plants in the regions, so it's more or less the same situation, but we are talking about different level of number. The farmers' varieties and landraces that were also inventoried, and we are talking about 70 countries worldwide, over 100,000 farmers' varieties and landraces from about 1,300 crops were reportedly assessed. Only 6% of these were found threatened. This was an historical, I have to say, data, because it seems that at least in the 17 countries reached by this work, and in particular the data we collected, only a minimum percentage were found threatened. Here there are in situ conservation of crop wild relatives and wild food plants. There are some data that I put just in case some of you are interested to have a look in a more specific way. What I would like to emphasize is also the on-farm management and improvement. Many farmers, as you know, continue to maintain and improve on-farm a significant amount of genetic diversity made of locally adapted traditional varieties and land races. Yesterday in the AFOCO meeting, we also suggested to consider to involve farmers in your work, and not only labs and institutions. So I think that this can be easily taken into account in the future of the AFOCO, but also in the future of the crop wild relatives activities for these institutions. Over 1,000 projects were implemented in 82 countries, about 37 million hectares that are equivalent of 45% of the total crop area of reported sites in 51 countries were cultivated with farmers' varieties and land races. So we are not talking about peanuts, we are talking about a large number of hectares, a large number of people, campesinos, working in this area of work. And there is also in the forestry a lot of work that farmers are doing in order to conserve, maintaining, but also to reproduce the genetic diversity, in particular food crops. In situ conservation and management, I mean, here there are the main gaps identified at the regional level consultations. There is a need to improve coordination among relevant ministries, in particular environment and agricultural ministries. With regard to the baselines, we lack information and regular monitoring on the status of diversity in situ and on farm. There was also, as a gaps, the linkages, the lack of the linkages with the national gene banks, for not only for farmers but even for other stakeholders. And there is a urgent need to address the lack of specialized, I would say, technical trained staff. For these reasons, I think that one of the most relevant work and partnership that we are having is with the Global Conservation Consortium for Food Plants. I think that this idea is I mean, take into account that there is a urgent need to address the lack of specialized and technical trained staff. The Global Conservation Consortium can play an active role to that. The consortium is coordinated by the New York Botanical Garden and developed under the Botanical Garden Conservation International. We have here Carly Cowell, and later on she will be a little bit more specific on that. Is co-funded by FAO Treaty, the Crop Trust, and the United States Botanical Garden to implement a comprehensive conservation strategies for priority food plants and their wild relatives. The initiative was officially launched last year at the 11th session of the governing body in Lima, in Peru. And it connects botanical gardens, agricultural gene banks, and other international treaty stakeholders from all corners of the globe to protect the planet. That was something that we needed. I think that there is a lot of potential work to do together with botanical gardens. You have just to imagine how many millions of people goes to visit botanic gardens. And just to have a totem with the international treaty, the relevance of food security, crop-wide relatives, activities of done by international organization, national implementation at different level, means practically something that you cannot reach in an entire life of work if you work in communication. So it's a huge opportunity, and thank you so much again, Carrie, for this work. So now the multilateral system, it seems that I have 15 minutes, so I'm perfectly on time. As I said before, in the context of the International Treaty on PGRFA, let me use the acronym. There is the multilateral system. It was established to give to all contracting parties, all the members of the treaty, the possibility to put in a big box material, genetic material, and to facilitate the access to this material. And in this way, not only to have the possibility to use this material for direct use by farmers, but also for training, capacity building, and breeding and research purposes. The report, we launched a report quite recently, 2 months ago. This is the first report over the past 18 years. So the period is from the 1st of January 2007 to 2025. And that was in response to a request made by the governing body in Lima, and we are trying to offer a structured and integrated analysis of data examining the multilateral system from different perspectives to better understand its practical functioning. In addition to detailed information on available materials and germplasm transfers, the report includes illustrative narratives that highlight the system's real-world relevance and impact. A key objective of this report is not only to enhance visibility, but to acknowledge the essential role played by gene banks, farmers, contracting parties, and other institutions in maintaining the flow of germplasm across borders. The objective is not only to present data, as said, but this information and the information contained is intended to sustain a broader dialogue and reflecting on the collective commitment to improving the multilateral system functionalities and long-term viability. So I think that if you have a look to the multilateral system, you can have, I would say, a good idea on having a look to this report. It's structured, the analysis is structured around the 3 core dimensions. The first chapter is about availability of PGRFA in the multilateral system. The second is the transfers of PGRFA. And the third one is the capacity development for multilateral system. Here are some key data to the global availability of PGRFA. This graph shows the current availability in the MLS. In total, we are talking about 2.6 million accessions that have been notified and available through the MLS. Something that we have to keep in mind, and this is, I would say, one of the most relevant and important agenda items that the government has to have to take into account, is not only to designate material, but to provide enough resources to their gene banks to regenerate the material. Because you can designate millions of accessions, but you don't have availability of the accessions, so the multilateral system cannot work. I'm saying that because we are here with the gene banks curators, professors, and so on. So it's important your work, but it's also important that you can give clear this message to the governments and receive financial resources in predictable way, by the way. These other, who makes this material available? What you see here is the breakdown of different providers, distinguishing between accessions available through the MLS in dark blue and accessions held under medium or long-term storage in the light blue. As you can see, not all conserved materials are included in the multilateral system. This might be because they fall outside the Annex 1. I'm not going into details, but we have 64 crops part of this multilateral system. So most probably they fall outside these 64 crops, are not in the public domain, are held by no contracting parties or have not yet been notified by contracting parties. Across all provider types, contracting parties remain primary contributors to the MLS. There are also other contributors, the CGR gene banks that have concluded agreements under Article 15 of the treaty, as well as the World Vegetable Center. The gene banks based in the region represented include Norgen, CATIE, ICBA, CEPACT, and SADC Plant Genetic Resources Centers, South African Developing Countries Resource Centers. The report contains a full breakdown of contribution by the individual institutions and regions. Here there is the availability of PGRFA under a multilateral system in the Asian region. As you can see, but you can have a look outside and you can easily understand that Asia is one of the primary regions of diversity for major Annex 1 crops. And the level of commitment of the contracting parties is, I would say, quite commendable in terms of designation of the material, but also in terms of taking actions on the ground for conservation and sustainable use of PGRFA. As you can see in the map, those are the, in the dark, there are the contracting parties, 17 contracting parties out of 25 members of countries. Number of countries, China and the entire bloc of ex-Russia is outside the international treaty. We are working quite hard with those countries, and we hope that they will become part of the international treaty. The sooner, the better. Last but not least, a few words about the global information system that integrates. It was conceived not as a new system, but an integration of existing system to create the global entry points to information and knowledge on PGRFA conservation, management, and utilization. This is one of the pillars of the international treaty. So once again, just for your consideration and your information, we have farmers' rights and conservation sustainable use is one of the pillars of the treaty. The second one is the multilateral system and the benefit sharing with the projects around the world. And last but not least, the global information system. So 3 pillars, and I hope that we are close in particular to accomplish the expectation of the contracting parties. This is a new structure in which you can have different sources of PGRFA, documentation, inventory, in particular about the farmers' rights, is the first global inventory in the world, and about how the farmers can sell, save, and use their own material. There is a toolbox for sustainable use of PGRFA. We started with Nigel and Sheila years ago, and now is a reality. More than 100,000 entries every year to the toolbox. Incredible. We couldn't expect something like that. You're right. You're right. But good ideas can become, collective ideas. Anyway, about the global information system, we have also produced passport descriptors, in particular about, as you can see, descriptors and guidelines to obtain digital objective identifiers. Korea, by the way, South Korea is one of the top 10 countries using, the DOIs. And we edited, but also published a descriptor for crop wild relatives. So this is quite important for the meeting today. There are also characterization and evaluation. What I would like to say here is, is about the DOIs for in situ material. And once again, I'm looking Nigel, who spent many years to FAO at different level in European Union and other international organizations, to try to not to convince, but to show the relevance of the in situ and on-farm conservation. And in this case, we have the purpose is to assign DOIs to in situ material to promote their visibility and availability, in particular for research, but also for use. And that was also what Nigel and Eshan Dulo presented in many articles. Sorry, Nigel, I'm looking at you many times, but we are working together for a long period of time. And so I think this is a tribute to our collective work. With that, I think I stop here. We have just 2 minutes remaining. I think I did my work in more or less 28 minutes. Thank you so much.
Thank you for the great presentation. 네, 좋은 발표 감사드립니다. FAO 국제조약의 역할과 또 다자간 접근 이익 공유 체계, 그리고 CWR 보전과 활용을 현장 실천으로 연결하는 국제협력의 중요성을 살펴볼 수 있는 시간이었습니다. 다시 한번 따뜻한 박수 부탁드리겠습니다. 네, 이렇게 해서 오전 일정이 모두 마무리되었습니다. 네, 이어서는 오찬과 함께 전시원 투어가 진행될 예정인데요. 오후 세션 발표는 오후 1시 30분부터 시작되겠습니다. 즉, 여러분의 점심시간 겸 휴식시간은 약 2시간 정도가 되겠죠. 명찰에 빨간색 스티커가 붙어있는 내빈 분들께서는요, 1층에 위치한 카트에 탑승해 주시면 되겠고요. 또 참석자 분들께서는 명찰에 포함된 식권을 지참하셔서 방문자 센터 1층 푸드코트에서 식권을 제출하신 후에 점심 식사를 하시면 되겠는데요. 이 식권을 못 찾는 분들도 있다고 하시더라고요. 이 명찰 사이에 식권이 끼워져 있다고 합니다. 명찰 사이에 끼워져 있는 식권을 한번 꼭 찾아봐 주시고요. 혹시 식권이 없거나 또는 찾는데 어려움이 있는 분들께서는 등록 데스크로 오셔서 확인해 주시면 감사하겠습니다. 네, 또한 이동 안내가 필요하신 분들께서는 주변 안내 요원에게도 문의해 주시면 감사하겠습니다. 식사와 전시원 투어는 2시간 동안 자유롭게 진행하시면 되겠고요. 또 이어서 온실 해설을 원하시는 분들께서는 오후 12시 50분까지 사계절 전시 온실로 모여주시면요 함께 진행한다고 합니다. 네, 그러면 맛있게 식사하시고요. 오후 시간에 다시 뵙도록 하겠습니다. 즐거운 점심시간 되세요. 감사합니다. 네, 잠시 후 10분 뒤인 오후 1시 30분부터 제2회 CWR 국제심포지움 오후 발표가 시작할 예정입니다. 잠시 후 10분 뒤인 오후 1시 30분부터 제2회 CWR 국제심포지움 오후 발표가 시작할 예정입니다. 네, 이제 10분 뒤면은 다시 우리 2부가 시작할 예정이니까요. 장내에 계신 분들 또 로비 쪽에 계신 분들께서는 자리를 정돈하시고 착석을 준비해 주시면 감사하겠습니다. 또 원활한 행사 진행을 위해서 휴대폰은 무음 또는 진동인지도 다시 한 번씩 확인해 주시면 감사하겠습니다. 네, 10분 뒤 1시 30분에 뵙겠습니다. 감사합니다. 네, 이제 잠시 후 오후 세션을 진행하도록 하겠습니다. 이제 조금 뒤 오후 세션을 진행할 예정입니다. 장내에 계신 분들과 복대에 계신 분들께서는 이제 자리를 정돈하시고 착석해 주시면 감사하겠습니다. 네, 또한 원활한 행사 진행을 위해서 휴대폰은 무음 또는 진동인지 다시 한번 확인해 주시면 감사하겠습니다. 네, 오후 시간에는요, 이제 5개의 발표가 진행될 예정인데요. 먼저 3개의 발표가 진행된 후에 저희는 잠시 쉬는 시간을 가질 것이고요. 이후에 2개의 발표 마무리를 하고 마무리로 패널 토론까지 진행한 뒤에 오늘 순서가 모두 종료되겠습니다. 네, 그럼 조금 뒤에 오후 세션이 시작될 예정이니 이제 자리를 정돈하시고 각자 자리에 착석해 주시면 감사하겠습니다. 네, 잠시 후 35분에 오늘 행사의 2부 행사가 시작할 예정입니다. 네, 저희는 잠시 후 35분부터 오늘 행사의 오후 세션을 진행하도록 하겠습니다. 장내에 계신 분들과 복도에 계신 분들께서는 이제 자리를 정돈하시고 착석해 주시면 감사하겠습니다. 네, 여러분 맛있는 점심시간 되셨을까요? 네, 이제 즐거운 네트워킹 시간과 편안한 쉼의 시간을 뒤로 하고 2부 세션을 시작해 보려고 합니다. 네, 2부에서는요, 총 5개의 발표가 이어지겠습니다. 첫 번째로는 3개의 발표가 이어지고요. 쉬는 시간을 잠시 가진 후에 2개의 발표, 마지막으로 패널들의 이제 패널 토론까지 이어진 뒤에 오늘 세션은 모두 종료되겠습니다. 네, 그럼 첫 순서로 국제자연보전연맹 IUCN SSC CWR 스페셜리스트 그룹 의장이시며 버밍엄 대학교 소속 나이젤 맥스터드 교수님께서 발표를 진행해 주시겠습니다. 발표 주제는 다음과 같은데요. Developing a practical strategy and action plan for national CWR conservation and use. 국가 차원의 CWR 보전과 활용 전략, 그리고 실행 계획 수립을 위한 실질적인 접근 방향에 대해서 말씀해 주시겠습니다. 네, 이미 나와 계시네요. 따뜻한 박수 부탁드리겠습니다.
Good. So, first of all, I should thank the organisers' meeting for inviting us as foreign experts. Foreign experts. Thank you. I shout. If it's too close, they'll have a headache. Okay, so sorry about that. So, it's a great pleasure to be here. And for someone who's worked on the conservation of crop wild relatives maybe for 40, 50 years, it's increasingly important that they are the fundamental basis of food security. So what we're talking about is really important. And when I was asked to give this presentation, they asked me to lay out how, if you were a country, Korea, Tajikistan, Bhutan, some other country in the region, how would you go about preparing a strategy, an action plan for conservation? So that's what I'm going to go through. And it's probably the simplest presentation you will see, because the presentation is this single slide. I'm only going to show one slide, and then I'm going to focus in on different elements of it. But basically, it's elements of the same slide. So we start off as a linear pattern, starting with total plant biodiversity over here, and then going through production of, working out which are the crop wild relatives, then prioritization, because usually you have a long list of crop wild relatives, prioritization, and then producing your inventory, and then once you have your inventory, gathering ecogeographic data. This is ecogeographic or genetic data that's available, that aids your formulation of your conservation strategy. Out of this step comes your conservation strategy, and then you apply your conservation techniques. So that's both in situ and ex situ. It's important that you do both. And then you lead into characterization of the conserved resource. So in other words, you've conserved it, it's adequately conserved, and the next step is to actually characterize it, evaluate it, and find out where are the adaptive genes that can be used by the breeding community. And associated with that is often pre-breeding. And I'll come back and explain why that is important later on. And then that leads into breeding. But each one of these, I have associated numbers and figures associated. So I'm going to come back and go through those one by one. So what I'm going to do now is focus on each separate element. So they're effectively, although it's one slide, I'm going to focus on each portion of the slide one by one. So the first is looking at total plant diversity. The figures for the total number of flora worldwide, this is from the State of the World's Plants report produced by Kew in 2016, 391,000 plants. So of those, a certain proportion are crop wild relatives, land races. So if we have this big circle as all plant diversity, then within that we have a large number of species which are affected by agriculture, maybe sometimes threatened by agriculture. And within that, we have a smaller circle, which are the ones that are actually used, the crops and the crop wild relatives, which are used as part of agrobiodiversity. So if you look at the bottom here, the elements that were included in this small element of agrobiodiversity are cropland races, crop wild relatives, obsolete varieties, so old varieties that are no longer currently available because maybe the resistance has broken down, pollinators, below fauna and fauna in the ground, and soil microorganisms. So those are the different elements at the bottom which make up agrobiodiversity. Right, the next step. If from that we want to work out which is the PGRFA, which was mentioned by Mario earlier, then we look at the global number of land races, and a guesstimate in a paper that's just coming out is we estimate about 10 million. Of all crops, 10 million, Mario, does that sound fair? It's a large number, and it's significantly more than crop wild relatives. But if we look at this paper produced by the Rice Association, for rice alone, we have 40,000 land races of rice, just for one species, one crop. And then if we look at crop wild relative taxa globally, the work that Mario was referring to earlier by Maxted and Kell was associated with a contract for FAO. We estimated in that between 50 and 60,000 crop wild relative taxa. Then we want to look at a definition of crop wild relatives. So it's all taxa. The broad definition, there are two definitions. The broad definition is all taxa within the same genus as a crop. So for instance, if we're looking at sugar beet, Beta vulgaris, subspecies vulgaris, then all the other species which are in the same genus are crop wild relatives by definition of sugar beet. And so you can then say that's a very broad definition. And this broad definition, so anything in the same genus as a crop is a crop wild relative, then that broad definition gives you crop wild relative diversity for your country. So if you're working in Korea, you can work out which are the crops that have wild relatives in your country because you know the genus name. So you can match the genus name against your floristic list and get a total list of all the crop wild relatives. So this is using this very general definition. A more precise definition would be given by using gene pool concepts. So gene pool concepts are where you're estimating how easy it is to cross the wild species with its related crop. And so you can use that more precise definition. The reason that I'm not focusing on that here is because we don't have gene pool concepts for all crops. It's only a limited number of the major crops that we have good gene pool definitions. But again, if you want to look at generic figures, if you look at the number of taxa, plant taxa in Europe, as an example, it's 40,900. And if you look at the number of crop wild relatives, it's 25,000. So if you take that figure, the difference between the total number of taxa and the number of crop wild relatives, about 60% of the flora are crop wild relatives. Now that holds. If you do the same analysis for Southern Africa, if you do the same analysis for Central America, it's always about 50-60%. So the first point I'm making is that crop wild relatives, there are a lot of them. We're not dealing with a trivial amount of species, so you will have to do some kind of prioritization. Next step, prioritization. So you have a large number of taxa. You can't conserve them all at once, so you have to narrow it down to the ones that are most important to you. And you do that using usually 3 main prioritizing criteria. So the crop importance, how important is the crop? And you can work that out from the data in FAO stat. The weather utilization potential, so whether what is in gene pool 1B, for instance, so it's the close wild relative or the tertiary gene pool, so you want to focus just on one gene pool or the other. But usually on 1B and gene pool 2 are the ones that are prioritized. And then threatened. If we're dealing with crop wild relatives, so you can use IUCN red list criteria for doing your analysis of threat, and highly threatened ones that are critically endangered or vulnerable would get a threatened status. And so all of these 3 criteria, you can work out digital scores, and you can score each of your crop wild relative checklist, and then the ones that have the highest scores are the ones you're then going to focus on in your much smaller data set for your inventory. So that's your prioritized inventory. The other thing I've mentioned here, that I've given you a reference to what Mario was talking about, a toolkit. This is not the same toolkit that Mario was talking about. This is a different one we've produced specifically for conservation planning of crop wild relatives. So this toolkit, which is freely available, you can download it from the internet, and this leads you through all this process, the whole process from the beginning, starting with the national flora, all the way through to having conserved crop wild relatives in genetic reserves. So this toolkit, as I say, you can use for going through all of these questions. Then once you've got your inventory taxa, so these are the most important crop wild relatives, then basically you need to gather your background data to do the analysis that's basis for your conservation. So it's usually we do what is called an ecogeographic study or survey. We collect background ecological, geographical, genetic, taxonomic information. We gather that information, we put it together, we synthesize it, and it's predictive. So for instance, if we're trying to conserve rice, wild relatives, then we don't start looking for them in South America because there's no record of rice wild relatives growing wild in South America. So we know that rice wild relatives grow in Southern Asia primarily, and if we're going to do conservation of them, this study will show us exactly where to look for them. And we have a one-by-one process here, step process, which is too detailed to go into here, But this is a way of doing this kind of analysis, and coming up right at the bottom here, and it's important to highlight this, is the whole of this process takes this ecogeographic data and finishes with identification of conservation priorities. So this is how we work out what are the conservation priorities. So if you have a checklist, an inventory of, say, 300 species that are your priority crop wild relatives of Tajikistan, then how do you know which ones to conserve? This will tell you. This process will tell you where they are, and it'll tell you whether or not you need to apply in situ or ex situ techniques to do that conservation. And the places you're going to get this background data are the ones I've mentioned here. So generally, the data is taken from GenSys, GPIF, and national specialist collections. So for instance, I was talking to the Korean team the other day, and they've been taking just data from GenSys and GBIF, but you also have taxonomic experts in Korea. They have their own data sets that may not be included in GBIF or GenSys. So you need to make sure you're also contacting their people and getting those data as well. Now, I've also included this nice map here to illustrate a point. Now, ideally, if you're doing conservation data, if you're doing conservation planning, you have really good genetic data. Genetic data is the ideal way of doing conservation. We very rarely have good data sets for most crop wild relatives. So perhaps if you're working on, maybe Noam will tell us later about wheat, but I'm sure they have good data sets, genetic data sets, but they're the exception. Most major crops, we don't have those kind of data sets. But to illustrate what you can do if you do have genetic data, this is, believe it or not, my very first PhD student was Morag Ferguson in 1998, finished her work. She worked on wild lentils, and she sampled wild lentils all the way from Tajikistan, all the way across to Spain and Portugal. So she looked at over 300 populations, looked at the pattern of genetic diversity, and then clustered those patterns. And she identified 10 clusters. The 10 clusters are shown here by the different cluster symbols. And effectively what she found is in Tajikistan, they're all triangles, which is one of the 10 clusters. And the triangles, green triangles, go all the way across to Western Turkey and across to Spain and Portugal through Italy. So everywhere is green triangles, yes? And the only place you find the other 9 clusters all here in the Fertile Crescent. So this area is the only area that has effectively diversity for wild lentils. So imagine if you don't have this information, you would say, okay, we're going to set up 5 protected area for lentils. We'll put 1 in Tajikistan, 1 in Portugal, 1 in Italy, 1 somewhere else in Turkey, say. That would be a mistake because the genetic information is telling you that the diversity is all located here in the Fertile Crescent. Yes? So whenever you have genetic data, it's a much better way of use of the data in planning your conservation activities. But if you don't have that data, and I'm saying most times we don't have that data, then we have to use ecogeographic data. Okay, so you've done your ecogeographic survey study. Then you lead into your ex situ, and I'm prioritizing ex situ. The reason I'm doing ex situ first is the CBD often talks about in situ having priority and is more important than ex situ. But for genetic resource conservation, the way that works, the way that we know we can do effective conservation of crop wild relatives is to take the seed, if there are orthodox seeded species, and put the seed in the gene bank. And the breeders also are used to using that way of accessing their material. So that's the simplest way of doing it. It works, yes? So why complicate things? Okay, so I'm going to go into talking now about a few examples from this Global Trust project. So this is Global Crop Diversity Trust, Crop Wild Relative Project, funded very generously by the Norwegian government. And I have to hand my hat to the Norwegians. If only the British government was as enlightened as the Norwegians, I'd be a happier man. But anyway, so the Norwegians give a lot of money for, in this particular case, for conservation of crop wild relatives. And we worked out a priority list of, this is a global list of 1,392 crop wild relative species related to 194 crops. And that paper was published as the first paper we published out of that project. And then the MSBQ did a lot of collecting expeditions jointly with national programs and CG centers between 2013 and 2018, so over a 6-year period. And they had a budget of about $8 million to do this work. So it's a significant amount of money. But the point I would take from this is 8 million, and they were only working on 29 major crops, so not the complete range of crops, only 29 most important, but still it's a subset. And in that 6-year period, they only managed to collect 3,447 seed accessions. So the point I'm making is it's actually expensive to conserve ex situ. Now, I'm not at all saying that we should give up doing ex situ and switch to in situ. But I am saying we can't continue to ignore in situ. So at the moment, the amount of money that's spent on seed collecting, ex situ collections, is about 99% of the money that goes on conservation. And at this time, probably 1% goes on in situ. There are very, very few working, practical in situ sites where crop wild relatives are conserved around the world. So this is something I definitely think we should be thinking about more. And we can guarantee that we'll make more genetic diversity available if we use both ex situ and in situ techniques. Okay? So this is looking at taxon richness based on this 1,394 priority crop wild relatives from 194 gene pools. And you can see the major area that has a concentration of taxon richness for crop wild relatives is basically around the Mediterranean. But you also have areas in Asia, significant areas in Asia, linking Central Asia down through into China. Not so much up here in Korea. And I'll come back to talking specifically about Korea later on. But the other thing that really stands out from this was it shows that we have other areas that had never really been identified as major centers for crop wild relatives. So look here, around Washington, this area of the US has crop wild relative diversity. I mean, no one ever talked about it. And also the other area that really stands out is Northern Australia. So Northern Australia has a lot of wild soya beans. And again, I don't think that was anything that was really realized until we did this analysis. So it just shows the importance of this kind of analysis. So this is looking at taxon richness. Then we can also look at ex situ collections, where we need to do ex situ collections. So this is all species modeling, and these are the results produced from them. So the redder areas here are the areas where we need to focus our new ex situ collections. So here, Indonesia, Malaya, here in China, going up here, and still around the Mediterranean, though interestingly, not quite the same pattern as we saw in that previous diagram of concentration, and then down here in South America. So this spot here is largely for wild Arachis species, which again had not been identified before. Now, I'm going to finish up with a comment on ex situ, because I haven't got time to go into a lot of detail, but just to finish up with this quote at the bottom, which I hope you can see. So let me go through this quote. So this quote is from the major paper where we analyzed this data. And the conclusion of the paper is that over 70% of taxa are identified a high priority for further collecting in order to improve their representation in gene banks, and 95% are insufficiently represented regarding the full range of geographic and ecological conditions. So the point is, 95% of crop wild relatives globally are not well represented in gene banks currently. So I know that Noam is going to come back to me in his talk and say, Nigel. We've done a bloody good job with wheat. We've got basically a lot of wheat, and I'm sure they have got. But if we're looking at all crops, then there are still major gaps. And this is why I'm arguing to do both in situ and ex situ. So if you do complementary conservation, you have a better chance of getting better coverage. But I still acknowledge completely that if you're a breeder trying to access material, you're always going to go to the gene bank. Because you know the gene bank, they tell you they have the material, they can send you a sample. And it's not so easy to get material out of in situ conserved sites. And I'll come back to that point later. Okay, so this is just looking at some problems associated with collecting ex situ. The obvious first one is undergraduates these days, certainly in Europe, are very reluctant to have training in taxonomy, field identification. And if you're going to the field to try and conserve crop wild relatives, you have to be able to identify the material. Primarily, the material that's going to be used is stored as seed in gene banks, as I said. It must be characterized and evaluated so it can be used. We don't have to have genetic diversity studies. We can use something ELC mapping. ELC mapping is ecogeographic land characterization. It's a kind of modeling technique for identifying predicted areas of high genetic diversity. So if, say, for instance, you had a map of Africa, say, and you knew the species grew all over Africa, it'll divide Africa into 10 zones, or however many zones you want, and then you can work out, right, okay, if we want to conserve genetic diversity, we need to sample the species in each of the 10 zones that have been identified. And this technique is very useful and I think is actually underused. Okay, so let's have a look now at in situ from the same analysis. So this is looking at in situ priorities. Remember the map before we had was for ex situ. For in situ, this is a map showing the 170 areas, they're not precise sites, 170 areas either in protected areas or outside of protected areas where we know we have high concentrations of crop wild relative taxa. So the colored sites, other than the blue, are the ones where we have high amounts of material inside protected areas, and we also have some sites outside of protected areas. So in this analysis, 170 sites identified in total, each species represented by 5 sites, so it's not present just in one location, it's 5 different locations. We want to select the maximum genetic diversity, so that's done using ELC mapping built into the program. And then we also did climate change analysis. So any site that was like to be really impacted by climate change was not included. We only included sites for in situ conservation that were less likely to be impacted by climate change. And clearly you can see the concentration, the world concentration is again clearly turning up in the Fertile Crescent, and not surprising at all. I just wanted to re-emphasize the point about when you're doing this conservation planning, emphasizing climate modeling is very important. So this is just looking at changes over time in water and in situ sites that can set up and be maintained. And I've given you a simple an example here for a particular species. So this is Medicago sativa, a very important crop wild relative and crop in Oman, the country of Oman. And you can see the population distribution is shown here in orange. In 2015, 12% of the country. In 2020, just 5 years later, it's actually increased. So climate change has increased the range of Medicago sativa. But look at the last site here. This is in 2050, and dramatic. It's now only found in 2.3% of Oman. So it does, I'm just reiterating how important the point is that we must do climate change analysis with our analysis of predicting where we're going to do our conservation implementation. Okay, so this is just, this is a kind of detailed, rather detailed analysis, but it's showing network structure. So usually when we're planning conservation, we plan conservation both within a country, as in over here, the green one at the far end, the pointer's not particularly strong, but anyway, the one over the far end in green, this is national in situ, and we've got the looking at crop wild relative diversity, prioritizing, sorting out our taxa, where they're located, doing your ecogeographic analysis, and that gives you a set of results. We also do the same analysis, say if you're working on Korea, you do the green analysis for Korea, and then you do the blue analysis for the Asian region. So you're identifying Asian priority sites and also national sites in Korea, and you put those two together and you have the orange circle in the middle, which is your integrated conservation using both national and regional priority taxa. And that's how you set up your network structure. Right, okay, so when you're setting it up, one of the most difficult steps is working with the non-agro biodiversity community. So we all understand the importance of crop wild relatives, but if you're talking to protected area community, they tend to be less inclined. And I think we made a mistake when we first developed the term crop wild relative. We should have thought of some other formulation that didn't start with crop. Because if you're talking to some protected area community people, they immediately hear the word crop, and they say, oh, we don't work on crops. There's no interest to us. So it's extremely frustrating. So there has to be mutual benefit. So what's the benefit to us, our community, agrobiodiversity? Well, obviously, we need to have greater diversity available, conserved and available for utilization. That's a key advantage for us. But the advantage for the protected area community is increasingly protected areas are finding it difficult to fund conservation in protected areas. Protected area agencies are coming back, governments are putting pressure on them to show that they're doing an efficient job. They have to show they're producing something really worthwhile, economically valuable. And so we can do that. So at the moment, we have a project that's going to be starting up, I hope, in the Nordic region, and in that region, we're working with the protected area each community in each country to persuade them of this argument and talk about additional ecosystem services, additional value. Now, this has worked in some countries already. In the UK, where I come from, it has worked. We are strongly working with the protected area community, and the same is true in Germany as well. Okay, then we have a whole series of questions like I had before for ex situ. So why we should have networks rather than individual sites, obviously it's more efficient. In situ sites established in new areas or new protected areas, I think it's very unlikely we'll ever have the resources available to set up new protected areas just for crop wild relative conservation. So we can adapt the management plan of existing protected areas and do in situ conservation in existing protected areas. Otherwise, we can work outside of formal protected areas and use either botanic gardens, managing areas that they run as in situ sites, or OECMs, other effective conservation measures, which is a new, less formal technique than protected areas currently being pushed by IUCN. And then, so all this is just saying that, and the name we're going to give if we do set up finally this, at least the European, and then I hope eventually the global system is the Vavilov Network, named after this scientist who has a very interesting life plan. And I haven't got time to go into it, but I mean, he is worthy. He is a worthy father to have a system named after him. Okay, so this is another point that I raised earlier. So one of the big drawbacks has been for many years, how do you link in situ conservation to use? Yes? Imagine how you do this. How do you do it? Because if you're a breeder, do you want breeders going to individual farmers, say in Africa, a big commercial breeder going and getting samples off them? How do you ensure equitable sharing of benefits in that case when you have a major international breeding company getting material from an individual farmer who's probably never even seen a lawyer, let alone could employ one to argue his or her side of the case? So it just doesn't work. We spent several years trying to work this out, and it will not work. So the only way we think of making sure that in situ material on the left-hand side here can get to utilization is via the gene bank. So in other words, with each in situ population, you take a sample, the sample is put into the gene bank, a designated gene bank, so there's a one-to-one relationship between the sample site and the sample site where it's donated into the gene bank. And then you have different ways, potentially, of handling this. You could have, for instance, a breeder who wants a particular accession collected from a particular environment where there's a protected area, and the breeder tells the gene bank, and then the gene bank goes and collects it. So I called that demand and supply. That doesn't work very well because it's a delayed system and it involves the gene bank doing extra work. Then just make sure that all the collections from in situ sites go into the normal long-term ex situ conservation. In other words, they're just regarded as normal accessions. Well, this is very expensive. The gene bank managers among you will know that you can't take an infinite number of additional collections and monitor them and manage them. It's going to be very expensive for you. So that doesn't really work very well. Then the next option is black box. So black box is you take a sample from your in situ site, you put it in the gene bank, and basically then it's there. The only people who can get it back are the person who's put it in, and it's not available for use. So that's not working. So we think the only one that really works is what we're calling in situ backup, where you take a sample from the in situ site, you then register it, document it, clean it, dry it, germinate, test it, so there's packaging, you put it in the gene bank. But what really costs the money with the gene bank is regeneration. So taking it out periodically and improving the germination percentage. So you don't do regeneration. You don't regenerate the material at all. In this case, you just go back to the in situ site and get a fresh sample. So you don't need to do regeneration because you go back to the original site and recollect again. And it's probably better to have a current representation of the population rather than one that was historic. So that's the favored option here. And it's this one here that we're favoring, and this is the one we're promoting at the moment. Then also it means that if the material is in the gene bank, it can be characterized and evaluated along with the normal gene bank collections in the way it would normally be done for ex situ collections, and then it can be made available and utilization is the end goal. So this seems to work and is our preferred mode of operation at the moment. Then getting to the end now of my talk. So no one will tell you, I'm sure, and it's true, that you have to have characterization and evaluation, but it doesn't have to all be phenotypic or genotypic. The CG centers are increasingly use predictive characterization, where you predict where the alleles will be, or at least to get a subset of material that you can do detailed genotypic and phenotypic analysis on. And then pre-breeding. So many breeders will say they're reluctant to use crop wild relatives. Why? Because it's difficult to get the seed, they're difficult to grow, there is linkage drag. So if you cross the crop wild relative with the crop, you put in traits that you don't want along with the traits you do want. And they already have, often if you talk to breeders, they say, oh, we've already got enough variation, we don't need any more. Well, I'm sorry, that's just not an answer when we're facing climate change. They don't have all of that diversity they need to tackle climate change. So the answer to this is have pre-bred material. And the CG centers are producing this pre-bred material, making it available so any country like Korea doesn't have to do the actual crossing between the crop wild relative and the crop themselves. They can get hold of the material from the CG system and then use that. Right, the last slide is just saying that the use of crop wild relatives in breeding now is well established. There was this compilation of exemplars of use for lots of different crops published by the Trust, Killian in the Trust, published in 2021, this monograph in crop science, which talked about the use of crop wild relatives in fighting climate change and their applications. Right, so the last slide, literally the last slide, is this one here, which is talking about policy work. Now, I'm a scientist, and I hate talking to politicians, but I realized in my long life, if you have that attitude, you're never going to get any money for your research. The only way you can actually guarantee getting money is talk to the people who give the money out. And so it's important we talk to the politicians. So here you can see me looking rather grumpy. This is in the European Parliament, and I'm giving a talk to European politicians about the importance of crop wild relatives and spending more money on conservation of crop wild relatives. So we could, for instance, in Korea, in this region of Asia, you could produce some kind of white paper laying out why the arguments for why crop wild relatives, it's economic to pay for the conservation, because in the end you get more out of the product than you're putting in, significantly more. And I wish we could get a tame environmental economist to actually work this out, the advantage. The more you get back from investing in crop wild relative conservation rather than the use you get out of it. And then lastly, just talking about meeting international conventions and treaty commitments. Well, I think it was, someone made the point in one of the talks earlier that we should be fulfilling this as part of our treaty and convention commitments. So I'm thinking here about GLIS. We already heard about GLIS from Mario earlier. The CBD, FAO Commission views, international treaty reporting. All of this reporting is an obligation if you're a member of those treaties. So we can, if we do this, we'll be able to do that reporting. So that's my last point. I think you need to make effective use of that. And this is just a few additional points specific to Korea I've highlighted here in red. I'm not going to go through them now, but it gives you the kind of issues, detailed issues, like whether or not there's a digitized flora. There's a digitized flora, then it's easy to work out which are the crop wild relative checklists. So thank you very much. Oh, it's just saying, oh, it's flashing me. Did I go over? Yes, it doesn't matter. Okay, thank you. Any questions? No? Pardon? Oh, the panel later. Oh, sorry.
It was a really perfect presentation. Thank you very much. 네, 다시 한번 따뜻한 박수 부탁드리겠습니다. 네. 두 번째 세션의 첫 발표가 마무리되었는데요. 발표 중에 잠시 이 번역이 나오지 않았었죠. 그래가지고 조금 당황하신 분들도 계시겠지만 아마 저뿐일 것 같습니다. 여기 계신 분들은 모두 우리나라의 브레인들이고 또 각국의 브레인들이셔서 그렇지만 이 시스템을 저희가 조금 점검하기 위해서 잠시 쉬는 시간을 가지려고 합니다. 네, 잠시 10분만 쉬는 시간을 갖도록 하겠습니다. 그래서 저희는 잠시 후 오후 2시 25분에 다시 시작하려고 합니다. 네, 잠시만, 이제 첫 번째 발표가 마무리되었으니까요. 잠시만 좀 리프레시 시간을 가지고요. 이어서 세 번째 발표는 25분에 시작하도록 하겠습니다. 조금 뒤에 뵙겠습니다.
마이크 테스트 중입니다. 마이크 테스트 중입니다.
네, 여러분 잠시 리프레시의 시간 다들 되셨을까요? 저희가 이제 장비를 모두 점검을 마쳤기 때문에 다시 시간을 재개해 보려고 합니다. 세 번째 발표를 이어보려고 하는데요. 세 번째 발표는 세계식물원 보전연맹 BGCI의 칼리코의 사무총장님께서 맡아주시겠습니다. 발표 주제는요. The Global Vision of GCCFP, Empowering Botanic Gardens as Living Infrastructure for Food Security. 식량 안보를 위한 살아있는 시설로서 식물원이 어떤 역할을 수행할 수 있는지, 그리고 GCCFP의 글로벌 비전에 대해서 말씀해 주시겠습니다. 네, 따뜻한 박수 부탁드리겠습니다.
Good afternoon, colleagues, guests, ladies and gentlemen. I will have the microphone here because I'm not as loud as Nigel. It's a great pleasure to join you today, and I'd like to thank the sponsors and for bringing me across for my first trip to Korea. It is wonderful to be here. My talk today will speak about ex situ conservation, something slightly different from what Nigel has just spoken about. So, Botanic Gardens Conservation International is a global network of botanic gardens, of over 900 botanic gardens, arboreta, and partner institutions in over 100 countries. We work together to secure plant diversity for the well-being of people and the planet. And as Mario mentioned this morning, we have a wide reach. We have over 1 billion visitors collectively across all botanic gardens in a year. This is massive outreach and awareness raising. But today my talk is going to explore how botanic gardens, and when I say botanic gardens, I mean arboreta and botanical institutes, can be recognized and mobilized as living infrastructure for food security. How botanic gardens and the newly established Global Conservation Consortium for Food Plants can help bridge the gap between wild plant conservation and resilient, sustainable food systems. So, a countryman of mine, Nelson Mandela, once said, "It always seems impossible until it is begun." And for those of us working in biodiversity loss and trying to conserve species, these words resonate deeply. They are perhaps more relevant to us working to conserve food plant diversity and crop wild relatives. The task before us is enormous, but we have begun. We are here today, and the two speakers before me have already shown that there is massive work already underway, and I know each one of you is doing work. The work has begun. So we don't need to stress. We don't need to worry. We're being asked to conserve genetic diversity for future generations. And history does show us that when we collaborate as institutions, conservationists, and communities, we can seemingly do the impossible and reach the goals that we aim for. Here we go. So, as highlighted by Mario earlier, despite the immense diversity of edible plant species that are available to humanity, the FAO's recent global survey shows that 35% of crop wild relatives are threatened. And these findings are sobering, as they show that the species that underpin future food security are under pressure, and many still remain undocumented, as Nigel has mentioned. Work done by the Royal Botanic Garden Kew and others found there are at least 7,039 edible plant species. Now that's quite an old survey from Kew State of the World's Plants. That's probably increased and increasing now as we're doing research. They also found that about 417 of these are food crops. So I'll leave that to my colleagues to debate the figures, but together these assessments show that our understanding of plant diversity is incomplete. And where assessments have been done, we know that the species are threatened with extinction. So the question is, where do botanic gardens fit into this picture? So botanic gardens, arboreta, and botanical institutes are defined as institutions holding documented living collections of plants for the purposes of scientific research, conservation, display, and education. They occupy a unique place in the conservation landscape. They sit at the intersection of biodiversity conservation, scientific research, living collections, education, and policy. But more importantly, they conserve species that are overlooked elsewhere, threatened species with restricted distributions or poorly represented in agricultural collections. They also have fundamental expertise in crop-wild relative taxonomy, field biology, restoration ecology, and the long-term conservation management in situ and ex situ. Through the BGCI network, with our over 900 institutions, we represent one of the world's largest conservation communities. Living collections are the most important aspect of botanic gardens. I'll now take you through what we have for botanic gardens in the definition: scientific research, education, and living collections. So botanic gardens play a pivotal role in plant conservation through a range of scientific contributions. And one of the most important functions is ex situ conservation, where threatened plant species are maintained in living collections and seed banks as insurance against extinction. These collections are documented, and botanic gardens have detailed databases of their collections. BGCI itself curates a database called Plant Search, where you can find out which botanic garden has which collections, and particularly for crop-wild relatives. Botanic gardens also conduct research on seed biology, propagation, and conservation genetics, helping preserve genetic diversity and improve conservation outcomes. In addition, they contribute to plant taxonomy and species discovery, providing the scientific knowledge needed to identify and assess threatened plant species. Many botanic gardens also support ecological restoration programs, and they play a critical role in researching the diversity and use and potential future applications of wild plant species, generating knowledge that can support future food security, medicine, sustainable use, and of course, climate resilience. Together, the activities undertaken by botanic gardens are essential for informing conservation policy through scientific-based evidence. Display and demonstration gardens are also parts of botanic gardens, and they're the most visible ways that botanic gardens can contribute to plant conservation. As we've just seen on the tours after lunch, they transform the living collections into spaces for learning, inspiration, and action. They help visitors understand the importance of plants and the challenges that they face, and the challenges that we as conservationists face. Many gardens use thematic displays to communicate key messages, including the value of wild plant diversity for food, as well as human well-being, the threat to plant extinction, and the need for climate-resilient and water-efficient landscapes. They also raise awareness of invasive species and their impacts on biodiversity. We come to education. Education is one of the most important ways that botanic gardens can contribute to plant conservation, with living collections and seed banks providing the foundation for learning, discovery, and public engagement, as once again we have seen here in Sejong. The collections offer unparalleled opportunities for first-hand understanding of the role that many plants play in our lives. Botanic gardens support national and international programs for education, formal and informal learning, such as school programs, guided tours, displays, and scientific research. They provide training for horticulturalists, conservation practitioners, and future environmental professionals. And while citizen science initiatives and community programs can inspire future conservationists and policymakers. But here we come to the heart of my talk, the living collections. The primary conservation role of living collections is ex situ conservation, which simply means conserving plant species outside of their natural habitat. Living collections act as insurance against extinction by safeguarding rare, threatened, and endangered species. Excuse me. Many collections in botanic gardens are in fact extinct in the wild, and these are the last remaining representatives of those species in botanic garden living collections. Living collections also play a critical role in conserving genetic diversity by maintaining plants from different populations and geographic areas. Botanic gardens preserve valuable genetic resources that can support future use and recovery programs. Another important contribution is supporting species recovery and reintroduction. Plants grown in botanic gardens can be used to reinforce declining populations and reintroduce species in areas where they may have disappeared. Many successful reintroduction programs around the world have used plant material produced in botanic gardens. Living collections are also essential for scientific research, as I have already mentioned. They provide material for students in taxonomy, systematics, ecology. I can go on and on of what we can use the material from the living collections for. They also provide species to study over long periods of time and to see them actively growing. In addition, living collections support conservation horticulture by helping scientists develop propagation protocols and cultivation techniques for species that are difficult to grow or to reproduce. These techniques are often the crux for the survival of species. The collections are also valuable reference collections, helping researchers and students to correctly identify plant species and understand their characteristics. And finally, they provide seed, germplasm, and other plant material for production of sustainable use initiatives. Just outside, at the registration desk, you can see materials that have been produced, products from living collections and from seed bank collections right here at this conference. So this slide just highlights another important contribution that botanic gardens and their living collections can make to conservation. They help with the rediscovery of species that may have been lost or are even thought extinct in the wild. Often, living collection teams going out to collect material cover vast areas collecting wild species from a greater range of species and for a greater range of species and genetic diversity. Collectors are constantly observing the ecosystems, documenting associated flora, and understanding the habits and habitats of the species in the wild. They therefore frequently encounter species overlooked by specialists going out to seek one particular species. So the two examples on the screen are crop wild relative heather species from South Africa, Ericaceae. And these are relatives of the common heather for honey production. Now, Erica grayei, which is on the left of the screen, was rediscovered after 111 years. And it was rediscovered by seed bank collectors, one of which was myself, when we went out to look at a type locality for a protea, Proteaceae, completely different species, that had been monitored and documented for many years by the protea specialists. But they had overlooked the small pink Erica, not for 111 years, but we picked it up, took it to the taxonomist, and he almost fell off his chair when he said, it's Erica grayei. 111 years, we had one specimen. Similarly, Erica caterviflora on the right of the screen was found after 19 years. It was thought extinct in the wild. It grows on the top of Table Mountain, frequented by many specialists, tourists, anyone else running up the mountain or hiking and climbing up the mountain. And it was found by a plant collector from one of the conservation horticulture departments at Kirstenbosch Gardens looking for Brunniaceae, completely different group, but saw this Erica, collected it, took it back, and the taxonomist once again, Ted Oliver, fell off his chair and said, it's right here in the city of Cape Town. So living collections and their collectors can help rediscover species. But while living collections are one of the most powerful tools that botanic gardens can make for plant conservation, it's also important to recognize that they have limitations. many plant species are inherently difficult to cultivate. Some are short-lived, and others are highly specialized, needing ecological requirements that can only be achieved in the environment. Another challenge is they are extremely vulnerable to pests and diseases, and they are in small areas, small spaces, and if there is an outbreak, you could lose an entire collection, almost an entire species, at once if not maintained correctly. A further challenge is the retention of horticultural expertise. And this was highlighted by Mario earlier this morning, in that expertise across our industry in conservation is sorely in need, I should say. So specialized knowledge to grow these species is required, and the skills. We need young career professionals to come up into conservation horticulture, and we need to retain those people that we still have and to keep their knowledge. Then documentation is vitally important. A conservation collection, a living collection, is only as valuable as the database and the data associated with it. So we need to develop our data systems. We need a data ecosystem that speaks across all the databases. Nigel listed several databases, and I've mentioned Plant Search. We need to integrate these, and we need to make sure that the data going in from living collections is accurate. And finally, botanic gardens operate in a finite space. And we need to maintain living collections. We need many pots that take up space. The plants take up a lot of space. And we can't just keep expanding our botanic gardens and our nurseries. It requires land, money, and a whole lot more capacity to do this. So there are quite a few limitations to botanic gardens. But it's not all bad, because we have seed banking. And I'm not going to tell you the benefits of seed banking, because I'm sure many of you, in fact all of you, probably know the benefits of seed banking, and we're going tomorrow to see the seed bank. So one of the largest advantages is that seeds are small compared to the growing plant. So they're compact. We can then store more genetic diversity in a smaller space compared to living collections with actively live plants growing. They're also easier to maintain. We don't need to water seed bank collections. We don't need to monitor pests and diseases as we do with living collections. We have to monitor pests and diseases in seed banking, but not as much as living collections. And we also don't need to repot seed banks. Another important benefit is that they are an insurance policy against extinction. They have greater genetic diversity, they're cost effective, and they can support restoration at a greater scale with more genetic diversity. So overall, seed banking is an efficient, cost-effective, and scientifically robust method for ex situ conservation. But it also has limitations. The fact that there are recalcitrant species that cannot be conventionally banked. Many threatened species also have few seeds. This limits collection from the wild, as well as germination testing and storage. And little is known about the seed biology. So when we do our testing, we have to be really, really careful, because if we lose those species, we could lose an entire species. If we lose this germination of one seed, you've lost almost half a population if you only had 2 seeds. And seed banks themselves are specialized facilities. They need long-term financial support, and this is often hard to come by given our current economic situation globally. And finally, seed banks conserve species and genetic material, but they do not conserve the natural habitats. Nigel spoke about in situ conservation, protected areas. We still need to conserve those. Seed banks don't provide us a view of the living plants and the habit that they have when they grow. So we need to look elsewhere. And here we have field gene banks. And field gene banks are important, where living plants are maintained in orchards, plantations, or dedicated safe sites, which is something that BGCI does through our Global Conservation Consortia. And they're particularly valuable for species which cannot be conserved in seed banks or living collections in glass houses, but have to be grown and often reproduce vegetatively. And field gene banks provide a readily available plant material for research, breeding, propagation, and restoration programs. And they allow scientists to study the important characteristics of growth, flowering, fruit production, and disease resistance. They allow the researchers and education resources to see the whole plant, not a plant in a pot or a seed in a jar. So what we have here is living collections, seed banks, and gene banks that should not be seen in isolation. And this reflects on the institutes which use these methods of conservation, such as agricultural food systems, which focus on crop genetic resources, while botanic gardens focus on wild species and ecosystems. Botanic gardens, help connect wild populations with conservation collections and research supporting agricultural use. And at the same time, the gene banks hold agricultural biodiversity. And here the focus is on distribution and breeding. It's clear that there is an overlap between botanic gardens and gene banks. And for us to conserve crop wild relatives and ensure that food security continues into the future, we need to leverage the strengths of both these institutions and build more integrated global system of conservation for the future of our food plant species. So how are we going to do this? Well, BGCI has established a program called the Global Conservation Consortium Program. This is a program that connects botanic gardens and like-minded institutions on a focused plant group to conduct gap analysis and take action for the conservation of species. One of our most recent GCCs is the GCC for food plants. And as was mentioned this morning by Mario, it was launched last year at the Treaty Convention, but there was a soft launch in New York in September at New York Climate Week. The GCC for food plants connects botanic gardens, agricultural gene banks, researchers, conservation practitioners, and food and agricultural stakeholders towards a common agenda for food plant conservation. It aims to strengthen the coordinated conservation action across all of these stakeholders and groups and ensure that natural habitats are preserved for crop wild relatives. The GCC-FP recognizes the complementary strengths of both gene banks and botanic gardens. And its aim is to build a simple premise, that we can achieve far greater impact through coordinated action than through isolated efforts. By sharing expertise, collections, data, and priorities, we can create a more effective global conservation system for food plants and their wild relatives. As I said, the work has already begun, and as a gap analysis, an initial gap analysis by the GCC-FP, the food plant species globally show that there are too many species for any one institution to conserve on its own, and no individual institution can conserve the full diversity of food plants and their wild relatives. Botanic gardens, arboreta, and gene banks need to work together to hold this solution in their hands and save all these species. So what we have is, we've seen that there's approximately 26,000 plus food plant species that need conserving, and then there's still all the thousands of crop wild relatives. As part of the consortium's work, we've also analyzed global food plant diversity. And Nigel showed you several maps. I'm going to show you several more maps. So we're doing some mapping at this stage. And this one illustrates the food plant diversity is truly global. That species are distributed almost every continent and ecosystem. And in total, the data set contains more than 5 million occurrence records. And this is an FAO data set. So while there are centers of diversity are particularly evident, it's interesting where the gaps are, where we're not seeing this mapped already. And maybe they aren't there, but maybe they are. Now, this map is from BGCI, and this shows the botanic gardens and our related institutes having infrastructure in place already. There are over 3,000 400 botanic gardens worldwide, spanning almost every continent and many in biodiversity hotspots. Collectively, they hold scientific expertise, extensive living collections, seed banks, and the associated knowledge of this. The crop wild relative conservation in this network is an untapped opportunity. There's also bridges between agriculture and biodiversity sectors through international collaboration and data sharing and coordinated action with botanic gardens that can close conservation gaps if we harness this network. And then, of course, we have a whole nother network. We have the gene banks, which represent the critical global infrastructure for conserving plant diversity. And here we have 14,000 gene banks worldwide. Once again, this is from FAO data. And these play a vital role in safeguarding genetic resources underpinning our food systems, ensuring that genetic diversity remains available for research, breeding, and adaptation for future needs. Gene banks have been successful in conserving agricultural diversity, but many crop wild relatives remain underrepresented here. We need to close this conservation gap through collaboration. Now here we go, we've combined all three maps into one, and it highlights the strengths of the existing conservation infrastructure, but also where there are gaps. While gene banks conserve over 1.2 million food plants, botanic gardens have approximately 14,000 accessions of diverse taxa. And the work has already begun. What we need now is stronger partnerships between our institutions, and particularly in centers of diversity, where many crop wild relatives remain undercollected and, as I've said, underrepresented. The connection of complementing networks is the only way that we can achieve long-term genetic conservation and food security. The conservation of food plant diversity is not the responsibility of any of us individually, our institutions. It's a shared endeavor globally. These figures illustrate the gene banks are dominated by major crops such as wheat, rice, and maize, as many of us know. And they have a critical role in preserving genetic diversity of our agricultural resources. In contrast, botanic gardens maintain a much broader taxonomic diversity, including crop wild relatives, tree species, and neglected and underutilized crops. And this shows that different conservation systems are highly compatible, each having their own unique expertise, collections, and capacities, neither holding the diversity needed to fully support resilient food systems. But together, we can collectively conserve food plant diversity by combining the strengths of both of these sectors. So fortunately, we have the GCC for food plants, bringing together experts from multiple sectors and disciplines. And this slide shows the lead individuals, and on the far left we have Colin Corey, who was a speaker here at the first Crop Wild Relative Symposium last year. And Colin sent me many of the slides, so I will say thank you to him in his absence. And it also shows the lead institutions who are supporting the GCC-FP. The network must grow in order for it to be successful. And I hope that many of you in this room will join the GCC-FP. Please do email Colin, details are on the screen, or come and see me during the afternoon and tomorrow. And there's no fee to join, just join. We need to conserve food plant diversity. So I'd just like to close with another quote from Nelson Mandela. What counts in life is not the mere fact that we lived. It is what difference we made in the lives of others. And in conservation, this challenges us to a simpler question, particularly for food plant conservation. What difference will we make to the future of food security? And the answer lies with genetic diversity, crop wild relatives, and collaboration. Through botanic gardens, gene banks, arboreta, communities, universities, and stakeholders, we have the means to secure the future together for our food systems. Thank you.
Thank you for the great presentation. 다시 한번 따뜻한 박수 부탁드리겠습니다. 네, 식물원과 수목원이 CWR 보전과 또 식량 안보를 연결하는 중요한 기반이며 특별히 유전자원 은행과의 협력이 앞으로도 굉장히 중요하겠다라는 점을 확인할 수 있는 시간이었습니다. 이어서 네 번째 발표가 진행되겠는데요. 이번 발표는 존 이네스 센터의 노암 하유트 수석 연구원님께서 맡아주시겠습니다. 네, 발표 주제는 다음과 같습니다. With wild relative resources, conservation, genomics, pre-breeding, and utilization. 미래의 CWR 자원의 보전, 유전체 연구, 육종 전 단계 연구와 활용에 대해서 말씀해 주시겠는데요. 네, 큰 박수로 맞이해 주시기 바랍니다.
Thank you very much. It's a really fantastic place to be in, and I really feel, I'm really grateful for the invitation, for the fantastic host, and frankly quite inspired of the leadership that Korea is seemingly taking in the region in terms of the future aspirations. And I hope to contribute even in the slightest way. So I'm going to talk about wheat-wild relative. I'm going to talk about one accession specifically, but bear in mind wheat. So we said 7,000 plus edible plants. Wheat provides 20% of calories and protein of human consumption, and together wheat, maize, and rice produce more than 60% of what we eat. And from there is the importance of them and the wild relatives. Yeah, so my name is Noam Chayot. I lead the Germplasm Resources Unit. It's a research gene bank in John Innes Center. Let's start. So in the talk, there'll be two areas. First, I'll give an introduction to our gene bank, try to explain what is a research gene bank. I think it's quite of a rare breed. And then give a case study, again, of following one accession. And through that case study, I'll present two projects. One is a long-term academic industry pre-breeding strategic institute program. It started in 2012, and every 5 years it's been renewed. Currently, it is called Delivering Sustainable Wheat. And the second project is a Horizon Europe project that just started. It's a 5-year project called Protect and Promote Crop Wild Relative that I contribute to. But, whoops, that was not. So that's a PDF and not the presentation mode. Sorry, that's not great. There's a lot of animation, and a lot of things that you want to be able to see. Is there any way to put my PPT slides and not the PDF slides that I can, no? What do we do? Yeah. Yeah, no, the problem is that there's a graph beneath this graph that you don't see. And it's some animation that the PowerPoint has. Okay, what I was going to say is that what there was there is a graph showing the human growth, population growth in the last 2,000 years and the doubling time. So when Jesus Christ walked on the earth 2,000 years ago, there was about 250 million people. And for many, many millennia, that was the number, 250 million. And then it took 650 years, so almost 1,650 years for the population to double to 500 million. And in our lifetime, we already experienced a doubling from 4 to 8 billion people. And in order to feed, and the reason that we don't see a population collapse, and the reason that there is no widespread hunger and war over food around the globe, except in some unfortunate areas due to human activity, but not due to a lack of food globally, is exactly this graph. So this is from 1961 until today, population grew but by 1.5 fold, but cereal yield, so the production per unit of area, doubled during that time, and cereal production grew 2.5-fold. And that's the reason that we have the peace and stability in this wonderful life that we live. I think that's one of the main reasons, at least. And there is a good reason for optimism, because if we continue to do that, just for 2.5 or 3 more decades, we will reach over this peak of the mountain of population growth, and that's the expectation of the UN. So between now and 2050, 2060, we should continue with this growth. That's the UK perspective, but I'll skip it. Yeah, those. So this is a slide that I show in the master's course that we teach in biotechnology and plant breeding, describing the green revolution. So these are the 4 elements of the green revolution, and there is Norman Borlaug giving his Nobel Prize speech, owning, and it's owed to the green revolution and to him and his colleagues, the fact that we did not have a widespread hunger in the world back in the 70s when we started, as was expected for some decades. And this is because of the movement from old land races, low-yielding material, to modern agriculture. And the animation then was supposed to add this picture, and that's the message to the student, that this is still ongoing. And this is an international course where we send students around the world, hopefully that they will take this and work on the species in their countries. And this is Simon Orr, my right-hand man in the group, measuring wheat height in a plant breeding station in the UK. Okay. So that was just to explain why we're doing what we're doing, and I will give a quick introduction to our unit. So the formal name is a National Bioscience Research Infrastructure, and we have a long-term funding from BBSRC, our funding council, for conservation, and then we have a mandate to get more funding for research and to enhance use. So our motto was taken from the famous oceanographer Jacques Cousteau, who said, "People protect what they love." So we protect what we love, crop diversity, and our mission is really to conserve and enhance utilization of strategic gene pools of crops, and these are our funders and several running projects. In the UK, there is no one national gene bank, and that's from historic reason. And the reason that the way we operate is that the material are conserved in several centers of excellence, and the GRNBRI, our team here sailing on the Norfolk Broad, it's not what we do in our day-to-day work. And we are a part of a bigger, so we don't have a central management, but we coordinate and cooperate through the UK Plant Genetic Resources Group that Nigel chairs, and we are in turn a part of a European ECPGR, so European Cooperative Program from Plant Genetic Resources. And it would be nicer with the animation, but next time. Okay, so maybe a bit of history about joining the center. So maybe about plant genetic resources. So the word genetics was coined by our first director. So we have a rich history of genetic resources, William Bateson. And this was part of the rediscovery of the Mendel law and the initiation of applied genetics, so to speak. So they didn't have a word for it, but that was what they were doing. He later went on to set the Genetic Society. It was called Genetical Society in 1990, and this is an expedition that we put in in 2019 to celebrate the centenary of the society. So these are pea plants collected from all over the world. We talk now about wild relatives. You can see that the wild relatives were not happy growing there for the expedition. Some of them were actually collected by you, Nigel, in Syria and in other places. I didn't plan that part. But the more important... Yeah.
Sorry. Actually, I think we can change this PPT program. Yeah, for the better things. 네, 저희 잠시 PPT 조금 더 좋은 발표 자료를 교체하기 위해서 잠시만 시간을 갖도록 하겠습니다. After this technical problem solved, we can start again. Is it okay?
Absolutely fine.
All
Yes, it would be fantastic.
네, 그러면
I can
조금만
sing
기다려 주시면 저희가 바로 발표 자료만 교체를 해서 시작을 하려고 합니다. 그러면 그 사이에 여러분께서 아마 감명받았던 그리고 또 인상 깊었던 강연들이 계속해서 있을 것 같은데요. 특별히 저 먼저 얘기를 해보면은 저는 바로 직전에 칼리코웰 사무총장님께서 진행해 주신 부분에서 마지막에 그 넬슨 만델라의 말이 너무 좋아서 사실 원문을 찾아보고 있었거든요. 인생에서 중요한 것은 삶을 살았다는 것 자체가 아니라 우리 삶이 다른 이들의 삶에 얼마나 긍정적인 변화를 일으켰는지가 중요한 것이다 라고 해주셨는데 아마 여기 계신 모든 분들이 그렇게 우리 삶에 그리고 우리의 여기 지구에 조금 더 좋은 긍정적인 변화를 만들고 싶은 게 아닐까 하고 생각을 해봅니다. So we can start again from now on. 네, 그래서 저희는 이제 발표 자료를 교체했기 때문에 더 나은 삶을 만들기 위해서 다시 한번 발표 시간을 가져보도록 하겠습니다. 다시 한번 따뜻한 박수 부탁드리겠습니다.
Okay, so we were here already. I won't do that again. More important for this talk is the links between Bateson and Vavilov. So Nikolai Vavilov, rightly so, the father of ex situ genetic resources, who went around the world and collected. And was the first, initiated the first systematic approach for collection and has the visionary view of that the material can actually be used in breeding. Again, they didn't have the vocabulary, but they had the good understanding of why they're doing it. So the knowledge was exchanged there, but also germplasm. Okay, so within the collaborative gene banking in the UK, our remit as a group is, let's say, of international importance are these 4 collections: wheat, peas, barley, and oat. These are gene pools, so crop and crop wild relatives. Together, over 50,000 publicly available collections. You can order them through Seed Store, and we'll do our best to send it to you as quickly as we can. In terms of use, in a 5-year cycle, we send more than 27,000 seed packets in support of more than 1,700 projects in 49 countries. So I think we can say that we are a highly used international facility. So the history of the collections, the cereal collections started in the early 20s and 30s. In this example, it's a collection that was done by a scientist named Watkins, Arthur Watkins. He sent letters to all over the British Empire at the time, asking the consulate to go to the nearest farmer market and send a sample to Cambridge. And this is what started the Watkins collection. The advantage of this collection, it predates the Green Revolution, so it has a breadth of diversity of those land races that were grown before industrial breeding started. It took 50 more years for the collection to start being conserved in a long-term seed conservation chambers. That, of course, has an impact on the genetics. They had to be somehow regenerated every few years. And, of course, it changed them to what they are today. We adopted the standard material transfer agreement back in 2008 and started operating as a national capability with the long-term funded of BBSRC in 2012. So the public inventory, as I said, is over 50,000 accessions, and it has meaning. We conserve the seeds mainly in this rather not new and fancy place in 4 degrees and 12% relative humidity. So it would be considered in many places as medium term, although we have the obligation to maintain them for perpetuity. And that means that we have a heavy task of regeneration. So if for cereals, legume live much longer, but for cereal we have about 20 to 25 high quality seeds that we can maintain. And if the regeneration cycle is of 25 years, we go back from that and say, okay, if we need to regenerate, the maximum that we can do every year on average would be 2,000, 2,500 accessions. It's a huge task. And that leads back to this number of a bit over 50,000. So that's the bottleneck of growing. There's a lot of pressure on us to do more. And so we are moving gradually to in a way of prioritizing for vacuum-packed frozen seeds. We have some walk-in freezers and those industrial freezers, and we send a lot of material to Svalbard. So this year, and I have every time I thank the Norwegian government, now I can do it in person for this wonderful international facility that really represents trust, as you said early on, and we truly believe in the importance of that. Okay, so back in 2023, this is what we mean by a research gene bank. We put a vision, a document, a 10-year plan. It's funded only for 5 years, but it's a 10-year plan. And we in one sentence, we can summarize it as browsable omics, germplasm conservation for conservation and utilization. And what it means is that when we send you a packet of seed, we hope to be able to send you, or you will be able to browse it on the website, a meaningful set of phenotypes and some genomic information that enable its use. So our research is there to improve conservation and utilization that brings about financial sustainability, and we are privileged that we are able to put this money back into our research. So we have this independent that we get from our institute as a national capability. And the research focuses are improving crop conservation methodology. So with responsibility of 50,000 accessions, there are things we can do better. So this is an R&D, so research and development for solving problems, so improving the protocols that we work on. And then the second task that we took is phenotyping all of those for grain nutritional quality traits. And the last one is gene bank genomics. I'm not going to talk, it's not going to be a heavy science talk now. Instead, I'm going to have a case study following one crop wild relative named Triti Kumurartu and showing you how we encourage its use. And of course, we cannot do it alone. We do it in partnership with many. But first, what are crop wild relative? I'll go quickly on that. So they are just wild plants, as you all know. This picture was taken not far away from where I was born and raised in Israel. So in the winter, when you go out to nature, it is just covered by edible cereal plant, as is the case in the Fertile Crescent. Through many thousands or millions of years of evolution, they adapted to their environment. From these plants, the ancient crop were domesticated, and from them, during about 8,000 to 10,000 years, land races or traditional cultivars were grown around the world. In each place, they were adapted to the human needs, the human taste, the diseases in the area, that's the soil, the climate, etc. And this is the source of the diversity. Now, the important thing to bear in mind is that each of these arrows is a genetic bottleneck, and the concept of genetic bottleneck means that every time that you go forward, some of the traits or of the diversity remains behind. A lot of it is crop, and we don't want it in the crops, but some of it is very valuable and important, and that's the importance of crop wild relatives. So these candies represent those alleles that are missing in the modern crops. Some of them can be found in land races, and more of them can be found in the wild. But going from the wild relative directly to the crop is extremely difficult, especially in wheat. It's a highly complex process because of reproduction barrier and also because of linkage drag. Unless we use gene editing, and we can, but the perception means that it's not really being used in most parts of the world. So unless we use gene editing, if we take a gene from here to here, we take a lot of other genes with it. And most of them will deteriorate at the level of the crop. And I don't have time to go in any details, but I think outside academia, it's fair to say that we can only use crop wild relative for highly rewarding traits, so disease resistance or yield, only if there's no other solutions. And also, it's extremely challenging in a market-based for-profit context without the public sector pushing it forward. So this case study was put by Simon Orford in my team, again following a material that was collected by Vavilov, just one accession collected in Urartu, nowadays Armenia. This is what it looks like today. It's a weed, but it's the progenitor of the A genome of bread wheat. So this is a very simplified version of wheat evolution. Wheat is a hexaploid wheat. Wheat is a hexaploid plant. It has 3 sets of genomes. Each one of them is much larger than human. So wheat is much more complicated than human if you thought that you're a complicated creature. But a progenitor of one of the genome, of the A genome, it has the A, B, and G. The A genome is Triticum urartu. So it can be used to diversify modern wheat. And if you go to our website, to Seed Store, and search interface, you can browse the collections, and in the collection you can go to the crop wild relative collections, and there you would find about 1,000 wheat wild relatives, and one of them is this Urartu that we're talking about. So as I mentioned before, because I thought I will not have the Vavilov collected material around the world and generated or put forward the concept of a center of origins is where you should collect to if you want to have more diversity. So this accession was taken to the VIR, to the first gene bank in Russia. It was deposited in Germany in IPK in 1963. So we're in IPK now. And then later on in the 70s, there was a knowledge and germplasm exchange between Germany and the UK, and it was sent to the Plant Breeding Institute in Cambridge, was giving this code. So 1002, it was the second Urartu that was recorded. In 1990, the Plant Breeding Institute was privatized. The germplasm was moved to John Innes. Knowledge and germplasm also went to the private market, and we don't know where it is now, but the germplasm is publicly available through our gene bank. It was digitized in 2015 and available from Seed Store under the SMTA. So it was sourced in 2017 by the lab of Julie and Ian King in the University of Nottingham, and it was sourced as part of this project Designing Future Wheat. And again, the concept of bottleneck in this project, the germplasm development is done through 4 ways. One of them is using wild relatives. They are studied, their genomics is worked on, and then they are added to the elite material. At least that's the concept. Our gene bank is involved in 3 points of this national project. First of all, we are the source of the material, of course, as normal for a gene bank. We're also involved in the data analysis, and the project databases and our database speak with each other, so it's machines speaking with machines. It's not human work, but it works quite well. And then we are a bridge between the academic partners to the breeding industry. So we were here in a wild relative, and now we're talking about a project-related collection, Designing Future Wheat, and also a breeder toolkit collection that I'm going to present now. The reason I'm showing it here on our website is to say that you all can use it. So we are developing the germplasm in a specific project, but within a year, that's our agreement with the funder, within a year from everything that was developed, it's already available internationally. Before we published, so we're not worried about competition. We want people to use it. We are funded to support food security, and that's what we're doing. So of this one line, 70 lineages were generated out of 361 lineages of wild relative introgressions, and 5 of them moved forward to the breeder toolkit. This is the bridge. On one side, many academic institutes, and on the other side, international breeding companies. So I'll just go in very short and explain the concept. It's not always easy to cross wild relatives and the vehicle, so an elite line. So there's a lot of technology here that I'm not going to talk about at all. But once you manage to cross it, usually you have 50% of your genome is the landrace or the wild relative, and 50% is this vehicle that we're using. And then you back-cross it to the parent, and that's the pre-breeding that Nigel mentioned, and then you have 25% wild on 75% vehicle, and we go forward until we have 3% wild and 97% wheat. We generate the population, and this is the toolkit. So the toolkit is the vehicle from that population, the one with the 3% wild, and importantly, the molecular marker, the genomic marker that enables the breeder and the scientist to distinguish between the two. And for 10 years now, we send them through this project to several breeders that run field trials. So we were here in this. We were here in the case study. It was taken from the University of Nottingham, and then in the university it was worked on. The double haploid, the crosses were done. We have markers, and we know where in the world the genomic region that was introgressed from the wild is. So we generated crop wild relative breeder toolkit lines. That's the name that we use in the project. And as I mentioned before, 70 came from that Urartu species, and 5 of them were selected by the breeder toolkit committee that we chair, and that the industry and academic partners sit together and vote for. As I said, 70 lines were deposited back and 5 of them were taken forward. So this picture I took last week. Again, Simon Orford here. This is the head breeders of Lima Grain, a huge international company, in their field in Lima Grain, and Simon holding the paper. The paper has this graph that reminds the breeder why it is on his field. It is because this line with the wild relative component has higher yield compared to the vehicle, has higher yield compared to the pair, which is the important thing, and has nice amount of protein and also high specific weight, which is an important trait from the industry. This is what a modern breeding station of wheat looks like. In a medium to high volume, they will have between 600 to 800 lines in triplicates. These are 5-meter plots to measure yield. And this is done 2 years before 1 or 2 varieties from here will be offered to be national listed. So this is what we call the breeding funnel. So we went from the gene bank scale now to the breeders, and this is why they're so reluctant to add diversity. If you shake their funnel too much, they won't be able to make it to the market, and that's why we need to bring it in a form that they can swallow. So that's exactly what we're doing here. Yeah, so we were here. But what happened with these 361 lines? Did we forget about them? There's a lot of work to generate them. No, they were not good enough, or not. They weren't studied well enough to convince the industry that they need them. But we still have another project, and this is the protect and promote crop wild relative, where we grow this material in academia, both in UK, France, and also Italy, and measure nutritional quality and set of disease resistance to continue and evaluate them and produce knowledge and hopefully also impact. And all the germplasm is available globally under the SMTA. This is what it looks like in our field. These are the wild plants. We grow them. This is a test in microplots, so a meter square plot to study disease resistance, and this is plots that we work on to study to evaluate the grain quality. And I think, and I hope it was clear in the talk, and if not, I'll make it clear now, that there is no way to plan the work for 100 years. Watkins and Vavilov, they collected it 100 years ago with a vision, and they went some steps along the first one, along the first arrow. And seed conservation is the second one. And there's no way that we can go in a project, even a long project of 10 years from this point to that point. But what we can do within each project is move forward. If we have a map of where we push the diversity forward within the crop that we are on the crop wild relatives that we are expert for, we can go from here to here. And this is what we do to show impact and enable the funding of conservation and of new crop wild relative assembly, as we do as well through protect and promote crop wild relative and other projects. Okay, I just want to, I still have 2 minutes, I can slow down. I just want to thank my, the team in John Innes. I mentioned Simon Alford, who is leading the work of the Gene Bank in designing future wheat, and he's the wheat curator. And Warki, who is leading the work in ProWild. Richard, maybe to mention, put together the database. We have a bespoke database, and it's there, and he curates the data, and it's there for people to use. So go and check it out. And another shout of thank you for the GIC platforms. Without them, we wouldn't be able to do any of the work we do. And thank you for the invitation and for listening.
네, 좋은 발표 감사드립니다. 네, 이번 발표를 통해서 밀 야생 근연중 자원이 보전과 유전체 분석, 또 전 육종을 거쳐서 실제 육종 활용으로 이어지는 과정을 참 살펴볼 수 있었고요. 특히 존 이네스 센터의 유전 자원 관리 사례, 트리티움 사례, breeding fume, is that right? breeding fume, 네, 그런 사례가 인상적이었습니다. 참 인상적이었는데 제가 그 정확한 키워드를 잘 모르겠네요. 네, 다시 한번 감사의 말씀을 전해봅니다. 그럼 지금부터는요, 15분간의 휴식 시간을 잠시 갖도록 하겠습니다. 그래서 잠시 리프레시 시간을 갖고요. 오후 3시 40분, 다가오는 3시 40분부터 다음 마지막 세션을 진행하도록 하겠습니다. 네, 참가자 여러분께서는 35분까지 장내로 자리에 착석해 주시면 감사하겠습니다. 마련된 다과를 즐기시면서 좀 스트레칭도 하시고 좀 쉼이 되는 휴식 시간 되시면 좋겠습니다. 조금 뒤에 다시 뵙겠습니다. 감사합니다. 네, 잠시 후 5분 뒤인 네, 이제 마지막 세션만을 앞두고 있는데요. 저희는 잠시 후 3분 뒤인 오후 3시 40분부터 마지막 세션을 이어가도록 하겠습니다. 장내에 계신 분들 그리고 복도 쪽에 계신 분들께서는요. 이제 자리를 정돈하시고 착석해 주시면 감사하겠습니다. 네, 마지막 순서까지 우리 집중해서 좋은 프레젠테이션들로 인사이트를 가득히 얻어가시면 좋을 것 같습니다. 잠시 후 3시 40분부터 마지막 세션이 시작할 예정입니다. 장내에 계신 분들과 복도 쪽에 계신 분들께서는요. 이제 자리에 착석해 주시고 휴대폰이 무음 또는 진동인지 다시 한번 확인해 주시면 감사하겠습니다. 네, 이제 마지막 세션을 시작해 보고자 합니다. 참 두 번째 세션에서도 인상적인 발표들이 많았는데요. 특히 마지막 순서였던 노암 하이두 수석 연구원님이 말씀해 주셨던 것 중에 제가 단어를 정확히 몰라서 발음을 못했던 게 있었는데 브리딩 퍼널이더라고요. 육종 깔때기라고 하는데 약간 유전자 오디션 같이 그런 느낌이 들었고요. 그런 유전자들로 만들어진 씨앗이면은 집에서 키우더라도 좀 실패할 확률이 적지 않을까라는 생각도 해봤습니다. 저희 집에서 지금 감귤나무가 크고 있는데 좀 많이 아프거든요. 그래서 그런 생각도 해봤고 또 아까는 그 칼리 코엘 사무총장님께서 얘기해주신 그룹이 너무 인상 깊어가지고 함께 좀 가입을 해봐야겠다라는 관심도 생겼습니다. 네, 이렇게 이어서 저희는 지금 마지막 세션까지 달려왔는데요. 이어지는 마지막 세션의 첫 번째 발표, 베트남 건터대학교 메콩 연구소의 응우옌 흐우러이 책임 연구원님께서 진행해 주시겠습니다. 발표 주제는 다음과 같습니다. Participatory evaluation and utilization of CWR-derived rice materials in Vietnam. A story of bridging conservation, breeding, and farmer innovation. 베트남에서 CWR 유래 벼 자원을 참여형으로 평가하고 또 활용한 사례를 통해서 보전과 육종 그리고 농업 현장의 혁신을 연결하는 이야기를 들려주실 예정입니다. 네, 책임 연구원님을 따뜻한 박수로 맞이해 주시길 바라겠습니다.
Thank you. Thank you very much for the introduction. And good afternoon, everyone. So my name is Nguyễn Hữu Lợi, and I'm from Cần Thơ University in Vietnam. And can I ask you a question? Have you been to Vietnam before? Yeah, raise your hand if you have visited Vietnam. Huh? Thank you. I think a lot of you have visited Vietnam. But did you visit the Mekong Delta in the South Vietnam near Ho Chi Minh City, for example? No? Oh, this is quite interesting places that you can visit next time. Yeah, believe on me. Okay, today I would like to share the Vietnam experience in participatory evaluation and utilization of rough white relative on dry material. And I think in this session, gathered and focused on the reading. In this presentation, I would like to tell you about the story on how the rough white relative can move beyond the conservation and become the variety that the farmer actually grow in their field. So in this session, you may know many information about rough white relative, right? So in rice species also, the rough white relative contains the valuable genetic diversity. They provide us the very good traits such as disease resistance, tolerant to the stress, climate-related stress, and also, for example, like salinity, drought, heat tolerant also. And however, we can see despite the decade of research, only the very small of the percentage of the material have been reached the farmer field. The main reason I think is simple, that the stress tolerance is very valuable, right? But it alone is not enough for the farmers. Farmers also demand for the good quality, suitable maturity, acceptable the plant type, and strong market value, because this is their main livelihood, right? So therefore, the real challenges is not only finding the useful gene or material, but also developing a variety that the farmers actually want to grow in the field. So this slide, only me can see the slide, huh? Oh, sorry. Okay, here. Sorry. So in this slide, I show you the picture here, and I would like to say that show you the missing link in many reading programs in Vietnam and also in the global, that the process we start from the conservation to reading has been well established, right? In many programs, it's very successful in this stage. And then we move to the participatory evaluation, allow the promising material to be validated by the farmers under the real condition in their field. And then we identify the preferred variety in many based on their preference. And but many projects they stop here. And the best way to scaling up and adoption, it quite had a gap here. And toward the seed multiplication or commercialization in the large-scale adoption of the farmers remain unclear. And in this work, we aim to how to solve these gaps for the long-term sustainability of the breeding program. So I share you Vietnam experience here. You can see the map here in Vietnam, and I located in the Mekong Delta in the south of Vietnam. And there in Hanoi and here in Da Nang, and I saw many tourists from Korea to be here. But you can see here, in Vietnam, during the BORN project funded by the Norwegian government here, and we established the network for testing the variety across in 3 regions, in the north, the central highlands, and the Mekong Delta here. So in this work, we work with the local government. We work with the farmers, and they rip the seed club. I would like to say a little bit about this one. Seed club is the group of the farmers. They work together for 3 main functions. The first thing, in Vietnam, we have the extension network, and the seed club is where the government can work with them in the community collective model. So the government only needs to work with the seed club, then many farmers in the club, they work together. And this is the first function of the first club, that we can transferring the technology to the farmer easy way for the large scale and also for many farmers. The second function of the seed club in Vietnam, we have the seed production. This means that the seed system in Vietnam is not only from the public institution or the private company, it comes from the community-based seed bank. It's where the seed club, they can produce their seed in quality based on the government law and protocol, and then they sell or sharing the quality seed to the farmer within the community. In each community, we have the seed club, and they can sell their seed to the local with the reasonable price in comparison with the private company or the public institution. And finally, the main function of the seed club in Vietnam is participatory blend breeding. So in Vietnam, in 2007, we have the first farmer variety that breed and selection and released by the farmers under the support of the scientists. So we call it the farmer variety. And this has been recognized by the government at the national release. So in this case, we try to connect on the community together, and then we identify specific variety suitable for each location. Then you can see here. So you can see here, this is the utilization pathway, the way that we work in the BORN project in Vietnam, that you can see, we start with the block wide relative in the gene bank, and then we receive the re-reading material from Cornell University by Susan McCord, and she shared the material to IRI, International Rice Research Institute, and then the evaluation under different conditions like drought, heat, or submersion. And then they will share the material to us. After that, we share this material to the farmers for the evaluation and selection based on their own criteria. That means we share the material with the farmer at BC3F3. That means it's not the complete stable line, right? So then they will select based on their own experience and local condition. And after that, we do the participatory evaluation. At that time, farmers has select their own variety in their community. After that, we combine all varieties, so we get around more than 100 derived stable line. After that, we send the material for evaluation in different locations in Vietnam to identify which line is suitable for its location. And after that, we organize many activities in the field, like farmer field day or the field meeting, where we invite the local farmers and the other farmers not belong to our project to come and to evaluate. After that, we can identify the preferred variety for each community. After that, we will do some in-house testing. For example, we do for biotic or in biotic, like salinity, heat, and also route experience in the lab. And after that, we also do the markers for double check with the research. Finally, we identify the candidate that can be promising. And then we share this material to the government for them to identify and to evaluate based on the government protocol, for example, the DUS and VCU. After that, we have the national release. And later, I will show you we have got one variety release at the national level already, and we have 5 candidates in under the process for this one. So, you can see that participatory evaluation go far beyond the yield. We cannot, it's not only yield, right? It's many characteristics of the line. The farmer accept the multiple characteristics. They include the yield, they also the plant type, they also the stress tolerance, the cooking quality, and the market preference. And many objects cannot measure through the reader observation alone. It needs to be engaged with the many stakeholders in the system. So the farmer therefore contribute the unique knowledge that complement with the scientific reading. In this thing, the farmer, we call it the co-innovators with the scientists. It's not the end user. It will be the co-operator also. So, here, I always forgot. Okay. So here, one important finding from our project is that the farmer reference will be differ among the regions here. You can see here, in the north of Vietnam, in the central of Vietnam, and also in the Mekong Delta, the reference of the farmer is completely different. For example, you can see here, in the Mekong Delta, the farmer refer the high yield, but short duration. Because, why? Because in the Mekong Delta, we do the intensive farming systems. We have 3 crops per year, and the duration, it takes only 120 days, so it needs to require the variety that did a short duration. And also, we, in the Mekong Delta, we produce the seed, produce the paddy mainly for for selling and importing. So the eating quality also the main preference by the farmers, and also for the government oriented also. In the central of Vietnam, you can see the yellow here. The yellow here. So in this location, it is the mountainous areas, in the highland areas. So their water for farming mainly depend on the rain. This is a rain-fed location. So the drought tolerant and stable performance under the low input like nutrition and water will be important by the farmer here. And in the north of Vietnam, this quite different, because in the north of Vietnam, the land area will be smaller than the other region, and they mainly produce the reproduction for fed animal and also for local their own consumption. And this one they focus on the rain quality and also the culinary reference. Moreover, in the north of Vietnam we have many we call it cold weight. That means that time is very cold. So the cold tolerance also is the important trait for the farmer here. So this demonstrates that the regional adaptation is a trend rather than the weakness, and no single variety is the idea for every production environment. So we need to focus and we need to identify the specific adaptation variable. Here, this is the research. I mentioned that among more than 100 evaluated material, so we only select the small numbers that this consistence combine the high use, stress tolerant, acceptable rain quality, strong farmer acceptance. Here you can see here some candidate for nông dân variety here. I'm sorry, nông dân variety, this means the farmer variety. The variety selected by the farmers, it's Vietnamese term. And you see, the variety, they show very excellent performance across the location. But you can see here, not all of them performance on, right? For example, nông dân 2 and nông dân 2 here, they only perform well in the Mekong Delta, but it's not well in the other location. And this one, for the farmer reference here, you can see the reference between the scientist and the farmer also different. You can see this one, the phenotypic acceptability here is the evaluation by the scientist. And the farmer field day score here is evaluation by the farmers, and we collect the form from the farmer for their evaluation, and then we count for it. So it's also different. And here, but most of them you can see here, the range yield around 6 to 7 tons per hectare. This is the top hiding, yield hiding in high yielding in Vietnam also. And you can see here, this is the heat map. I summarize how frequently it were ranked number 1 by the farmers. So several interesting information you can see here. Luckily, we found nông dân 26 here. He ranked in the number 1 during the farmer field day in on location. For the others, it's only performance well in specific location here. And how we did this one, you can see here is some photos for you to, you can see here, this is in the north of Vietnam. We work with the local farmers, and in this, most of them using these pillars, and then we provide them the signal here, and they stick to the pillar, and we can count with variety have many signal. That means that is the best favorite variety. And here, you can see here, D-line variety compared with the local variety here is too late, right? Although the variety they already harvested still on the field. So this also not relevant by the farmer anymore. And here, we also invite the local government to come to work with our program for the evaluation based on the government objective. And then we combine on the sector here, we do the farmer field day, where we invite the local government, we invite the farmers, we invite the scientists, and we invite the reader here to come together to evaluation, and then we will discuss together to find the good variety in this location. And here is quite interesting. They figure that we use the voting for the field. We will give them number 1, 2, and 3, and then we let them go beyond to the field, and then we will select variety. If they most favorite, they will send number 1, and if they not, so they can skip this variety. So in this one, this slide, I would like to share with you about the case study of our recent national relief variety here. This is the Nông Dân 2 variety. Nông Dân 2 variety, they originated from the rough white relative, mainly from Phi-Bugong species, and this is improved by the rereading, and then we select in this. And this one is the plant variety protection certificate, and this one is the official release from the government for the national production. And this one is the farmer field day, and the farmer, they very happy with this variety for during the voting process. So here, we see that the number is very important in this slide. Sorry. Yep. We take around almost 15 years for selection from reading, from Master Cross until the official release. And this day, we have Master Cross in 2011 here, and after that we have the backboxing process in evaluation in the ERI, and then we receive the material in 2019. After that, we do the process selection and evaluation, and then until 2026, it has been released. So it takes 7 years already for this slide, right? So you can see here, the Nông Dân 2 variety, they have very good duration, because when mean for the tree crop intensive identification, and then they had the high yielding, they had the eating quality, they had suitable for the alternative wet and right technique for saving water and toward the low carbon drive variety. And then they had the resistance to brownland hopper, the major pest in the right field, and this is the farmers selected in most location in the specific location. And then, so from this information, I would like to share with you about several lessons from Vietnam. The first is the rough white relative can perform extremely well under the real farming condition. The second thing, that the stress tolerance along is not insufficient, and the rain quality remain equally important. The third, the farmer evaluation revealed the adoption potential that the reader section alone cannot identify, I think. And finally, the participatory evaluation significant increase the confidence in the future dissemination nation, because at that time we get the brief referred by many variety by many farmers, so we can identify the chocolate for release and scaling up in specific location based on the research from us. And here, although the farmer refer variety have already identified, and a major gap or the point have been exist in the large scale adoption here, I saw that how to scaling up and sharing material in the large scale for adoption by the farmers. So this many promising variety never reach the last adoption. It's only the small scale, and they cannot develop in the big impact to the farmer community. So the reason include the first one, I think, is the limited in seed multiplication. The second thing is the weak private sector investment, because we mainly produce the rice for selling, and the weak in private sector investment, it means that when we reduce the rice production, so we cannot sell. So this is also the challenge for the farmer, although they really like your variety. But if they grow in their field and the buyer, they come and they said, oh, I don't know this variety. Yeah, it's very small. I cannot buy this variety because we cannot put it in the pot for exporting, for example. So the problem and the challenges for the scaling up, and also we need to engage more private sector to come to our process. And we think the long-term investment, also the critical question. Some project you can see is very successful, right? It's very successful, but when the project stop, the activity will be decreased. The activity will be decreased, and no more talk about it, or they cannot clear up for the long term of sustainability. So the invest for more stakeholder in our activity will be make sure that we can encourage the stakeholder to work for the long-term sustainability. And here in Vietnam, we propose the solution is the public-private farmer partnership. What is it? The public institution, they generate innovation through the breeding program, and then the farmer will be validate material under the real condition, and after that, the private company will contribute for investment in seed multiplication, marketing, commercialization, government support, and then we can move to the government. The government will be support for the certification, intention, and policy. Together, they will, the stakeholder will create a complete innovation ecosystem capable for connect the stakeholder together, and we can scaling up variety to the million farmers. And then here there are some principles during the partnership that the public researcher, they will create innovation, and then we move for the farmer to validate the innovation. After that, we encourage the private company for early scale. We don't need to wait until we release variety, and then we encourage the private company. It's late, so we need to encourage them in very early stage. So the private company can scale this innovation, and the government can enable the innovation. So to ultimately, the society benefit through the improved food security, the great climate resilience, and the stronger, we can have a stronger rural livelihood for the farmers under the impact of climate change for the uncertain condition. And then, this one, I think when we did the robot solution I mentioned, the partnership alone is not sufficient. So we need a strong legal framework to make sure that the partnership can be run well. Our pathway is to begin with the SMTA, yes, and then we in the standard material transfer agreement, so we can enable the legal access to the worldwide relative genetic, and while we ensure the pair benefit for sharing. And then we do the participatory evaluation to identify the superior varieties. After that, we have apply for the plant variety protection, recognize that the breeder's intellectual contribution, and create the confidence for the private sector, they invest in our variety. And finally, our framework can be worked done if the activity can be done. And you can see here, this is the very nearly in 30th of June here. This is the plant protection certificate from our project here. And you can see here, who are the owner of the PPP. This is Cần Thơ University, our institute here. And who is the author of varieties? It will be the farmers. It will be the breeder at the breeding stage. It will be the one who contribute in the process for participatory selection and also evaluation. So in this mechanism, it makes sure that all partners, all contributor can be equal in the right. And then here, so far I have shown here for how CWR derived material can become official release. However, I believe it is not to the end of the story. The release CWR derived varieties should not only consider successful of the product, they should become the valuable parents for the next generation. So by roasting in Vietnam, we also roast the farmer refer CWR derived variety with the local language and also the local variety to make it continuous breeding for continuous breeding cycle where variety can be contribute to the future genetic improvement. And here, some people ask me why we need BBB and why we, although we have the SMTA, right? So the question is, continuous innovation will require the institutional environment, and these are two mechanisms will be particularly important. The SMTA will be provide the legal access for the genetic material, and the BVB protect the farmer. That mechanism can be worked together to make sure that the confidence of the all stakeholder can be contribute and investment in the process. And finally, I would discuss because the time is already. So I just talk this one a little bit. To summarize the one story I propose, we have 3 levels of utilization framework of the CWR species. The first level is genetic utilization. Here, the conserved CWR diversity is transformed into the improved breeding material through the germplasm access and the trait recovery or something like that, like Matt introduced. And then we move to the Then we move to the second layer, the farmer utilization. The farmer evaluate whether the material actually fit with their local needs or this measure that the reference assessment and multi-location testing that measure the farmer accept. And then we move to the high top of levels, either societal utilization. This is where the farmer reference a variety move through the variety release, scaling up, and finally for the large scale adoption. So the key message in this slide is very simple. The conservation creates the potentials, but the impact only happen when the genetic innovation, the farmer validation, and society scaling are connected together. And I hope that this framework can support the future effort to strengthen the conservation and sustainable utilization of crop variety in ASEAN crop variety working group. And to conclude, in conclusion, Vietnam demonstrated that the crop variety can be successful move from the gene bank to the farmer field, and participatory evaluation provide the practical bridge between the breeding and adoption, and the public-private farmer partnership can create the practical pathway for scaling, and finally, the component transform the conserved genetic diversity into the real impact to the farmers. Thank you. Thank you for your attention.
Alright, thank you for the great presentation. 네, 귀한 발표 감사드립니다. 네, CWR 유래 벼자원을 통해서 보전과 육종, 농업 벽장의 혁신을 연결한 뜻깊은 사례를 보여준 발표였습니다. 네, 그럼 이어서 마지막 발표를 소개해드리겠습니다. 어느덧 마지막 순서까지 왔죠. 한국의 CWR 보전 성과와 국제협력 그리고 아시아 협력으로 확장되는 향후 방향에 대해서 한국수목원 정원관리원의 나채선 실장님께서 말씀해 주시겠습니다. 네, 큰 박수 부탁드리겠습니다.
예, 안녕하십니까. 방금 소개받은 나채선입니다. 드디어 한국어 발표를 듣게 되셨습니다. 예, 많이 힘드셨을 것 같고요. 저는 한국어로 시간 관계상 조금 줄일 수 있으면 줄여가면서 발표하도록 하겠습니다. 먼저 발표를 시작하기 전에 소개를 좀 드리고 싶은 부분이나 세세한 부분이 있는데, 이렇게 훌륭하신 분들이 앞에서 발표를 하고 왜 내가 마지막에 하는가 말씀을 드리자면, 첫 번째는 국제기구의 역할, 그리고 두 번째는 그러면 그 다음으로는 국가가 어떻게 해야 되는가, 그리고 그러면 그 국가 안에서의 수목원의 역할은 무엇인가, 그리고 그렇게 보전된 자원들이 어떻게 활용되고 있는가를 보여드리고 싶었던 거고요. 그 다음으로 제가 발표하는 이유는 그러면 한국의 그 중간에 있는 수목원은 그거에 대해 잘 발맞추어 가고 있는가를 보여드리면서 마지막 패널 토론 때 앞으로 한국이 나아가야 될 방향에 대한 이야기를 듣고자 이런 순서로 마련하게 되었습니다. 그리고 또 하나 말씀드리고 싶은 거는요, 되게 사소하지만 저희 아마 뒤에 보시면, 그리고 돌아다니면서 보셨겠지만 아마 검은 티셔츠에 스태프라는 명찰을 붙이고 있는 저희 실원들을 보셨을 거예요. 그 실원들이 준비한 기념품 중에 아마 책상 옆에 붙어있는 쇼핑백이 있는데요. 그 중에 하나를 좀 소개를 해드리고 시작하고 싶어서, 저희가 이번 기념품으로 되게 작아서 안 보이실 수도 있는데 이 심포지엄이 계속 기억되었으면 하는 바람을 가지고 종자 키링을 만들었습니다. 이 안에 종자는 우리나라의 CWR 종자고요. 그리고 또 저 아마 바깥에서 보셨을 패널에 붙어있는 종자들인데, 이거 하나하나를 시간 내에 저희 친구들이 다 찍어가지고 만들어 놓은 거라서 이거를 꼭 한번 소개해드리고 꼭 이 심포지엄이 오래오래 기억되었으면 하는 바람을 가지고 시작하도록 하겠습니다. 예, 그러면 이제 발표를 시작하도록 하겠습니다. 저는 한국의 그러면 크롭 와이드 렐러티브라는 것이 어떻게 시작되어서 처음에 보전부터 현재 나아가는 방향까지에 대해 발표해 드리겠습니다. 처음 저희의 프로젝트는 2021년에 시작했고 1단계는 올해 2026년이 마지막입니다. 그리고 2단계로 계획을 하고 있는 부분이 27년부터 31년 또 5년의 간격을 가지고 진행될 예정이고, 그리고 마지막으로 잘 몰랐던 이 CWR이라는 것에 대해 알리기 위해 우리는 어떤 일들을 하고 있는지라는 부분을 가지고 말씀드리겠습니다. 예, 먼저 첫 번째 저희가 했던 일들입니다. 실은 그런 생각을 했어요. 너무 다 아시는 분들이 발표를 해주시니 이 CWR을 잘 모르시는 분들 앞에서 한 번 더 무엇인지 소개해드려야 되지 않을까 해서 페이지를 만들어 보았습니다. 야생에서 자라고 있는 작물의 친척, 그리고 작물의 기원이 됐고 작물과 가장 가까운 야생식물이라서 앞으로 우리의 먹거리가 될 수 있는 그런 자원들을 CWR이라고 하고요. 기후변화에 대한 기후 적응성도 가지고 있고 병저항성, 환경저항성 등의 다양한 특성을 가지고 있기 때문에 보존하고 앞으로 식량 안보에 꼭 필수적인 야생 자원이다라는 것을 말씀드리고 시작하겠습니다. 그럼 처음에 저희가 왜 한국의 CWR이라는 프로젝트를 시작했는가? 제가 이거를 공부를 하면서 많이 찾아보면서 느꼈던 점은 많은 글로벌 이니셔티브와 연구들이 진행되고 있는 와중에 한국은 다양한 자원이 있음에도 불구하고 이 부분에 대해 명확한 정의를 가지고 좀 발전시켜 나가지 못했던 것 같아서 이 부분에 제안을 드렸었고, 다행히 이 부분에 대해서 많이 동의를 해주시면서 저희 한국수목원정원관리원이 가진 강력한 인프라 그리고 우리나라 자원을 가지고 그럼 한국이 아마 아시아를 대표할 수 있는, 리드할 수 있는 한번 국가가 돼보자, 그러면서 베이직한 걸음을 시작하게 되었습니다. 네, 그래서 저희는 말씀드린 것처럼 21년부터 26년까지 1단계고요. 처음 저희의 목적은 일단 보전에 초점을 맞춰서 앞으로를 대비하자는 것을 목적으로 시작을 했고, 주요 내용으로는 그럼 국가의 CWRN 자원이 무엇이 있는가, 그럼 목록화를 만들어보고 그 다음에 자원을 수집하고 보전하고 그리고 활용을 위한 특성 정보를 분석해보자라는 것을 가지고 시작했습니다. 네, 저희의 각 단계들은 실제 글로벌 CWR 프로젝트라는 것을 모티브로 시작했기 때문에 먼저 목록을 만드는 걸 최우선으로 했고, 종자의 수집과 보전 그리고 그 각각에 대한 특성에 대한 조사를 진행을 했고요. 실은 프리브리딩이라고 하지만 실제 육종을 하시는 교수님들과 함께 이거에 대한 기본적인 정보를 갖춰야 앞으로 활용할 수 있겠다라고 싶어서 이런 단계를 거쳤고, 그리고 이게 아무래도 CWR은 자원 자체가 주요한 산림 자원이고 바이오 소스로서의 가치가 충분하다라고 생각했기 때문에 기업과도 협력해서 바이오 프로덕트로 만드는 것까지 생각을 하면서 진행을 했었습니다. 네, 먼저 처음 목록에 대해 말씀을 드리면 실제 저희가 처음 이걸 시작할 때는 글로벌 CWR 데이터베이스에 우리나라 식물이 188종 정도가 등록이 되어 있었습니다. 물론 저희는 몰랐고요. 찾다 보니까 우리나라에 분포하는 자생식물이라고 등록이 되어 있음에도 불구하고 저희가 잘 몰랐었기 때문에 이 188종을 가지고 시작해보자라고 시작을 했는데, 앞서 처음에 나이젤 박사님의 발표를 듣고 보니 더 많은 범위의 목록이 있고 그것에 대한 체크리스트를 가지고 발전시켜 가야겠다라는 생각이 들었습니다. 그래서 이 부분에 있어서는 저희는 전체 글로벌 데이터베이스의 분석이라던가 앞으로 기후변화 시나리오에 대비해서 우리나라 야생식물이 자생식물이 어떻게 분포지가 변화해 갈 것인지 이런 걸 가지고 우선순위를 만들어 봐야겠다라는 생각을 했고요. 이 부분에 대해서는 저희가 부족한 점을 보완해 가면서 올해 계속 진행을 하고 있습니다. 먼저 저희가 처음 시작할 때는 당연히 이 부분에 대해 잘 몰랐기 때문에 제네시스라던가 GBIF 그리고 그린 글로벌을 가지고 한국에 분포하는 CWR에 대한 목록화를 먼저 시작을 했고요. 그리고 그것에 대해 수집을 하고 저희가 전국적으로 그럼 자생지가 어디에 분포하는지를 조사해 가면서 국립대학교와 함께 협력을 해가면서 종자를 보전하고 이 종자를 키워서 식물체로 또한 보전하는 이런 역할들을 진행하고 있습니다. 네, 그리고 말씀드린 것처럼 그러면 우리가 가지고 있는 우리의 자생식물이 정말 앞으로도 꾸준히 보존할 수 있고 자생지에 계속 분포하는지, 가장 뭘 먼저 수집해야 되는지 이런 것들을 알아봐야 되기 때문에 기후변화 시나리오에 따라서 어떤 결과를 보여주는지에 대한 분석을 진행을 했고요. 이 메디카고라는 속은 아마 다들 너무 잘 아실 것 같은데 알팔파라는 저희 개자리 속을 말하는 거고요. 우리나라는 실제 개자리 속에 자생식물 한 종밖에 없다고 알려져 있는데 그 외에 분포하는 식물들은 꽤 되고 있습니다. 그래서 이 메디카고 종에 대해서 분포지 변화 예측을 했을 때 어떤 종 같은 경우는 기후변화 시나리오가 있어도 계속적으로 분포를 할 거고, 어떤 종 같은 경우는 기후변화 시나리오가 최악으로 갈 경우에는 우리나라에서 사라질 수도 있다라는 것을 가지고 그럼 뭘 먼저 수집하고 보존해야 되는가라는 부분을 염두에 둔 분석이었고요. 다음으로는 저희 실제로 이런 그 CWR에서 작물이 되기까지 형태적으로나 유전적으로 어떻게 변화해 갔는지를 가지고 형태에 대한 비교라던가, 그 다음으로는 작물과 어떤 차이가 있는지 그런 유전 분석을 진행을 했는데요. 실제 저희가 이 유전 분석을 진행한 또 하나의 이유는 아무래도 야생식물이다 보니 너무 데이터가 없었습니다. 너무 데이터가 없기 때문에 기본적으로 엽록체 유전체에 대한 유전자 분석을 하고 그것과 작물이 얼마나 가까운지, 실제 그 중에 어떤 게 더 가까운지를 좀 더 확인해 보고자 진행을 했고요. 매년 수집된 종에 대해서 속별로 1년째 키운 다음에 새 잎을 또 뜯어가지고 실험을 했기 때문에 이 실험 하나하나는 꽤 많은 시간이 걸렸다라고 말씀을 드리고 싶습니다. 네, 이런 식으로 저희가 목록화를 하면서 어떤 게 더 중요할지, 그리고 어떤 게 더 가까운지 이런 부분에 대해 고민을 했는데, 앞서 말씀드린 것처럼 더 많은 것을 베이스라인에 두고 다시 한 번 더 보완해 나가야 되고 체크해 가봐야 되지 않을까라고 생각하고 있습니다. 다음으로는 종자 수집인데요. 실제 이 부분 같은 경우는 경북대학교에서 책임을 해가지고 전국에 도별로 있는 대학교들을 모아서 지역별로 종자를 수집해주고 계십니다. 실제로 이 부분 같은 경우는 저희가 타겟한 200종만 수집을 하는 게 아니라 앞서 발표해 주신 것처럼 같은 속에 있는 모든 야생식물을 수집하고 있기 때문에 지금 현재까지 약 1,900여 점을 가지고 수집을 했고요. 그 종 단위로도 저희가 원래 6년 목표했던 거는 약 130종 정도였는데 그보다 훨씬 더 많은 수의 종자를 수집을 하고 있습니다. 그리고 저희가 이런 역할을 하다 보니 중앙아시아와 끈끈한 네트워크를 가진 기관으로서 중앙아시아에는 어떤 자원이 있을까라는 부분에 대해 같이 고민해 봤는데요. 중앙아시아 같은 경우는 오히려 저희 생각보다 훨씬 더 많이 다양한 자원을 가지고 있는 자원의 보고였고, 그래서 2023년부터는 같이 종자 수집을 할 때 그 나라의 CWR이 뭐가 있는지를 확인하고 그 부분도 포함해서 종자를 수집하고 보존하는 역할을 하였으며, 그 후에는 현재 올해 같은 경우는 생물 다양성의 핫스팟이죠. 조지아까지 포함해서 종자 수집에 대한 부분에 같이 협력하고 있습니다. 네, 이렇게 수집된 종자는 당연히 저희가 종자 은행이 있고 앞서 잘 아시는 것처럼 시드볼트가 있기 때문에 안전하게 장기 보존을 할 뿐만이 아니라 증식 재배를 통해 다시 종자를 벌크업 재생산을 하고, 그리고 또한 잘 키워진 이력이 관리된 식물 같은 경우는 전시원으로 내보내서 이것들을 알리는 역할도 하고요. 또한 연구 재료로도 사용이 될 뿐만 아니라 재배에 대한 표준 매뉴얼을 만드는 것까지 하여 연구를 진행을 하고 있습니다. 그리고 저희가 시드 뱅크를 운영하는 데 있어서 아마 계속 앞에서도 많이 말씀해 주셨을 거예요. 야생 종자다 보니 바이어빌리티 테스트를 하는 기본적인 매뉴얼도 없고 정보가 많이 없다라고 해서 저희는 뱅크에서 어떻게 검사를 해야 되는지에 대한 기본적인 정보들을 계속 구축을 하고 있고요. 저희 원래 처음 시작할 때의 목표는 이스타와 큐에서 만든 테스팅 와이드 시드라는 야생 종자 검사하는 방법을 등록하는 사이트가 있습니다. 거기에 저희가 개발한 방법들을 등록하는 것을 목표로 시작했는데, 이 사이트가 올해 여름이 돼야지 다시 한번 리오픈을 한다고 해서 그 이후에 그 부분은 논의를 하기로 하였습니다. 네, 바이어빌리티 테스트에는 지금까지처럼 발화 방법을 하는 것도 있지만 비파괴 종자 검정 방법이라고 해서 멀티 스펙트럼을 이용한 분석 방법도 있고요. 그래서 종자에 대해서 저희는 계속 최신 기법을 연구하고 있다라고 말씀을 드립니다. 또한 종자가 얼마나 오래 저장이 가능한지, 저장이 가능한 종자이긴 한지 이런 것들을 알아야지 더 안전하게 보관할 수 있기 때문에 종자의 저장 특성이나 수명에 대한 연구도 꾸준히 진행을 하고 있습니다. 예, 또한 너무 잘 아시다시피 이렇게 잘 저장하고 나서 나중에 꺼냈을 때 못 쓰게 되면 안 되기 때문에 발화에 대한 기본 조건은 저희가 지속적으로 탐구를 하고 있고요. 여기까지가 저희가 이 종자를 안전하게 보존하기 위해 시드뱅크와 시드볼트에 보존을 하기 위해 하는 연구들이었고요. 다음으로는 그럼 CWR이기 때문에 미래 육종 자원으로서 사용을 하기 위해서는 기후변화 적응성이라던가 환경 스트레스에 대한 얘네 특성이 무엇인지를 알아야지 더 선발하고 활용하기 좋기 때문에 스트레스 톨러런스에 대해 저희는 기본적인 테스트도 하고 있습니다. 환경 저항성으로 가뭄이라던가 혹은 염 저항성 등을 테스트를 하고 있고요. 이것 같은 경우는 어바이오틱 스트레스라고 해서 이런 환경에 대한 특성을 보고 있을 뿐만이 아니라 이거 같은 바이오틱 스트레스, 그래서 패스트나 병 같은 거, 병에 대한 질병에 대한 저항성도 테스트를 하고 있는데요. 실제 이거 같은 동부속의 CWR 종자를 녹두와 동부와 함께 비교한 데이터라고 보시면 될 것 같습니다. 네, 그리고 그 다음으로 저희는 이런 특성까지 종자의 특성이라던가 식물체가 그럼 스트레스에 따라 종자가 스트레스에 따라 어떻게 발화하는지까지를 본다면 그 다음으로는 실제 공주대학교에서는 육종을 잘 하시는 교수님이 계시고요. 육종에 사용할 수 있는 그럼 진짜 좋은 소재가 무엇인지 어떤 진을 선발해야 되는지 이런 진 선발이라던가 프리브리딩을 위한 소재 개발을 위해서 계속적으로 연구를 해주시고 계십니다. 그래가지고 저희는 그거에 대한 소재라던가 정보를 공유해드리고 공주대학교에서는 좀 더 심도 깊은 육종에 대한 연구를 해주시고 계시고요. 그럼으로써 우리 자원이 보전에서 그치는 것이 아니라 실제 활용에 넘어가기 전 단계까지의 데이터를 같이 쌓고 있다라고 보시면 될 것 같습니다. 예, 그리고 마지막으로 말씀드린 것처럼 저희는 이 산림 자원들이 어떻게 소재로서 활용이 돼야 되는지에 대한 부분도 연구를 하고 있는데요. 왜냐하면 저희는 많은 야생 자원을 가지고 있고 이 자원이 얼마나 많이 먹었었는지 그리고 전통적으로 약에 쓰였는지에 대한 많은 데이터를 구축하고 있습니다. 그렇기 때문에 이 소재들이 단순히 육종 소재로서의 가치도 매우 중요하지만 그럼 전통적으로 의학으로 쓰였던 자원이라면 또한 바이오 소재가 충분히 될 수 있기 때문에 기업과 협력을 하고 있고요. 기업에서는 매년 저희 소재와 데이터를 가지고 더 심도 깊은 항산화라던가 이런 연구를 통해 제품을 만들어서 실제 온라인이나 가게에서 판매를 하고 있습니다. 그래서 저희는 이 부분은 2023년부터 같이 기업과 제품을 쭉 개발해 왔고요. 실제 이런 개발된 제품들을 또 선물로 주거나 홍보에 사용을 하면서 이 소재가 얼마나 중요한지를 알리는데도 또 한 가지의 목적을 가지고 진행을 하고 있습니다. 네, 그리고 제일 중요한 거는 이런 데이터들이 저희만 갖고 있고 여기에 머물러 있으면 안 된다고 생각을 하는데요. 그래서 저희는 CRPD야라고 해서 그것을 지난 8월에 런칭을 했습니다. 지난 8월에 런칭해서 저희가 가진 연구 데이터를 모두 대중에게 공개를 하고 있는데요. 물론 아직 많은 데이터가 부족하긴 하지만 지속적으로 데이터를 쌓아가고 있고 많은 분들이 활용해 주길 바라고 있습니다. 그리고 이 데이터들이 물론 다른 여러 사이트들과 연계돼서 좀 더 퀄리티 있고 그리고 많은 분들이 볼 수 있는 사이트가 되기도 또한 바라고 있습니다. 네, 여기도 물론 각 자원에 대해 희귀식물인지 특산식물인지 혹은 그리고 CWR인지 또한 데이터 업데이트를 하고 있는 중이라고 말씀을 드리고요. 그리고 저희가 실제 1단계는 한국의 자원을 먼저 보전하자였는데 말씀드린 것처럼 중앙아시아와 함께 하다 보니까 아시아 지역 콜라보레이션이 조금씩 완성돼 가고 있었습니다. 그래서 아시아와 함께 중앙아시아 그리고 조지아와 함께 종자의 수집 그리고 저희가 직접 가서 현장에서 종자를 어떻게 수집해야 되는지 그리고 초청을 하여 종자를 그럼 어떻게 관리해야 되는지에 대한 교육을 지속적으로 진행을 하고 있고요. 그리고 유럽과는 저희가 다양한 이유를 가지고 협력을 했을 때 지금 최근에 벨기에 메이서 식물원과 영국의 왕립식물원 MOU를 하면서 CWR에 대한 더 많은 협력을 진행을 하자라는 논의가 이루어졌습니다. 그리고 여기 지금 두 개의 국제기구가 다 와 계신데요. FAO와 아포코가 올해 처음으로 FAO를 직접 방문하면서 저희가 혹시 더 배울 점이 무엇인지 그리고 함께 할 수 있는 점이 무엇인지에 대한 논의를 드렸었고요. 그래서 오전에 마리오 박사님께서 해주신 DOI라던가 이런 레코딩에 대한 이력을 저희가 직접 받고 있는 상황입니다. 이런 넘버들을 통해서 저희가 국제적으로 활용할 수 있도록 노력을 하고 있고 또 하나는 저희가 백두대간 글로벌 시드볼트가 스웨바르 시드볼트처럼 국제 인증을 받을 수 있는가에 대한 질문도 한번 드렸었는데 그거에 대해서 최근에 검토해준 답변이 와가지고 저희가 좀 더 나아갈 수 있지 않을까라는 기대도 하고 있습니다. 또한 아포코와는 협력은 먼저 제시해 주시고 관심을 가져주셔서 저희가 어제 매우 성공적으로 아시아 CWR 워킹그룹을 발족을 할 수 있었는데요. 이를 계기로 아시아의 13개 국가가 협력하고 더욱더 발전해 나갈 수 있지 않을까 하는 기대를 가지고 올해까지 이런 일들을 진행하고 있다라는 것을 말씀을 드립니다. 예, 그러면 앞으로 27년에 31년에 2단계에서는 우리가 어떤 변화가 있을 것이고 발전을 할 것인가 라는 부분을 말씀을 드리자면 실제 1단계와 2단계의 가장 기본적인 골격은 그대로 진행되고 단지 기술이 더 발전될 것이라는 것, 그리고 저희가 더 당연히 발전해야 된다는 것을 말씀을 드리면, 저희는 현재 시드볼트와 뱅크를 기반으로 장기 저장 가능한 종자만 계속적으로 저장을 하고 있는데, 저희의 또 다른 숙제는 말씀하신 것처럼 저장이 불가능한 종자에 대해 현지 내에서는 어떻게 할 것이고, 그럼 리빙 컬렉션으로서는 어떻게 수집을 하고 보존할 것인가, 이 부분을 고민을 하고 발전시켜야 되는 걸 최우선으로 저희가 하는 과제 중에 또 다른 하나의 미션이라고 생각을 하고 진행을 할 예정이고요. 그 외에 추가적으로 그럼 어떤 부분이 더 차별성이 있는가라고 하면, 저는 어제 실은 나이젤 박사님의 강의를 따로 개인적으로 화요일 정도 오전에 한번 들은 적이 있습니다. 그리고 오늘 또다시 들으면서 그럼 우리가 국가의 전략을 정말 어떻게 수립해야 될지를 한 번 더 고민을 하고요. 그리고 아시아 CWR 워킹그룹이 올해 발족을 했으니 내년부터는 운영을 잘 해야 될 텐데 이것을 가지고 어떻게 발전시킬지, 그리고 오늘 미식회에 참석하신 네 외빈들은 많이 감탄하셨는데, 한국에서는 야생자원과 나무를 잘 먹는데 이런 문화를 어떻게 CWR에 접목시킬 수 있는지, 그리고 마지막으로 글로벌 콜라보레이션 중에 저희가 작년부터 조정했던 호라이즌 유럽이라는 큰 국제 프로젝트가 있습니다. 이것에 대해 지속적으로 지원하면서 발전을 해 나가야겠다라는 생각을 가지고 크게 4가지 카테고리로 더 발전 방향을 만들어 봤는데요. 저희가 얼마 전에 FAO에서 만들어진 CWR 보전 전략, 그리고 내셔널 컨저베이션 스트래터지를 보면서 국가에서는 어떤 단계로 보전 전략을 수립해야 되는지를 가이드북을 보면서 공부를 좀 했습니다. 그러면서 저희가 이제 내년부터는 이 절차를 가지고 좀 더 지금 현재 우리가 하는 방식을 고도화시켜야겠다라는 생각을 가졌던 거고요. 이 PRFA 스트래터지에는 크게 CWR, 그리고 랜드레이스, 그리고 진뱅크의 역할들이 담겨져 있었는데요. 그중에 저희가 CWR에 대한 보전 전략을 앞서 나이게 박사님이 발표해 주신 것과 함께 접목하면서 국가의 우선순위, 그리고 전체의 베이스라인, 체크리스트 등을 통해서 다 발전을 시켜야겠다라는 부분에 대한 것을 하나의 미션으로 가지고 올해 2번째 단계에서는 이 부분을 발전시켜 나가겠다라고 생각을 하고 있고요. 이 가이드라인에 따라서 제일 중요한 건 저희가 현재 이 5년 동안은 엑스시추라고 해서 종자 은행에만 더 집중을 했다면, 인시추라는 것이 굉장히 중요하다는 것을 이번 심포지엄을 통해 많이 배웠고, 이 인시추에 대해서 우리가 어떻게 나아갈 수 있는지 같이 하는 전문가들과 협력해서 이 부분도 같이 담아야지 보전이 좀 더 완벽해지지 않을까라는 부분과 함께 모든 이해관계자들과의 협력이라던가, 그리고 저희가 저장하는 방식이나 이런 부분에 대해서 더 고도화해야 된다라는 것들을 직접 접목시켜 나가야겠다라는 생각을 했습니다. 그리고 2번째 차별점으로 아시아 CWR 워킹그룹입니다. 아시아의 많은 자원, 그럼에도 불구하고 모든 국가별로 있는 차이, 갭이 있고요. 그리고 인프라의 차이라던가 역량의 차이라는 부분은 당연히 있을 수밖에 없는 부분임에도 불구하고, 유럽에서는 이 CPGR이라는 이 새로운 유럽 간의 이니셔티브가 있고 IUCN의 이니셔티브가 있는 것을 본보기로 삼아서 이것을 목표로 삼아서 저희 아시아 CWR 워킹 그룹도 잘 운영을 해봐야 되지 않을까라는 생각을 하면서 이 5개의 콜라보레이션 파트를 같이 제안을 했었고요. 당연히 처음에는 저희는 아무래도 각각의 플로라가 무엇인지, 종자를 어떻게 보존할 것인지, 그 다음엔 중요한 건 에듀케이션, 캐퍼시티 빌딩이라서 각각의 역량을 서로 어떻게 상호 보완적으로 키워 나갈 것인지, 그리고 이 종자와 자원을 어떻게 활용할 것인지, 계속 되었던 주제였잖아요. 보존해서 끝나면 안 되고 이것이 활용까지 연계되면서 지역 협력체와 함께 발전해 나가야 된다는 부분을 충분히 배웠고요. 각 국가별의 트레디셔널 날리지를 어떻게 전통 지식을 보존을 해야 이 부분이 앞으로 연계될 수 있는지라는 부분을 가지고 총 5가지의 협력 분야를 발전시켜 나가려고 하고 있습니다. 예, 그리고 한국의 문화라고 오전에 소개를 시켜드리면서 두메부츠 페스토라던가, 아마 저희 다과에도 그 메뉴들이 다 있었어요. 야생자원을 직접 드셔보시면서 우리는 이것을 먹고 얼마나 많은 자원이 우리에게는 식용 가능한 식물인지를 말씀을 드렸었는데요. 이런 난리지를 저희가 그냥 우리가 담겨두는 게 아니라 좀 더 디지털화하고 데이터화해서 잘 보존을 해야 되고, 이런 부분들을 가지고 저희는 새로운 새로운 CWR의 가치를 단순히 먹는 거가 아니라 이 패러다임을 eat to save라고 해서 보존하기 위해선 또한 먹어라 라는 패러다임의 전환을 가지고 미래를 위한 자원이지만 현재를 위한 자원도 될 수 있다라는 생각을 가지고 발전시켜 나가려고 하고 있고요. 저희는 이런 많은 사업들이 실은 유럽에서 벤치마킹한 경우가 많았는데요. 이것 또한 노르젠 북유럽 유전자원센터에서 식품연구소와 함께 메뉴를 개발하고 미슐랭에 실제 그런 재료들이 납품된다는 것을 확인을 하고 그 예시를 가지고 도전해 볼 수 있는 분야이고 우리가 가져갈 수 있는 강점이겠다라는 생각을 가지고 진행을 해보려고 하고 있습니다. 그리고 마지막으로는 글로벌 프로젝트입니다. 저희가 지난해 호라이즌 유럽에 열심히 도전을 했지만 아쉽게도 선정이 되지 못했습니다. 근데 그럼에도 불구하고 거기서 배운 점도 너무 많았고 유럽과 협력할 수 있는 다양한 방법이 있구나라는 것을 가지고 유럽과 연구 협력을 진행을 할 수 있다고 생각을 해서 진행을 해보려고 하고 있습니다. 저희는 지난해 저희를 어필하는 또 하나로 아시아의 자원의 허브가 될 수 있고 우리는 충분히 좋은 인프라와 역량을 가지고 있습니다. 라는 것을 가지고 어필을 했었고요. 많은 분들의 도움으로 어쨌든 호라이즌 유럽에 무사히 지원을 한 경험이 있습니다. 그리고 현재는 또한 다른 컨소시엄에 포함돼서 다른 콜을 가지고 올해 9월에 한 번 더 지원을 하려고 하고 있고요. 제가 지난주 실은 한국에 온 지 얼마 안 돼서 저도 실은 시차가 지금 말이 아니긴 한데요. 지난주에 벨기에에서 열렸던 호라이즌 유럽 네트워킹 포럼이 있었습니다. 거기에 저희 클러스터 6의 연구기관, 한국의 연구기관으로 유럽의 연구자들과 만나면서 어떻게 호라이즌 유럽에 참여할 수 있는가를 논의를 하고 왔는데요. 그러면서 또 다른 많은 파트너들을 찾고 협력해 줄 수 있는 분들을 만나고 와서 좋은 기회였다고 생각을 하고 있습니다. 현재 말씀드린 것처럼 저희는 스웨덴 농업대학교랑 작은 컨소시엄을 꾸려서 발전을 시켜 나가고 있는 중이고요. 그를 통해서 올해는 꼭 성공할 수 있기를 기원하면서 열심히 준비하고 있습니다. 예, 그러면 여기까지가 저희가 생각하는 2단계에 새롭게 나아갈 방향이었고요. 세 번째로는 그럼 그 외에 우리가 어떤 또 다양한 활동을 하면서 우리나라의 CWR이 무엇이고 어떻게 인식을 확산시켜 나가고자 노력하고 있는지를 먼저 말씀드리면 국내에는 저희가 종자부전 전문 교육을 진행을 하고 있습니다. 종자 교육을 하면서 종자가 얼마나 중요하고 어떤 시설들이 있는지 그럼 실제로 뭐 초등학교부터 중학교, 고등학교, 대학교의 실습 과정까지 포함해서 도메스틱 국내의 교육을 진행을 하고 있고요. 실제 그래서 저희 부서의 연구원들은 연구도 해야 되고 심포지엄도 해야 되고 실은 이런 교육도 진행하고 있는 부분에서 많은 부분의 협조를 받고 있고요. 그리고 국제적으로도 저희가 매년 현지에 나가서 종자교육에 대한 부분, 수집에 대한 교육, 그리고 또한 현지의 보전안을 만드는 부분에 대한 노력을 하고 있는데요. 이 부분은 저희뿐만이 아니라 같이 도와주시는 다른 부서의 실장님이나 실무자들도 같이 나가면서 종자 보전뿐만이 아니라 그 현지에 맞춰서 식물을 어떻게 보존해야 되는지라는 부분도 같이 교육을 진행을 하고 있습니다. 그리고 저희 올해가 지금 이 두 번째 심포지엄입니다. 저희 이 심포지엄의 처음에는 저희는 야생식물 종자실인데요. 2023년에 와일드시드라고 해서 컨저베이션 종자보전 심포지엄을 처음으로 저희끼리 한번 시작을 했었고요. 2024년에 그러면 조금 더 키워보자라고 하면서 더 알리기 위해서 외국 연사 몇 분도 화상으로 하면서 이런 심포지엄을 계속 키워나가면서 사람들에게 우리가 하는 일이라던가 이런 CWR에 대한 부분을 알리고 있었고요. 지난해에 처음으로 이제 산림청과 한국임업진흥원의 큰 도움을 받아서 한수정과 같이 이 제1회 심포지엄을 열게 되었습니다. 그때는 정말 처음이었기 때문에 이것에 대한 정의를 먼저 알려드리고 각 나라들은 이것에 대한 어떤 프로젝트들이 있는지를 알려드리는 데 목표를 뒀으면 이번에는 말씀드린 것처럼 국제기구부터 수목원에 오기까지 그리고 농민과 함께하는 육종까지 해서 어떤 역할들이 각 파트별로 발달되어 있는지를 가지고 알리고자 했고요. 그렇게 되면서 저희가 처음으로 굉장히 큰 심포지엄을 준비했었고 저희가 올해 2회째로 작년보다는 좀 더 잘해야 되지 않겠냐라는 목표를 가지고 이번에도 또 열심히 준비를 했었습니다. 그리고 이번에 와주신 연사분들 중에는 이미 저희가 1회에 심포지엄을 했다는 걸 아시고서 또 흔쾌히 초청을 받아주신 분들도 계셔서 저희 하는 일들이 한 걸음 한 걸음 나아가고 있구나라는 것을 확인할 수 있었습니다. 그럼 이렇게 학술적인 부분이나 전문적인 부분에서 알리고자 노력을 했다면 저희는 수목원이다 보니 전시라는 부분이 계속 나아가고 있는데요. 2024년에 저희 백두대간 수목원에서 사명이라는 이 제목을 가지고 미래를 지키는 사람들이라는 부제를 가지고 저희가 하는 종자보전과 CWR이라는 주제를 가지고 전시를 크게 또 한 번 했었습니다. 이것은 특별 전시로 약 1년 정도가 열렸었고요. 그 부분에 오셔가지고 직접 이 종자가 무엇인지 만져보기도 하고 어떤 역할을 하고 있는지를 알리는 주요한 전시였다고 생각을 하고요. 실제 지금 화면에는 그때 당시 저희 실에는 종자 수집 팀장이었던 김혜진 시드보이트 센터장이 지금 화면에 나와 있습니다. 네. 그리고 그 외에도 저희는 종자의 국제 박람회라던가 산업 박람회 등 다양한 박람회를 참가를 하면서 이게 제품으로서의 어떤 가치 그리고 이런 식물 소재들이 어떻게 활용돼야 되는지 그리고 어떻게 보존하고 있는지를 지속적으로 알리고 있고요. 1년에 적어도 상반기 한 번, 하반기 한 번 나가면서 저희 하는 일들을 지속적으로 모두에게 알리고자 노력하고 있습니다. 자, 그리고 이제 마지막 이 부분인데요. 제가 실은 오늘이 오기까지 당연히 저희 보시면 와일드 플랜트 CD 디비전이라고 써 있는데요. 저희는 백두대간 수목원의 야생식물 종자실이고요. 올해 처음 2월에 워크숍을 했을 때 각각 업무별로 우리 올해 어떻게 발전하겠습니다라는 것을 저렇게 팀별로 전지에 써서 올해 이렇게 잘해보자라는 걸 가지고 왔고요. 저희 친구들은 실은 이때 쓸 때만 해도 심포지엄은 전혀 계획이 없었거든요. 그럼에도 불구하고 이 심포지엄을 만들기 위해 너무너무 노력해준 저희 아까 말씀드린 것처럼 스태프라는 검은 옷을 입은 저희 친구들에게도 너무너무 고맙다는 말을 하면서 발표를 마치고 싶습니다. 한번 저와 그리고 저도 너무너무 감사하지만 저희 친구들을 위해 힘찬 박수 부탁드리겠습니다. 감사합니다.
네, 너무도 좋은 발표 감사드립니다. 네, 오늘 이 CW 국제 심포지엄의 기원부터 그리고 한국 CW가 나아가야 할 방향, 그 계획까지 많은 것을 얘기해 주셨는데요. 사실 요즘에 K가 붙어서 안 되는 게 없더라고요. K-팝, K-뷰티, 또 뭐 K-푸드 이렇게 있는데 이제는 KCWR의 시대가 아닐까 하는 생각도 해봤습니다. 네, 정말 뜻깊은 발표였고요. 이렇게 해서 오늘 준비된 모든 발표 시간이 마무리되었습니다. 지금부터는요. 오늘의 마지막 순서 패널 토론 준비를 위해서 10분간 휴식 시간을 갖도록 하겠습니다. 네, 패널 토론은 지금 4시 48분이기 때문에 4시 58분 5시? 4시 58분? 네, 4시 58분부터 굉장히 정확하시네요. 4시 58분부터 시작을 하도록 하겠습니다. 네, 그럼 참석자분들께서는 4시 53분까지 이 자리에 착석을 해주시면 감사하겠습니다. 또 패널로 참여하시는 분들께서는 안내 요원의 안내에 따라서 지정 좌석으로 이동해 주시면 되겠고요. 잠시 여러분께서는 10분간 리프레시의 시간을 가져주시면 되겠습니다. 조금 뒤 10분 뒤에 패널 토론과 함께 만나 뵙겠습니다. 감사합니다. 네, 이제 잠시 후 5분 뒤인 4시 58분부터 오늘 심포지움의 마지막 주요 순서인 패널 토론을 진행할 예정입니다. 잠시 후 5분 뒤인 4시 58분부터 오늘 심포지움의 마지막 순서이자 또 가장 주요한 순서인 패널 토론을 진행할 예정입니다. 장내에 계신 분들께서는 이제 자리에 착석해 주시면 감사하겠습니다. 또한 복도에 계신 분들께서도 이제 자리에 들어오셔서 정돈하시고 착석해 주시면 감사하겠습니다. 이제 정말 마지막 순서만을 남겨두고 있는데요. 잠시 후 58분부터 시작하겠습니다.
근데 잘 못 쓰시는 분들은 받자마자 이 나오는지 안 나오는지 팍팍 하거든요.
질문이요. 여기 보면은 마이크는 저랑께 넘기도록 하겠습니다. 질문 딱 진행은 이렇게 할게요. 네네네. 네, 잠시 후 58분부터 잠시 후 1분 뒤인 58분부터 오늘의 정말 중요한 순서이자 또 오늘의 마지막 순서인 패널 토론을 시작하도록 하겠습니다. 네, 이제 복도에 계신 분들 또 장내에 계신 분들께서는요, 자리를 정돈하시고 착석해 주시면 감사하겠습니다. 네, 그러면 지금부터는 오늘 심포지엄의 마지막 주요 순서인 패널 토론을 시작하도록 하겠습니다. 네, 이번 패널 토론의 주제는 글로벌 정책 안에서 지속 가능한 활용을 위한 한국의 전략이 되겠고요. 좌장은 국립경국대학교 정규영 교수님께서 맡아주시겠습니다. 네, 패널로는 국내에서 국립수목원 최경 원장님께서 함께해 주시겠고요. 또 국외에서는 FAO, ITP-GRFA의 마리오 마리노 기술총괄님, BGCI의 칼리 코엘 사무총장님, IUCN의 나이젤 맥스티드 교수님, 존 이네스 센터의 노암 하유트 수석연구원님, 마지막으로 건터대학교 메콩연구소의 응우옌 흐우러의 책임연구원님께서 함께해 주시겠습니다. 오늘 발표에서 공유된 글로벌 정책과 국가 전략, 식물원 기반 보전, 작물 재래 원종 연구, 현장 활용 사례, 그리고 한국의 CWR 협력 방향을 바탕으로 심도 있는 논의가 이어질 예정입니다. 네, 그럼 정규영 교수님을 좌장석으로 모셨는데요. 다시 한번 큰 박수 부탁드리겠습니다. 네, 그럼 지금부터는 정규영 교수님, 좌장님께서 진행해 주시겠습니다.
예, 방금 소개받은 국립경국대학교의 정규영입니다. 작년에도 좌장을 봤는데 올해도 지금 좌장을 보고 있습니다. 걱정하시지 않으실 게 끝나는 시간은 정확하게 5시 반에 끝나도록 하겠습니다. 그렇게 생각하시고요. 오늘 크게 보면 이제 주제가 그 CWR 글로벌 정책과 과학가의 만남, 지속 가능한 미래를 위한 동행이라는 주제를 가지고 세 세션으로 구성이 됐습니다. 국제기구 역할에 대해서 마리노 박사님께서 말씀을 하셨고, 저기 쳐다보시면 한글로 영어 나옵니다. 그 다음에 벙이멈 대학의 우리 나이젤 박사님, 아주 그 CWR의 국제적인 리더시지요. 그것도 중요한 말씀 하셨고요. 그 다음에 칼리코엘 박사님이 그 만델라 얘기하셨던 이유가 남아프리카 공화국 출신이십니다. 오케이? 그래서 그 원래 유전학 원해학자이시고 보전 전문가이십니다. 그리고 이제 네 번째가 야생 미래 이용에 관련되어지는 내용으로서 노암 차유트 박사님 말씀을 하셨고요. 그 다음에 이제 그 이용 사례 부분 쪽으로 보면 베트남에서 그 후엥엔 훌러이 박사님께서 벼 품종까지 해서 이제 그 이용 부분 말씀을 하셨고요. 여섯 번째에 이제 우리 나채선 박사님이 그 한국의 CWR 현재와 미래에 대한 말씀을 해주셨습니다. 진행은 이렇게 하겠습니다. 먼저 오늘 토론자로 참석하신 우리 그 국립수목원의 최경 박사님께서 말씀을 해주시고, 그 다음에 플로어에 있는 분들 중에 질문을 받고, 그 다음에 이제 그게 되면 마지막으로 우리 그 연사들께서 그 발표하시면서 못했던 얘기, 그리고 한국의 CWR을 위해서 그 이렇게 좀 조언 이런 것들을 해주시면서 이렇게 마무리를 하도록 하겠습니다. 그러면 제일 먼저 우리 그 최경 박사님 얘기 듣도록 하겠습니다.
네, 안녕하십니까. 저는 국립수목원 최경이라고 합니다. 저도 아까 교수님께서 금방 말씀 한번 작년도 오셨다고 그러셨는데, 저도 작년에 여기 앉아서 이야기를 했던 것 같은데, 이번에는 사실 저희 원장님 안 계시는 바람에 그 제가 대신 왔는데 또 앉게 돼서 참으로 영광스럽게 생각하고 있습니다. 뭐 기회 된다면 내년에도 또 오면 좋겠다라고 생각을 했습니다. 오늘 이제 전체 그 심포지움에 대한 내용을 들으면서 먼저 오늘 이렇게 귀중한 발표를 해주셨던 이제 모든 연사분에게 감사를 드리고요. 전체적으로 봐서 이제 좀 제가 생각하기에 전체적인 어떤 그 이 발표에서 궤를 같이 앉는 게 아마 이 작물 재래 원종 CWR이라고 하는 것이 더 이상 특정 분야의 연구 대상은 아니겠구나라는 생각이 들었습니다. 대표적으로 뭐 CWR이라면 저희 뭐 밀이라든지 벼, 콩 이런 것들을 떠올릴 수 있을 거라고 생각이 드는데 저는 최근 들어서 그 그러니까 마트에서 판매하는 것들 중에서 보니까 퀴베리라고 하는 그러니까 껍질째 먹는 퀴라고 있던데 그거 보는 순간 저희는 우리나라에 있는 다래가 떠올랐습니다. 다래가 어떤 면에서 보면 CWR이라고 할 수 있을 것 같은데 다른 저기 호주에서는 그걸 또 품종 뉴질랜드인가요? 품종 개량해서 혁신이지 않습니까? 키위는 껍질을 까서 먹어야 되는데 털 때문에 이제 털을 없앤 작은 포도알 같은 키위를 만들어서 먹구나라는 생각이 들어서 저런 부분이라면 우리가 충분히 어떤 품종 개량까지도 갈 수 있는 가능성이 있겠구나라는 생각이 들었었습니다. 그런 면에서 본다면 사실 CWR이라고 하는 것이 뭐 생물 다양성 보존이라든지 혹은 식량 안보 또 기후 변화 그리고 미래 세대라고 하는 그런 모든 것들이 하나의 주제로 연결되고 있는 것이 아닌가라는 생각이 들었습니다. 오늘 전체 발표를 보면서 결국 이제 CWR에 대한 부분들은 하나의 메시지로 정의될 수 있을 거라고 생각이 되는데요. 보존하고 활용하는 것이 별개로 보는 개념이 아니라 사실 하나의 가정으로 봐야 될 것이 아닌가라는 생각이 들었습니다. 그걸 위해서 이제 필요한 부분들이 몇 가지 있을 거라고 생각이 드는데요. 첫 번째로는 이제 정확한 생물 다양성의 정보를 어느 정도 확보하고 있는가라는 것들이 되게 중요할 거라는 생각이 듭니다. 특히 이제 우리나라 같은 경우는 국토의 대부분이 산림으로 이루어져 있고 또 많은 CWR이 이 산림 생태계에 있기 때문입니다. 그래서 우리나라의 CW 전략은 우리나라 산림 생물 다양성 전략 정책과 반드시 함께 추진되어야 할 필요가 있겠다는 생각이 들었습니다. 또 두 번째로 생각이 된 것은 국제 기준과의 정합성이라고 하는 겁니다. 오늘 발표에서도 공통적으로 언급되었듯이 이 CWR의 보전이 한 국가만의 기준으로 하는 것이 아니라 국제사회가 함께 사용하는 기준과 방법을 적용해야 할 필요가 있다는 생각이 들었습니다. 우선 보존 대상종을 선정하고 또 위협을 평가하고 현지 내 보존과 현지의 보존 그리고 유전자원 관리까지 국제적으로 비교 가능한 체계를 만들어야 될 필요가 있다는 생각이 들었습니다. 그리고 이제 생각 드는 게 앞으로의 보존 범위는 종이라고 하는 그 자체가 아니라 실질적으로 유전적 다양성까지 확대해서 갈 필요가 있겠다는 생각이 들고요. 이건 지금과 같은 기후위기 시대에 같은 종이라도 서식하고 있는 지역에 따라서 서로 다른 적응 특성을 가지고 있기 때문이라고 생각이 들었습니다. 그래서 이런 유전적 다양성을 유지하는 게 미래 품종 개발과 식량 안보 측면에서 매우 중요한 의미가 있지 않는가라는 생각이 들고요. 그래서 자생지 보존과 함께 다양한 지역 집단을 장기적으로 모니터링하고 관리하는 체계도 같이 해야 되겠다라는 생각이 들었습니다. 실제 CWR이라고 하는 것이 결국은 이제 미래를 준비하는 뭐 유전 자원이 있고 또 보물이 있지 않겠나라는 생각이 들어서요. 기후 변화가 심화될수록 이런 지금 산림에 살고 있는 야생종에 대한 가치가 더욱 커지지 않을까라는 생각이 들었습니다. 근데 이제 이건 뭐 전체적인 대한 부분이고요. 전 개인적인 걸 조금 더 추가를 한다 그러면 아마 마지막에 나채선 박사님께서 발표하셨던 CWR에 대한 미래 우리나라의 어떤 그런 연구 방향이라든지 그런 부분들을 잠깐 언급해 주셨는데 요건 제가 조금 더 좁게 말씀을 한번 드려본다면 저희 그 자생종 중에서 식용 가능한 식물은 한 1000종에서 1100종 있다고 보고요. 아까 나이젤 박사님인가 말씀하셨던 것 같은데 그 근현종까지 해서 60% 정도라고 한다 그러면 한 2400, 500 정도 될 거라고 생각이 됩니다. 그래 따진다 그러면 단지 이제 종 단위에서가 아니라 지역별로 population, 개체군 단위에 대한 보존이라든지 배수체라든지 유전 다양성 혹은 복합 활용도 그리고 활용 중요도 아까 뭐 마지막 간다면 농부의 선호도 같은 여러 가지의 어떤 카테고리가 있을 것 같아서요. 그런 것들을 다 하려고 하면 전체를 할 수 없으니 어떤 타겟 스페시스를 정해야 되지 않을까라는 생각은 들었었습니다. 그래서 집중하는 식물들을 정해서 조금 더 심도 깊게 하는 연구도 필요하지 않을까. 그래서 평가의 기준을 정할 필요 있겠다는 생각이 들고요. 또 하나는 이게 어느 한 그룹이 할 수 있는 상황은 아니라서요. 식물원 수목원 네트워크를 충분히 활용할 필요가 있다는 생각이 들었습니다. 이 CWR 보전에 저희 식물원 수목원 네트워크가 참여를 한다면 만약에 이제 전체가 다 하지 않는다면 보유 시설의 어떤 단계 그 정도에 따라서 CWR 보존 가능 등급을 매겨서 같이 할 수도 있을 것 같습니다. 뭐 종자원을 가지고 있느냐, 현지외 보존원을 가지고 있느냐, 그 보존원의 크기가 어느 정도여서 어느 정도 이제 커버를 할 수 있는가 하는 그런 기준을 갖고도 접근이 가능할 것 같고요. 또 한 가지는 아마 얼마 전에 아마 식물원 수목원의 발전 방향에서 나왔던 부분일 것 같은데요. 국가식물 보존 수집 전략이라고 하는 부분들이 있습니다. 그런 그 전체 식물원 수목원이 같이 가는 전략 속에 이 CWR도 포함이 되어서 같이 가면 좋은 어떤 성과를 내지 않을까 싶어서 한번 제안해 드려봅니다. 네, 감사합니다.
예, 그 국립수목원하고 한수정하고 이 CWR 이 프로젝트 잘 이렇게 같이 한번 협력해서 진행되기를 기대하고요. 다시 한번 말씀해 주신 우리 최 박사님 박수 쳐주시기 바랍니다. 시간 관계상 몇 분만 플로어에서 질문이거나 멘트를 받고자 합니다. 혹시 그 자진해서 뭐 질문하거나 코멘트 하실 분 계십니까? 예, 마이크 자기소개 하시고 그 다음에 말씀해 주셨으면 좋겠습니다.
예, 저는 한국수목원 정원 관련 산림생물자원본부장으로 있는 우관수입니다. 장시간 우리 연사님들께서 좋은 발표해 주셔가지고 감사를 드리고요. 최경 우리 수목원장님도 말씀하셨는데 사실은 이 보존과 활용이 이게 잘 조화를 이뤄야 될 것 같은데요. 아시겠지만 CWR은 단순한 그 식물 자원을 넘어가지고 국가 식량 주권과 직결된 아주 중요한 미래 자산입니다. 근데 이게 활용 측면에서 사실상 우리 보존은 많이 하고 있죠. 우리 한수정에서도 시드 볼트에서 저장도 하고 있고 뱅크에서 이제 활용도 하고 있긴 한데 이게 국가 간에 사실은 저장하는 CWR이 각각 다르지 않습니까? 그래서 중요한 것은 전 세계적으로 봐서 이거를 서로 교류를 좀 할 수 있으면 좋겠는데요. 이 국가 간의 교류를 하려면은 뭐 여러 가지 문제가 고려돼야 할 걸로 생각합니다. 법적인 문제도 있고 이게 이동했을 때 생태적인 문제도 있을 것 같은데 어느 연사님께서 뭐 대답 뭐 하실지는 모르겠는데 이 국가 간 제 질문은 국가 간 CWR을 교류할 때 어떤 점들을 좀 고려해야 될지 그에 대해서 뭐 어떤 분이 답을 주시든 좀 주시면 감사하겠습니다. 이상입니다.
마리오.
It's work? Okay. Thank you, and thank you also for flagging this issue because it's quite relevant. As we heard before from the presentation of Dr. Na, I think that Korea in particular is in a very good track because you are using the standard material transfer agreement to exchange the crop-aware relatives inside your countries, among the different institutions of research, but also outside your countries. AFOCO, if I heard well yesterday, is going to exchange the material through the SMTA, the Standard Material Transfer Agreement. Another element that you have to take into account, because you were mentioning that you are doing a lot on conservation, less on utilization. I think that you are, building, I will say, the framework. Because only conserving and characterizing the material, you can utilize the material. at different levels, not only directly providing the material to the farmers, but also to provide this material to the private companies who want to commercialize this material. So my suggestion is also to accomplish the FAO international standard for conservation of PGRFA, and to see in case you have any possibilities to include in the National Biodiversity Action Plan in Korea, as well as in other countries that you are in contact with, to include and to insert in the National Biodiversity Action Plan the reference to the international treaty and the main concept about how to facilitate the access to the crop wild relatives, how to exchange the material, how to preserve the right to some extent of the providers of this material, in particular in your seed vault. So this is more or less what I have in mind to answer to your questions. And nevertheless, I think that we have to clarify the roles of the different stakeholders. The public domain here in Korea is really committed to support the work in conservation and utilization of the material, but this kind of, I would say, fortune doesn't happen in other countries. So your system can become a lesson learned for other work outside your country. Thank you.
Thank you. 예. 들으셨죠? 예, 예.
Just one sentence. I lead a gene bank that doesn't have a national border. I mean, we see ourselves as an international unit, and our remit is, I presented it, but I think once you use the SMTA, it really simplified. And if you want to become an international center for whatever remit you define, I think it's, I just want to second it, that it's the right path. And it doesn't have to be a national asset. It's an international asset for humanity.
네, 첨언하셨고요. 또 국제적으로 나가기 위해서는 여러 가지 생각 좀 하고 그렇게 접근하면 좋겠습니다. 또 플로어에서 질문하시거나, 예, 여기 그 소속 좀 밝혀주시고 얘기해 주시면 좋겠습니다.
Thank you. My name is Kiwan Kim from the Asian Forest Cooperation Organization. At first, thank you so much for all the panelists and then the experts for wonderful and valuable the presentation. I've also a lot learned from this international symposium. My question is very simple to all the experts. If specific country which is not familiar with the CWR concept, what kind of the capacity building program need to be for the specific country human resource? That is my question. Do you have some recommendation, specific the training module or capacity building program? I would like to appreciate it. Thank you.
Yes, thank you for that question. It's an important one. So if you remember on my presentation, which I presume you'll all have copies of after the conference, I divided the presentation into a series of points in arrows, different stages in progress. And I think almost every one of those requires skills and training how to overcome and go to the next step. So the training materials for those are all available. They're either available as straight training materials, or there are papers with methodologies showing how you can get from point A to point B. So one of the things we could usefully do as an end point to this meeting is annotate that with the appropriate training materials that are available. And I'm quite prepared to do that for my own presentation because I think it would be very helpful for the community here. But maybe we could organize that afterwards. So you mention a few examples at the moment. Like I said that for instance, in conservation planning, I gave the website where you can look at the toolkit for conservation planning, crop wild relative conservation planning. And it talks you through step by step how to do it and gives you the appropriate expertise so anyone could do it. So that would be, I think, a very good start. In terms of in situ management of populations of crop wild relatives, we've written a book basically, and that book is the guidelines to crop wild relative population management, and that's downloadable from the internet as well. So I can highlight that. What I'm saying is, I suppose, it's rather difficult because we have a large range of resources available. And if you ask specific questions, I can tell you what that resource is. But to make one list, it's not so easy. But I can at least annotate with the different steps and give you an introduction to the literature.
For ex situ, I think what Nigel mentioned yesterday in the discussion was that it's important not to reinvent the wheel. I'm not using your words, I'm rephrasing, because there's a lot of material out there. For ex situ, I think the crop trust, the global crop trust would be probably the best starting point, because they are engaged in training internationally. Yeah, that would be my suggestion.
Well, can I just add to that point? So I think Noam's right, but the team before they moved to the Crop Trust were at the Alliance, and when they're at the Alliance, we worked with them to actually write training materials for ex situ conservation, and all the training materials are still valid. It hasn't changed so dramatically since then. They're only produced, I think the last set was in 2016 or something, so it's only 10 years ago.
Thank you. If I could also add that BGCI has a lot of resources and training materials, but on the horticulture, the conservation horticulture side, so the development of propagation protocols, because we're talking crop wild relatives that maybe we're not sure how we're going to germinate or propagate. So there's a whole aspect there that fits in with the training from the ex situ conservation of crop species. But we're looking at species maybe unknown to us. We're collecting them from the wild for the first time. And something we also do with BGCI across our networks, we obviously have training materials, mostly in English, because we're UK-based, Spanish and French. But then when we look to our partner countries, we do a needs analysis of the specifics that they need. We look at the materials, and then we translate them into those languages that are needed, because it's very difficult. If I was going to learn something in Korean, I could tell you I wouldn't learn it very well. So we don't expect people to also then learn them in English. So we help with the translations. I think that's an important part of training, is that whatever material is delivered to the recipient in their language.
So, sorry, can I ask one last point, I think? Yeah, I just want to share the information about our activity work with Rob Church for the training material and also on the CWR project. And currently we have developed the interaction game-based website where the young agricultural student or the farmer can go for learn about the keyword of CWR. And this is also the model that you can personalize for the young generation, not on beside the training material, beside the book, beside the many knowledge by FAO or the other. You can try to change the weight that can be that can be suitable for the wide range of generation, including the young generation. I think young generation also important for the long term and sustainable development of agriculture. Okay.
Thank you. 특히나 이제 아포코의 CWR 참여를 기대하면서 우리 지금 백두대간 수목원에서 저기를 추진을 하고 있으니까 잘 상의하셔가지고 좀 적극적으로 참여하시면 좋겠습니다. 예, 또 예, 김지훈 교수님. So Korean wheat.
네, 또 국립공주대학의 김재윤 교수입니다. 앞에 분이 영어를 하셔서 저도 어쩔 수 없이 영어를 해야 될 것 같은데. Thank you for your great talk. I have a question to Dr. Noam Hout. Actually, I have two questions. Is there any actual or successful story where the wheat WR is has been interrupted the breeding program? That's the first question.
So did I understand correctly? You're asking if we have a case by which crop relative went all the way in our breeding system into a variety, right? Yeah. So the answer is, well, in the UK currently, breeders are not obligated to publish their pedigrees as they used to. So the answer is officially we don't know, but the answer is yes. So there are particles of crop. So of course, that's from the current project that I presented. We have material very close to the market, but not yet in the market. But there are, of course, examples of wild relatives that were used in wheat. I believe that YR15, the very famous resistance for yellow rust, came from an introgression that was done in Israel some 30 years ago. But these are decade-long projects. But there are a few examples of pre-breeding with wild relatives.
That wasn't quite his question. He was asking about heat resistance.
Heat resistance. Sorry. So I answered about pathology. Heat resistance. I don't think I have an example. I don't think so, actually. I don't know if there, I mean, it's hard to say no, but I'm not aware of an example for wheat. It's an extremely complex trait. You'd agree.
Yeah. So there is several papers that list all the different crop wild relative uses, and there's one by Dempenwolf, published maybe 5 years ago, and in it he lists different crops and different traits that the crop has used crop wild relatives for. And I know he has heat resistance in there. So there are definite examples in that paper. I'm sorry, I haven't got the reference in my head, but I know it's the lead author is Dempenwolf, and he worked then for the trust.
Okay, I have one more question. So actually, I believe the pan-genome study is a very powerful strategy for the wheat pre-breeding. So do you or your team has a plan regarding this?
So are you asking about pangenomics? So just using more than multiple references? Yeah.
So what I'm saying is using the pangenome study is go to the pre-breeding, CW pre-breeding.
So this is, I think it's more in the academic domain to this stage, but what we're doing with pangenomics is, I don't know how to simplify it, sorry. We're able to use, yes, so pangenomic is used to have more precise or better resolutions for the whole genome sequencing that enables us to find specific SNPs, and then, of course, it improves the genome-wide association studies, so it kind of speeds what we do, and maybe we can discuss it in detail later. So it can assist, it does assist pre-breeding now, but it's really in its infancy, I would say. Also genomic prediction, for example, they're not yet using the breadth of genomics. So if we have 600 million SNPs, still the industry usually use a few tens of thousands. So it's not yet in the resolution that exists in the paper. And really a role that we see as a gene bank is to mediate between. So some technologies are not probably yet relevant for the industry, even the advanced companies that we work with.
Thank you.
Did I answer?
Yep.
예, 못다한 얘기는 이따가
오케이.
저녁 드시면서 얘기 나누는 거로 하고요. 또 플로어에서 질문 있으십니까? 예. 홍선지 교수님. 짧게 질문. 누구한테 할 건지 정확하게 말씀해 주시죠.
예. 제가 아까 나이젤하고 칼리가 발표한 내용 때문에 그런데요. 대부분 정책 위반자나 폴리시 메이커나 아니면 폴리션들은 중복성을 되게 싫어합니다. 근데 지금 보타닉 가든이나 와일드 시드뱅크와 그다음에 크랍 진뱅크와의 일단 중복성이 오버랩이 상당히 많이 지금 생기는 사업이 CWR 관련된 사업인 것 같아요. 그래서 정책 위반자나 정치인들은 이 자리에 왔다가 인사만 하고 떠나요. 그리고 저한테 설명할 수 있는 시간은 보통 3분 내지 5분 정도만 허락이 됩니다. 그래서 이 3분이나 5분 사이에 가장 효과적으로 그 중복성을 설명할 수 있는 방법이 뭐가 있을까 한번 여쭤보고 싶습니다.
턴. 이제.
So what he means is, why would you have a separate gene bank for because wild material from crop material, and that's it's duplicating effort. So he's saying could we compare? I don't think I'm qualified to answer that question.
I can try. So there is redundancy, there is overlap, but the complementarity is bigger. And they serve different functions and they serve different industries. And I don't think we should change that. So gene banks serve the agricultural sector, the farmers and the breeders, commercial. Botanic gardens do conservation and research, and they serve conservationists. They should also serve the gene banks, but not directly with the breeders. That should be with the agricultural sector. And so if you're talking to a politician, and we are at the moment because there is this, there's the Nagoya Protocol on access and benefit sharing under the Convention on Biological Diversity, which doesn't allow commercialization, free commercialization of wild plant species. So it needs prior informed consent, and you need to show if there is a benefit that it goes back to the country. Maybe the country wants that. But there are some instances like Australia, New Zealand, and South Africa where the First Nations, Canada as well, it's the people and the local community where that crop wild relative comes from that should be getting the benefit and not to the government. So depending on countries, it's very complex. And we're trying to sort that out because what we need to do is make sure that our crop wild relatives and the genetic diversity is used as the examples we've seen to boost our productivity. Whatever, if it's phenology or heat resistance, we need to use the wild species, the wild genetics. And we can't be caught up in these politics, but at the moment, that's where we're at. Botanic gardens often can't interact directly with breeders, not all of them. I mean, there's over 3,500 around the world. So we actually need a system where we can track what's used and put the benefits where they belong. And the Digital Sequence Information Fund for sequencing is looking at that. So countries or breeders put money in the fund and they can use the genetic resources. And I think it's a cleaner way. But this is still under big discussion. In Armenia in October, we'll be discussing this again.
So I was just going to, it occurred to me when I was thinking, and good job you went first because it gave me time to think about the question. And so I thought of a reason why you might want to keep it separate. If you're a botanic garden, or if you're Kew Gardens and you have the Millennium Seed Bank, which has very large collections of crop wild relatives, the reason that they're justified in having that, or partly justified in having that, those collections, is because they have much broader knowledge of biodiversity of plant crop wild relatives. In other words, if you're doing that kind of research, like regeneration, then the breeding, the germination protocols, the protocols for growing the plants, making sure they don't get diseases or whatever, are very specific for certain species. So if you're just a general crop gene bank, then maybe you don't have such good knowledge. And for instance, I can give you a very good example of this. When I first started working in genetic resources, I was a plant collector for FAO, and I remember collecting a large number of perennial forage legumes. And I gave those collections to ICADA, and almost all of them were lost because they couldn't regenerate the material. And if you're collecting crop wild relatives, you often have small population sizes, so maybe just 10, 20 seeds. You need to bulk them up as your first step. And if you can't get them to bulk up correctly, then you're just throwing your material away and you've wasted all your effort in collecting it. So in that case, I can see a very good example why you would want to have that. But I do also think there is unnecessary duplication in some cases.
And of course, the flip side of the same coin is that if you're a crop expert, then you know how to look at diseases of that crop, and you would be able to use the wild relatives in a much more. Disease is one example. It's perhaps the simplest, because you would probably have the expertise needed to enhance utilization. But I think this is not a duplication of effort to have them in both places. I think it's actually it's a positive. It's a complementarity, I think.
예, 말씀 감사드리고요. 이제 마무리를 해야 되겠습니다. 그 발표에서 못하신 얘기거나 또 한국의 CWR의 발전 방향에 대해서 마지막으로 발표자들께서 돌아가시면서 한마디씩 해주시면 좋겠는데요. 그 제일 먼저 우리 마리오 발표하셨고, 그 한국의 CWR 발전에 관련돼서 좋은 말씀. 마리오, 그 다음에 나이젤, 이렇게 돌아가면서 한마디씩 하시고 마치도록 하겠습니다. First.
It's a very difficult question, to be honest. I have to admit that we were here speaking, but that at least this event is for us something that we can bring with us in terms of new approach, in terms of new style. I have to tell you, new style of in which South Korea is now coping with this challenge to become a hub for the entire continent. It's really a challenge, but to be honest, I think that you have the infrastructure. And what I would say in particular about crop wild relatives is a new there are a lot of expectations around the world about the use of crop wild relatives. Some of us started talking about crop wild relatives 20 years ago when no one was available to capture our messages, but now the time is arriving to start with this kind of cooperation and partnerships, in particular at the regional level. So my personal feeling is continue to work as you are working, and try to combine the wild plants with crop wild relatives and land races, and trying to manage the entire packages, not focusing only on CWR. That's my point of view. Thank you.
So okay, thank you. So I think I'm I'm very optimistic, but I don't want to think that it's going to be easy. I think it's not an easy process, but I think, as I tried to show in my talk, and perhaps the question indicates that my talk wasn't very good, because I was trying to show that we know all the steps, right from the beginning to the end, how to do them. It's not easy to achieve all those steps, and those steps will be learning and require getting skills and training, but most of all money. And that was my first intervention in the meeting was, where's the money coming from to do this? What is your plan for securing funding so you can actually take this forward? And I still am not absolutely clear, having listened to the whole symposium now, what is the answer to that question? I know you're trying, but frankly, I think you need to have a clear plan about raising money to actually achieve it. Because I think technically, we know how to do it. Or you can ask people who think they know, maybe they don't know fully, but at least they'll give you a start. So I don't think that the technical problems are too great. I think getting the money is the difficult issue. Sorry to be so crude about it, but I think that's the reality.
펀딩을 하기 위해서 대단히 노력을 하고 있습니다, 지금. Your turn.
I think on the back of what Nigel said, yes, show me the money. Where are we going to find the funding? But I think what I've seen now from yesterday's discussions and in the symposium is that you are a champion, and Korea needs to be that champion and to maintain the enthusiasm. It's enthusing all of us globally. And when people are enthusiastic, money can be attracted. We don't always have to go and look for it. When funders and governments see that people are working and there's dynamic effort, they give funding. And there are governments who are doing this, and private funders. So I think maintain that role as a champion and the enthusiasm. And I think it was said earlier that, we have K-pop. We should have K-food. Why not? So exactly what Mario is saying, look at crop wild relatives in their whole aspect, not just what part of the genetic diversity can be used to help enhance rice or wheat, but could it be an entire food crop on its own, a new one? There is a selling point. We can enhance the crops we've got, but why should we not just diversify? And having been here since my arrival, I have eaten so many different foods. It is blowing my mind, and I'm very excited because there's so much scope and potential. And I think going forward, that's what Korea needs to lead on, being that champion. Thank you.
Thank you. Your turn.
So I'll try not to repeat anything and just add perhaps after the story from Vietnam as well. That's building a stakeholder and a pool for the infrastructure and knowledge and everything that you're bringing together. So add this plan from the start, I think, would be a key to success, and also a key to maintain funding, because even if you have now a very generous government that helps with infrastructure, etc., there would be a day that someone would ask, what is the impact? What are we doing? So I think if from the start you have a roadmap, and that would probably the best way is by stakeholder engagement. That would, I think, would be a key for success.
Okay. Last.
Thank you so much. So I think there are many options from the speaker here, but I have one. Actually, want to say that the key for implementation the Silva project in Korea for the future, I think the first one is the data. I mentioned yesterday many times that we do not stop at the data can be created. We need to think the data can be accessed by more and more stakeholders, more and more people who need it. For example, Professor Kim, he asked about his tolerance of wheat, for example. So some people they need material, they need the information, but some place in the world they have a lot of knowledge about information that we need, but we don't know how to access this. So the access in data for and the material will be the key for implement and also the make the long-term impact in the I think in the future. And the second thing, I think because we need to secure our money, right? Our budget for the long-term project. Actually, for reading activity or the other related, it needs more times. It's not 1 year or 2 years, 3 years. It's more than 5 or 10 years because it's the long-term process. So to secure the fund, also the budget, I think we should think about a little bit about the socialization in the activity by engagement more and more stakeholders joining our activity. So that's why we can reduce the burdens in the budget. So that make us to do for the long term, for the to reach the long process. Yep, I think this is so. One more thing, one more thing that I really like the style for organize this current and also activity, and I think that the innovation will be the key for reach more people. For example, here in the morning, we hear about the CWR species, and we can try it and we can see it. This is the way we learn and we get more information about it. And in the afternoon, I enjoy the session that the student they showing the food for our of us here. This is the way we educate for the young generation, right? This is the innovation style. We make our long-term impact for the long-term benefit from the project we make for the community. Yeah, thank you.
예, 오랜 시간 발표와 토론해 주신 연사분들께 감사드리고요. 우리 뜨거운 박수로 이렇게 토론 마치도록 하겠습니다. 감사합니다.
네, 오랜 시간 함께해 주신 우리 전문가분들을 향해서 다시 한번 따뜻한 박수 부탁드리겠습니다. 네, 그러면 정말 긴 하루 동안 함께했던 심포지엄은 이제 마무리할 시간이 되었습니다. 오늘 아침에 정말 많은 비와 함께 꽤 어두운 하늘로 시작했던 심포지엄이었는데 어느덧 비가 맑게 개었더라고요. 그리고 이제서야 햇빛도 좀 보나 싶은데 심포지엄이 마무리되었고 또 하루가 끝나가고 있습니다. 이 하루 동안 우리는 CWR이 무엇인지, 또 CWR의 보전과 활용 관련, 국제적 통찰, 글로벌 정책과 현장 실천, 또 한국이 앞으로 나아가야 할 국제 협력 방향에 대해서 함께 논의했습니다. 긴 시간 동안 귀한 발표를 해주신 우리 연사분들, 또 패널 토론 함께 해주신 전문가 여러분, 또 끝까지 함께 자리를 해주신 모든 분들을 향해서 서로에게 박수를 쳐주시길 바라겠습니다. 네, 다시 한번 감사드립니다. 저는 끝으로 오늘 칼리코웰 사무총장님께서 해주신 말씀으로 마무리를 짓고 싶은데요. 인용해 주셨던 말씀으로 넬슨 만델라가 인생에서 가장 중요한 것은 살았다는 게 아니라 타인의 삶에 어떤 긍정적인 영향을 끼쳤냐는 것이라고 했는데요. 여기 계신 모든 분들 서로에게, 그리고 후대에게, 그리고 전체에 있는 사람들에게 정말 긍정적인 영향을 끼치는 사람으로 더 나아갔으면 좋겠습니다. 네, 이렇게 해서 오늘 우리가 했던 논의가 앞으로의 정책과 연구, 현장 실천으로 이어져서 미래의 식량 안보, 생물 다양성 보전에까지 기여하기를 기대해 봅니다. 네, 그럼 이상으로 제2회 산림내작물 재래원종 CWR 국제 심포지엄을 모두 마치도록 하겠습니다. 함께 해주신 여러분 정말 감사드립니다. 네, 나가시면서 잊으신 물건 없는지 다시 한번 확인해 주시고요. 즐거운 하루 마무리 되셨으면 좋겠습니다. 조심히 돌아가세요.